What is going on, guys? My name is Bucky Roberts, and welcome to your very first tutorial in C programming, one of the most popular programming languages in the entire world. And also, before I even start showing you guys how to code or what programs you need to get up and running, I want to mention this. Whenever you're watching these videos, make sure to watch them in 1080p and also full screen. And that's because I'm going to be recording my entire desktop. So if you're just on YouTube and you try watching it in that little video player, then it's not going to work out. So again, watch it in full screen, 1080, everything is going to be crystal clear. Now, I'm also guessing that you guys probably already know what C is used for, and that's why you want to learn it. Maybe you want to make like a computer game or something. But for those people who are just watching these videos and maybe they just want an idea of what you can do with C, it's basically used to make any software on your desktop, like all of these programs you can make in C. Also, you can make computer games, and you can pretty much use it to program any electronic, like robots, vending machines, stoplights. Your microwave could be programmed in C. So it's basically a very widely used programming language. The only thing that you really can't do with it is you can't like make websites. So if you want to learn a programming language to make websites, then I recommend checking out my PHP videos. That's probably a better place to start. So again, if you want to program robots, make computer games, and awesome software, then you guys are in the right place. So there are a couple of things that we need in order to get, up and running so we can actually code a C program. The first thing is, of course, a place to write the code. Now, you can just use anything like Notepad, or if you even have this basic Notepad right here. But look at this thing. It's like the ugliest program ever. I highly do not recommend this. So again, you need some place to write your code. And another thing that you need is a special program called a compiler. Now, what a compiler is going to do is it's going to take the code that you write and turn it into code that the computer can understand, the ones and the zeros. So that's the job of the compiler. So of course we need to download one of those because it doesn't come on Windows by default. So how are we going to get both those programs? Well, if you go to Google and you type in code blocks and hit enter, go to this website codeblocks.org. Now after you go to that, what we're going to do right now is we're going to download a piece of software, and it's actually completely free, which is freaking awesome. And this is not only the place that we write the code, such as it's like an awesome version of Notepad, but it's also a compiler built into it. So this one program has every single thing that you need, and like I said, free. How awesome is that? So go to downloads right here, and it's going to say, okay, you have to choose a couple options: the binary release, the source code, or source code from the SVN. What we want to do is just get the binary release. It's the most easiest way. And then of course it says, okay, what operating system do you have? Well, I am using Windows. If you're using something else, then choose your options down here. But I'm going to click Windows, and now I have one more option to select, and that's what piece of software do you want to download? This basic setup, this one that has this min-gw option, whatever that is, and this one with all of this stuff with some numbers after it. Well, I'll explain the different versions right now. What you typically want to use is this min-gw setup, and this first one right here is just the raw program. It's just the IDE, basically just the Notepad part of it. Now this next one, this min-gw, this is the compiler. It's what you need. My guess is that you don't have a compiler on your computer already. So download this one, and then after we write our code, it's going to allow us to translate it to a program that the computer can run and that we can test out. So again, you guys are going to want to download this one. And this is just a different version, and it says right here, later I read it earlier, but it's a new version and it might have some bugs in it. So this is the stable one right here, the IDE and the compiler. So I actually like to download it from SourceForge, kind of a tongue twister. So go ahead and click that link right there, And I hate these download pages. They're like one little thing and like 87 ads. But anyways, um, and this is probably going to take a little bit to download, so I'll pause my video and just unpause it when it's done downloading. Alright guys, so mine just got done downloading, so you can either double click this, or if you're not using Chrome, which you should be, then just go to your downloads folder. Mine is in Bucky. Where you at? Downloads. Downloads. And this is the piece of software that we just downloaded, the file that we just downloaded, should I say. So double click this, and it's, choose yes. It's pretty much going to take you through a wizard. Very simple stuff. Just click next. I agree. Let me just read this. Yep. Read all that. Agree. We can just select the defaults for anything. And install. Holy crap, that is fast. Alright, so this bad boy's installing, and once it's ready, and actually it puts icon on your desktop, which is actually really handy by default. Yes, I do. So this bad boy opens up, and it might take a while if you're starting it for the first time to boot up. And the first thing I actually want to do is minimize that, and well, I can click next, finish out of that, and I want to make a folder on my desktop. So new folder, and this is where I'm going to be putting all of my project files. So I'm going to put C underscore tutorials. And also I want to mention this, make sure that you just don't make a folder called C, because that is the name of your hard drive. So if you try to make another folder called C, then it's going to get confused. So again, anyways, just don't name it C. You know, it's probably self-explanatory, but heads up just in case you forgot. So once you got that taken care of, open up your IDE again, and okay, kind of overwhelming. So I want to show you guys how to get started. What we need to do is we need to create a new project. So you can either click this button right here, or you can just go to File, New, Project, whatever you feel like. And of course, we have a bunch of options. And what we want to select is this right here, Console Application. This is basically just a simple program for your desktop. It's not like for a phone. It doesn't have any weird settings or anything like that. So Console Application, and hit go, and it says, okay, a little alert, whatever, and it says what programming language to use. Basically, this piece of software can use two different languages. C++ is like, well, we're not learning it, so just go ahead and pick C, because, well, that's what this tutorial series is about. Click next, and it says, okay, the first thing is give a title to your project. And I'm just going to name mine, actually I'm probably going to be using this one for a while, so I'll just name it Bucky's program. Something stupid, probably the stupidest thing you can think of. And as you can see, the other stuff automatically fills in as well, the project file name and the resulting file name, and pretty much saying where do you want to save this. And of course, I want to save it in that folder that I just created. Click OK, and click next. All of this stuff is good by default, basically asking what compiler do you use, but whenever you download it, everything is set up perfectly, so don't mess with any of this stuff. Just click finish, and blank screen. We must have messed something up. Well, actually, if you go to your left, you're going to be able to see all your projects right here. So this is the name of the project that we just created, Bucky's program, or whatever you named yours. And all of the files that we have right now are in the sources folder. So if we click that little plus sign, we're going to see that it automatically created one file for us called main.c. So go ahead and double click this, and it's going to open up right here. So pretty much all of your files are going to be on the left hand side. This right here is pretty much your text editor, like Notepad. And up here are a bunch of settings that I'm not going to like explain every one right now, because it would be like the most boring video ever. So I'm just going to be explaining them as we need them. So basically, the first thing that we see is we get all of this by default, and this is actually a very simple program. Now, I know you guys don't know what any of this means right now, but I do want to show you guys how to run the program whenever you're ready. So we can actually run this right now by clicking this little button. It's called Build and Run, and it takes actually a couple steps to run your program. The first one is to compile it or build it. Pretty much take all of this code, the words that we understand, and it translates it to ones and zeros. Now, once you have that program or that file that the computer can run, you can click Run, or you're just going to be clicking this and it does it all in one shebang. So click this, it builds it, converts it, and runs it, and the final result of this program, it just prints out "Hello World" on the screen. So again, I know you guys don't know what all these words mean and why we're using all these symbols, but I just want to show you guys how to get up and started right now. And in the next tutorials, I'm going to be explaining what all this crap is and how we can, well, start making programs. And actually, before I let you guys go, the last thing I want to mention is in these tutorials, I'm going to be typing a whole bunch of source code. And if you guys just want to like sit back and watch the tutorials and then get the source code later on, I'm going to be posting all of the source code on my website. So if you go to my website, buckysroom.org, and if you click forum, then in the C section, get it? Anyways, if you just click that right there, then of course my source code isn't posted right now because I haven't typed anything yet. I'm just making the videos now. But all of the source code is going to be right here. Just click on it will be like source code for tutorial number 4. Click it. You can just copy the code, and boom, I'll give it to you guys for free. So thank you guys for watching, and well, I'll see you guys in the next video. Alright guys, welcome back to another video tutorial, and in this video, before we actually start typing a bunch of crap on the screen, we need to understand exactly how a computer program works. So let me explain that right now. Every computer program is made up of these things called functions. Now, the job of a function is just to tell your computer to do something. So again, a computer program is pretty much built of several of these functions usually. This one only has one, but let me go ahead and give you guys an example. Say that we want to make a program that'll watch a YouTube video for us. So the first function would be take your mouse and move it to this Google Chrome icon. Second function, click. Third function, click on videos. Fourth function, play a video or something. So again, as you can see, a computer program is made up of these pieces called functions. Now, right here, this one right here is actually a very basic function that's necessary for all C programs. And I'll tell you guys about the different pieces of this right now, just so we actually have an idea of what we're looking at. So pretty much, whenever you run a program, the computer is automatically going to look for a function called main. So you need to have this function no matter what. Now your function starts and stops at this curly brackets. That's how it knows what code goes in your function. So every line in between here is part of this main function. So let's take a look at these lines right now. So every single line is just a piece of instruction to tell your function what to do. And also, you probably want to take note of every line ends with a semicolon. That's how it knows to end this piece of instruction and go to the next line. So the first thing our program does whenever it starts is run main. And then it says, okay, well, what's in main? What do you want me to do? Well, the first thing is print text out on the screen. And I'll tell you guys more about how this works later on. But this is pretty much the line that prints text out on the screen. And that's why whenever we run our program, we see it says hello world. So that's what that line does right here. Now it has one other line. It says return 0. And for now, that's just kind of like the background of what's going on. How can I explain this? How your program and functions work. They need to return something, and it just says, okay, if you return 0, it means this function ran correctly. Sometimes if you have it return 1 or something, it means an error. But basically, if you return 0 to main, it means that your program is running A-okay. So that's what that line does. Talk about more on that later. Now the only other pieces we don't understand yet are these lines right here. These include lines are basically saying this. See, whenever you have a C program, the C language comes with a bunch of built-in functions by default. So this function right here allows you to print crap out on the screen like this. However, we need to tell our program to include those files so we can get those basic default functions. So right here, we're basically saying include a bunch of built-in crap that we can use in our program. This is our main function, the very first piece that runs, and the only important piece of instruction right now is printing text out on the screen. So that's basically what's going on behind the scenes. And another thing I want to mention is this: blank lines and indents and white space, it doesn't matter to your computer program. It's just for making your code more readable. So if you want to put enter a bunch of times, if you think that's more readable, if you want to press tab and put this way over there, it doesn't matter. It's just for, let me clean that up a little bit. It's just for the person, the developer, whatever is the easiest to see. So again, white space, blank lines, indents don't really matter. Again, every single computer program is made up of functions, which pretty much do something, and every single function is made up of lines of instruction to tell that function exactly what to do. So now that we understand how a very basic computer program works, in the next tutorial we're actually going to be getting our hands dirty and starting to actually code. But for now, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, welcome back to another video, and in this tutorial I'm going to be telling you guys how to do a very simple command, and that's just print stuff out on the screen. So of course, go ahead and delete this right here and give yourself some room to work with. I like having a blank line above and below. It makes it stand out, especially whenever I'm teaching. And of course, whenever we want to tell our program to print something, type in the word print F and then 2 parentheses. Now of course, every instruction we need to end with a semicolon, so go ahead and put it right there. And this is a command to tell our computer, like I said, to print something out on the screen, and the thing that you put in between the parentheses is the thing that you print out. Now, like I said, your computer can work with a bunch of different types of data, like whole numbers, numbers with decimal points, negative numbers. However, whenever you want to work with words or text, you need to include it, or excuse me, you need to put it in between double quotation marks. So do that, and then you can just type whatever you want to type, like Bucky is awesome. So check it out. This is good to go. We can now build and run that, and it says Bucky is awesome right on the screen. How freaking awesome is that? So now you're thinking that this program is probably the coolest program I've ever seen, but I want to go ahead and print another line. You know, got to enhance this program. So print F, do it again, semicolon, double, and what am I going to put? Bucky is awesome, and I'll put Bucky is cool. So then we're like, okay, gonna go ahead and build around this. Okay, that's kind of what I wanted, but I thought it was going to be on a new line. Well, the reason that this second one isn't on a new line is because we didn't tell our computer program to put it on a new line. All we said was print out Bucky is awesome, and then print out Bucky is cool. And what did it do? Oh, it printed it out on the same line. So in order to move things to a new line, you need to actually use a special character, and that's \n. Now this has special meaning in C, and it pretty much says go to a new line. So now whenever we run this, close this one, it's going to print out the first one, Bucky is awesome. In that new line, it's not actually going to print \n. It just knows to go to a new line and continue printing the other thing. And there are a couple of these special characters that you guys probably want to take note of. One of them is /t, and that just makes a tab. So it says Bucky is awesome, tab, Bucky is cool. And whenever you're making things like tables, tabs come in handy a lot. And I don't know if you guys are going to be able to recognize this one, but /a actually makes a sound on your computer. I don't know if my screen recorder can pick up the audio coming from my computer, but if you run this, I don't know if you guys heard that, but there was a beep I just heard in my headphones. This slash A is short for alert. It pretty much says play your computer's alarm, alert, or beep noise. So actually run this code in your compiler and you guys can hear what your computer sounds like. Alright, sorry guys, I had to pause the video. My family just showed up. There's like a town-wide garage sale today. So all came over to my house because I have like a an awesome location for a garage sale. It's like right in the village. So my mom and sister and my little cousin are here today. So if you hear any noise in the background, blame them, not me. But anyways, what were we learning about printing stuff out on the screen? So we learn how to do that. Basically, what right now our program is saying is print this out, play a beep on our computer, and then print this out. Of course, since our program runs real fast, it's gonna just look like it's doing everything at once. But that's what's happening right now. And another thing I want to talk to you guys about is comments, because you probably are going to be seeing these a lot, and I want to explain to you guys what they are so you don't get confused whenever you come across them. So a comment is basically just little notes that you can put in your program, and they're just notes for you to read. The computer, whenever it sees a comment, it ignores it. Your compiler doesn't care about it. It's just notes that you can have in there for reminders, or if you're working on program with other programmers, you can put little notes in there. So anytime you want to make a comment on multiple lines, you do this. Put two, well, I'll type it first. Pretty much your comment starts wherever you put / asterisk above the 8, and then you can type your comment in multiple lines, and then to symbolize the end of your comment, do the same thing but backwards. So asterisk / So again, the beginning is the / first, the ending is the / last. So then, that typically wouldn't be your comment. Your comment would be something like, this is my program. It prints out my name. It's awesome, or something like that. So you'll probably have them like above functions. You'll see them a lot, and it explains what the function does, or at the top of your program to explain what the program does. So again, that's a multi-line comment. Now, whenever you just want to leave a comment on one line, like a short little note, what you can do is you can add 2 / in a row. Now everything you type after this is going to be commented out, or it's going to be ignored by the computer. So you can say, these are the lines that print my name. So basically, whenever your compiler is going to build this program, the first thing it does is it rips out all of these comments, because it doesn't care about them. So that's why whenever you build and run it, it runs it the exact same way as if the comments didn't even exist. Just so you can pretty much make notes. Simple stuff. And also, whenever I put the source code on my website, I'll probably comment some stuff. So if you guys, I don't know, can't watch the video for some reason, then you guys can just read what each line does. Now, in the next tutorial, I think, since we're kind of running out of time, is I'm going to talk to you guys about something called conversion characters, and that is how to make this little piece printf statement a whole lot better. So I'll show you guys then, and thanks for watching. Don't forget to subscribe. Alright guys, now that we understand the basics of how to print crap out on the screen, I want to talk to you guys about how to make this print command a little more powerful using a special symbol called conversion characters. So remember I said that C programs can work with a bunch of different data types. It can work with numbers, whole numbers, numbers with decimal points, text, and also, I probably should have mentioned this earlier, but this data type, which is pretty much just a bunch of characters, these are called strings. Strings are things like words, maybe just, it could be one character string, but basically, whenever I say a string, that's what I'm talking about, a bunch of characters or words. So let's go ahead and delete all this because we don't need that anymore. And the first thing I want to do is make another printf statement, and this one is going to use conversion characters. So what is a conversion character? It's basically, like I said, a placeholder that you can use to put something in your string, let's say. So it's probably just easier if I shut up and type it. So the special symbol that we're going to use is %s. that means we're going to have a placeholder for a string. So we don't know what string is going to go in here yet, but some string is going to. So we'll say %s is the best person ever. New line. So basically saying, say some word is the best person ever, or some text is the best person ever. Well, now that we said make a placeholder, we gotta give it something to put in that place. So after your first quotation mark, if you press comma and add another string, then you can type something like Bucky, and basically what it's going to say is, okay, I'm going to use this string and say %s is the best person ever, but then I need another piece of information. What string do I use to put in this place? Well, after a comma, that's where you tell it Bucky is the best person ever. So if you build and run this, it substitutes that second string for that %s. So basically, anytime you see % something, it means it's going to get substituted out. And you can actually use as many of these as you want. So you can say %s is the best %s ever, and the first substitution is Bucky, and the next one is we'll say Bucky is the best programmer ever. So basically it says, okay, for the first one, use Bucky. For the second one, use programmer. So when you build and run this, Bucky is the best programmer ever. So that's the very basics of a conversion character. And I also want to mention that this %s is for strings only, for text, words, stuff like that. Whenever you're working with numbers, you need to use something else. So let's go ahead and build another awesome thing. So let's go ahead and say I ate %d corn dogs last night. Well, what %d means is it's kind of confusing. It means a whole number or an integer. So a number without a decimal point, like 1, 8, 12, that would be a %d. So, %d is not the easiest, letter to remember. But anyways, after this, you can go ahead and input a number like 9. Now remember, only strings or only text goes in between those double quotation marks. Whenever you're using numbers, they don't go in between quotation marks. So if you run this program, it's going to say I ate 9 corn dogs last night. Simple enough. So the last thing I want to mention is this. Whenever you use numbers with decimal places, you don't use %d. You actually use something called %f. Now, a number with a decimal place is called a float. Why they named it that, I'm not really sure. But that's what it is, and whenever you use %f, you can use something like that. Now, usually you have decimal places with a lot of decimal places after it. That doesn't even make sense. Numbers with a lot of decimal places after it. So whenever it prints this out on the screen, the default is to print 6 decimal places. So 141592. So that's why I say I ate that many corn dogs last night. However, if you want to format it to only show, let's say you only want to show 1 decimal place or 3 decimal places, you can have something like this. Actually, let's change this up a bit. It doesn't really make sense. Who counts the percentage of corn dogs they ate? So we can say like pi is %f, and then we'll go to a new line. Actually, if we just copy this because we're lazy, show you guys something cool. So print 2 more of those, and again, right now it just prints out 6 decimal places for every one. But like I said, if you only want to show like 2 decimal places, then what you can do is between the % and the f, you can press 0.2. Now what this is basically saying is show this float, but only show it to 2 decimal places. And we can do another one like 0.4. This will show it to 4. So again, if we run this, the first one is the default one, which shows 6 decimal places. Right here, we're saying only show 2. That's why it shows 3.14. And of course, pi to 4 decimal places is 3.141. And it actually rounds it for you, as you guys can see. So pretty freaking sweet. That is how you print stuff using conversion characters. And you're actually going to be using those a lot. And the reason that we do want to use those, if you guys haven't figured it out, you probably did, but it's for programs like you would put conversion character is the best person ever, and then let the user enter their name. So I would enter Bucky, and it said Bucky is the first best person ever. Someone else would enter Sally, it'd say Sally is the best person ever, and it allows you to customize a program. So I'm going to be showing you guys how to get user input from the user later on. But for now, thank you guys for watching, and I'll see you guys in the next video. Alright guys, welcome to another tutorial, and in this video I'm going to be talking to you guys about one of the most important concepts in C, and that is of course variables. Actually not even in C, but entire computer programming as a whole. So let's actually clean this up because we're done with this. And what a variable is it's just a placeholder for something else. Whenever people teach this, they try to make it sound so confusing, but that's all a variable is, just a placeholder. So you probably use these all the time in math class, and let me go ahead and give you guys an example. Now, also I want to point out that what I'm about to type is not computer code. I'm just showing you guys this is an example. So if you set x equal to meatball, and then you say I love x, obviously you can see the basics of what a variable is. This doesn't mean I love x. It says I love meatball because this x, you set it equal to meatball. So again, this isn't, computer code, but that's basically what a variable is. A placeholder for something else. Simple enough. So now let's go ahead and learn how to use them, how to write actual computer code that makes variables. Now, every variable you have, you're going to have to give it a name. And there are a couple rules that you're not allowed to do whenever you're making a variable. And if you break these rules, you're going to get an error because it's going to mess up your computer. The first thing is you can't start with a number or an underscore. So you can't have a variable called like 69 hot dogs, or however you spell it. You have to start with a letter from the alphabet, either lowercase or uppercase, but it's a common usage to start with a lowercase one. Now another thing is that you can't have spaces in your variables. So you can't have a variable named Bucky Roberts because that has a space in it. So again, no spaces, don't start with numbers, and also you can't have any weird symbols other than underscore. So you can't have like Bucky $6 signs and asterisks and that, and then Roberts. So basically start with a letter, no spaces, and well, just those basics I just told you. So now that we know how to name variables and what we're not allowed to do. Oh, another thing I want to mention, and this is probably common sense too, but make sure you don't name your variables any name as a function. So don't name your variables main, don't name a variable printf or anything like that, or else it's going to get confused. It's going to look at the variable like, whoa, are you like trying to run a function, or what the heck are you doing, idiot? So that's what your computer is going to say to you. Trust me, I heard it before. And well, now we can actually start typing them. So whenever we want to use a variable, the first thing we need to do is tell C that we're going to be using it, and this is called defining your variable. So how do we tell C? Well, the first thing we need to do is tell it what type of data we're going to store in it. Are you going to use this variable to store a word, a number? What are you going to do? So let's go ahead and say that we wanted to store an integer, a whole number. So type int, that's the keyword for int, and now type your variable name, and I'll put my age in there. So of course add a semicolon at the end, and it's basically saying, hey C, we're creating a variable, we're going to call it age, and it's going to store a whole number, aka an integer. So now whenever C runs across it later in your program, it's not going to get confused. It knows that age is a variable and it stores some value. So now we have a variable. How do we store a value in it? Well, all we do is, it's actually really easy. Type the name of your variable, and in this case age, and put an equal sign and set it equal to some integer, such as my age is 27. So basically we created a variable and we stored the value of 27 inside the variable age. Now whenever our computer sees this word age, it's just going to treat it as the number 27. So let's go ahead and do one more thing. Printf on the screen, and we can say Bucky is %d. Remember, this is an integer, %d, and we'll say years old. Now for the conversion character, we can just put age. We don't need to put the number 27 itself because this age is pretty much viewed as that value. So run this bad boy, and it says Bucky is 27 years old. Pretty sweet, and of course we can change this later on. So when I'm old, I can change this program to say 65. Bucky is 65 years old. Boom, shebang, pretty stinking sweet. Now, another thing that I want to teach you guys is that you can also use simple mathematical operations with variables instead of just putting a basic number in there. So instead of just writing 65, you can have your computer figure it out. So you can say Bucky is 2014 minus 1987. So if I run this, it's going to say Bucky is 27 years old, because what it did is it said, okay, for the value of this variable, perform this calculation. So 2014 minus 1987 equals 27. So store that answer in the variable age and then print it out on the screen. So if we wanted to get really cool, what we could do is something like this. We could say, okay, let's have a variable for age. We'll have a variable for current year, and we'll have a variable for birth year. So if you had no idea how old you were, you could run a program like this to figure it out. So basically we have three variables: age, current year, and birth year. Now for current year, we could set that equal to 2014. For birth year, set this equal to 1987. And for the age, what we can do is this: take the current year and subtract the birth year. So basically what it's going to do is, since this already has a value of 2014 and this is pretty much 1987, it's going to take this variable, subtract it from this variable, and store the answer in the variable age. So pretty sweet. Now whenever we run it, check it out. 27 years old. If you're running, alright, what if I was born in 1963? Well, then I would be 51 years old. I always wondered that, and now I know. So that is basically a real quick introduction to variables. Again, all they are is placeholders for something else. And in the next tutorials, I'm going to be showing you guys how to use different types of variables and some other awesome things that you can do with them. So thank you guys for watching. Don't forget to subscribe. And again, remember, if you want any of this source code, I'm going to go ahead and post it on my forum so you can get it then. So thanks for watching, and I'll see you next time. Alrighty guys, welcome back. And in this video, I want to talk to you a little bit about something that happens behind the scenes whenever C actually makes a program in strings specifically, and it's called the string terminator. So it's actually not as cool as it sounds, but it is pretty cool, and I'll show you guys what I'm talking about right now. I'm just going to type Bucky Roberts right here, and of course we know that this is a string. Now whenever C makes your program and compiles it and runs it, what it actually does is it needs to know where the end of the string is. And this is just for memory management. It's not really important, but what it does is it adds a special character to the end of your string called a string terminator. So what this is it's basically just a special symbol, and of course we don't actually print this out, or the user actually never sees it, but it is there to just tell C this is the end of the string. The next piece of memory is you can like store something else in there. Now why I'm mentioning this, you're like, alright, why are you even telling me? Because the user never sees it, we don't have to put it in there manually, so what's the point? Well, the reason I'm mentioning this is because whenever you're doing stuff like calculating the length of strings or calculating how much memory you're going to have to set aside to store a string, you need to include that as well. So in order to determine the length of strings, it's every single character, and this white space, every single piece of white space actually counts as a character too. and you have to add that string terminator. So let's see how much memory we would need for this string. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it has 13 characters, including the white space, and we would need 14 bytes. And of course, that one extra one is for the string terminator. So if you ever see that little issue, or if you're like seeing how many bytes the strings hook up and it is kind of off, that's why. Now, now that you understand that, I want to mention something else that might be kind of confusing. Whenever you create a string like this, you're actually not creating one big chunk of memory. You're actually creating something called an array. Now, an array is it's pretty much just a list of items of the same data type. And what I mean is you can have a list of integers like 8, 20, 34. You can have a list of characters like A, B, C, D, E. And what this string is it's actually a character array. So what the computer sees is just a list of characters. It sees a B and then a U and then a C, K, Y, space, so on and so forth. And this is actually important because we can do pretty cool things with arrays. So let me go ahead and create a simple program now. And I'll show you guys how to actually create an array. It's different than the strings we've been using before. So anytime you want to create an array, you first need to tell C what type of data you're going to use. So of course, with a string, it's a list of characters, and that's char in C. So the next thing you need to do is you need to give a name. Pretty much like you name variables, you need to name your array. And I'm just going to store my name, Bucky Roberts, so I'm going to name mine name. Now, right after this, go ahead and press those brackets that are next to the P on your keyboard, or at least they're next to the P on mine. And in between these brackets, we need to tell it how many bytes this string is going to take up. Now remember, my name, Bucky Roberts, with the space included, it's 13 characters. However, we need to set aside some space for the string terminator at the end. So I'm going to put 14 right there. So basically we said we're going to create a list of characters. It's going to be called name, and it's going to hold 14, or pretty much set aside 14 bytes of memory for this. And then, just like a variable, we'll set it equal to Bucky Roberts. And of course, everything ends with a semicolon. So now what we can do is pretty much just print this out like printf. And of course, what are we going to put? My name is, I'll just put, keep it simple, %s, and I'll put that on a new line. Now after this, of course, like I said, just go ahead and type name. And when you run this, hopefully, it says my name is Bucky Roberts. Pretty sweet. Alright, so why the heck would they make this like this programming language where you need to make a list? Why didn't they just put string name equals Bucky Roberts? Wouldn't it be easier? Well, the cool thing about this is pretty much that you can do a lot of things, or a lot more things, with an array or a list of items. And let me show you guys what I'm talking about right now. So first of all, I want to show you guys how to access an individual item or element, as they're called, in your array. So why would they even make this programming language to use these stupid things called arrays, where they're pretty much like a list of items, other than just making a simple string type where you can store a string into? And the reason for that is because you can actually do really awesome things when you have a list of items. So the first thing I want to show you guys is just how to access an individual item in that list or the array. Now, in order to do that, you just go ahead and type the name of your array, which is name. Probably should have named it something else because I'm saying name like 80 times a second and it's probably confusing, but you get the idea. So type the name of your array, which is name, and then in the brackets you can type it's pretty much the position of the element that you're looking for. And I'll go ahead and put 2. Now I want to mention this. Whenever you create a list or an array in C or any programming language, it always starts with 0. So you would think that, okay, B is 1, U is 2, so would print out U. Well, actually, it goes B is 0, U is 1, C is 2, So this little piece of code right here is actually equal to C. So then we can do something stupid like set it equal to Z. And of course, whenever you're using characters, put them in between single quotes. And what this is going to do now is say, okay, get the character that's at 2 position, which is 0, 1, 2, which is C, and set it equal to Z. So now my name is going to be B-U-Z-K-Y, so Buzzkey, which is actually a pretty cool name if you think about it. Alright, so let's just go ahead and print this out now and see if it worked. Alright, so the first one, of course, the original thing we wrote is just my name is Bucky Roberts, simple enough. Now whenever we changed the second element in the array, and of course, like I said, each item in your array is called an element technically, but I'll probably say item just because, I don't know, it like makes it sound more like a layman's term or whatever. So of course we replaced it and it says Buzzkey Roberts. Now another thing I want to teach you guys how to do is an alternate version of having to type these manually. So what you can actually do is you can define an array kind of like you define a variable. You can set its definition earlier and then you can give it a value later on. Now whenever you do that, you need to explicitly say how many bytes of data you're going to be holding in that array, because whenever your program creates an array, it needs to set aside memory right then and there. So if we define it, say, hey, take up this much space on the computer. However, when we just define it and then give it a value on the same line, we actually don't need to explicitly say how many bytes, and the reason for that is this. So let's go ahead and make something else. I'll put food, and I'll set this one equal to tuna, greatest food ever. Now like I said, the reason that you don't need to explicitly put 5 right here is because whenever it runs this line, it can just go ahead and count the characters for you. So it counts them, says okay, store 5 bytes bites of tuna. Anyways, and it's going to store tuna in food. So now I'll show you guys some cool little tricks. So this line right here is going to print out tuna, and I'll prove it to you guys. Nope, it didn't, because I put name instead of food, and we actually should change this. Best food is tuna. Pretty awesome program so far. My name is Bucky Roberts. My name is Buzzkey Roberts. The best food is tuna. Gonna sell this bad boy to Microsoft for millions. Now, the last thing I actually want to mention that I wanted to show you guys is whenever you want to assign a new string to this array, then what you do is a little bit different than a variable. If it was just a variable, you put the variable name and set it equal to a new value or whatever. However, when you do it with an array, what you have to do is you need to use a function called strcpy. Now this is going to take 2 pieces of information. The first one is it's pretty much you have to tell it what array do you want to change. Well, let's just go ahead and change the food array. Now put a comma, and the next piece of information is what string do you want to store in this array now. Well, let's just go ahead and change it from tuna to bacon. So now the food array equals bacon instead of tuna. So if we print out this line, print that bad boy. Of course you can see the original one, the best food is tuna, and it changed the best food is bacon because we switched, or pretty much we gave the array of food a new value. So hopefully you guys understand about string terminators and how your computer actually needs to set aside memory and how we can take advantage of those by creating arrays and doing some cool things with arrays. So again, I know it was kind of confusing, and if you have any questions, ask me on the forum. I can answer you, or a bunch of people are also willing to help you. So for now, thank you guys for watching, and well, see you later. Alright guys, welcome back, and in this video I'm going to be talking to you guys about these lines at the very top of your program, and they're technically called preprocessor directives. Now, you know how I told you guys like in the first video that the reason that we download this piece of software is not only so we can type code in it, but also one of the jobs of this piece of software was basically to take code that we can understand, of course, we can read this. This is the word include main, and it pretty much translates it into ones and zeros, or in other words, code the computer can understand. Now, this process, the technical term for it is compiling your program. So, what these lines are and why I even mention that is because before your program compiles, what it does is it includes or pretty much runs your preprocessor directives. Kind of a tongue twister. But basically, it's going to grab the entire file wherever we tell it to. So it's going to grab stdio.h and stdlib.h, and it's going to substitute them in place right here. Now, after all your preprocessor directives are finished completing, then it's going to go ahead and compile your program. And also, like this one right here, this stdio stands for standard input output, and that's what allows us to use that printf because it outputs stuff on the screen. So again, what this include does is basically include another file with, well, whatever we want to put in it, and I'll actually show you guys how to make your own file in just a second. Now, another preprocessor directive you can use other than include is actually one called define, and I'll show you guys how to use that right now. Pretty much type in the I call it hashtag because I'm stupid Twitter now, but the pound sign, hit define, and what a constant is basically, it's kind of like a variable, but its value can never change. So whenever you have a variable like tuna, you can set it equal to 21, and then later on you can set it equal to 32. Well, with a constant, you can't change its value. You set it once in your program, and it stays that way forever. So if you want to, I don't know, just make a stupid constant, just to show you guys an example called my name. And also, whenever you're making constants, make sure that you make them in all uppercase letters. And this is just so you can easily distinguish a constant from variables in your program. It's I don't know, it's just like something all programmers do. So of course, type the name, whatever you want to name your constant, and then after it, its values. So I'll just say my name is Tuna McButter. And another thing I want to point out is that you don't need a semicolon at the end of any preprocessor directive. So now, basically what's going to happen is anytime we have my name in our program, might as well use it. And what are we going to put? Something stupid like me name b, and we'll just write my name right there. So basically, what this preprocessor directive is going to do is it's going to search your program right here, and it's going to look for any instances of the word my name and replace them with the string Tuna McButter. So now, if we run this, it says me name be Tuna McButter, and of course, it did all of that before your program started compiling. So now, let me go ahead and actually show you guys how to use these in a useful kind of way. So clear this out. And clear this out as well. And I want to show you guys how to include your own custom made header, and we'll actually use one of those constants because why the heck not? So the first thing we need to do if we want to include another file is, well, create a new file. So if you go to File, New, Empty File, and it says do you want to add it? Yes. And now you pretty much just give it a name. I'm going to name mine Bucky's info, and you also want to put .h. It's just a header file, and it's just I'll explain to you guys about the different types of files later on, but whenever we're including this, give it a .h extension. It means something special to see. So hit save, and then it says okay, pretty much, do you want to add it? Yep. And another thing I want to mention is that whenever we named it .h, what it means to see is a header file. So it creates a new folder called headers, and it organizes pretty much all your header files for you by default, which is pretty sweet. So now we have two files in our program. This first one, of course, is the one main.c, the main one we've been working on the whole time, and we also have this new bucky's.info.h. Now, also take note of these other header files we include were also .h, so in case you didn't notice that. Now, in this one, remember, what's going to happen is any code that's in here is pretty much going to be copied and substituted right whenever we write our preprocessor directive. So we can write something like, let's just go ahead and define a couple constants. So define my name, and I'll put my real name this time. No more of that tuna McButter or whatever the heck his name is. And I'll just go ahead and define age 28. So now, and we actually don't need to save these because whenever we build and run, it automatically saves all your files for you. So pretty cool. You can do it the lazy way. So now we have a little bit of code in this Bucky's info.h, and let's go ahead and include it in our main program. So copy this, do it the lazy way, and also delete your entire stdlib piece of code right now. And as you can see, this header and this header are brought in using the brackets. And whenever you use brackets, it pretty much means search the default place where headers are. But we can use double quotes, and double quotes means search in the same directory or the same folder is our code, and it's just a little bit faster way to bring it in. Don't really worry about it right now. And of course, type the name of your file. So again, it's going to include this one, and then it's pretty much going to copy this and paste it right in here. That's like pretty much what it does, actually. I should probably use that analogy earlier on. And then it runs your program. So now that we have this info brought in, let's make a cool program with it. I'll show you guys how to make a program that calculates the age of girls I'm allowed to date. So I'm like, alright, am I allowed to date a girl who's like 24 if I'm 28? Well, I don't know. What about a girl who's 17? Probably not. So you know the formula for it is this. Go ahead and make a variable called int girls age. And the formula for this is actually, and I'm going to do some math, and I know I didn't talk to you about the mathematical operators of C yet, but you guys will understand this. You take the age, and this is my age, which is 28, and you divide it by 2. Of course, to divide is just forward slash, and I'll talk, like I said, talk about that later on. So now, of course, this is 14 for me, and you take that and add 7. And that's the age of girls anyone is allowed to date. So go ahead and think of your age right now, divide it by 2, and add 7. Don't date any girls younger than that. So this should equal 21, I believe. So now let's just go ahead and add a print statement. Don't need to do anything else. So I'll just put something like S, which would be my name, like Bucky Roberts, can date girls who are actually girls do this percenti or older. And of course now we need to give it those pretty much like pieces of information it asks for, and this is what I name it, age, or the first one is my name, and the second one is girl's age. So let's see if this works. Alright, so Bucky can date girls 21 or older. Alright, I am fine with that. Gotta go find me some 21-year-old hottie now. If anyone's listening, give me a call. Alright, so I'll talk you guys through this one more time real quick, just so it sticks in your brain and you're pretty much a pro with it. What we can do is we can write our own custom header file, and any code we put in here, as our program runs, it pretty much grabs this file, copies all the crap in it, and pastes it right here. And then your program compiles. In our program, what we did is we took my age, divided it by 2, and add 7 to that value, and it gave us the girl's age that you're allowed to date, and I got 21, so I'm going to pause this video, go find some 21-year-old hottie, and I'll see you later. What's up, guys? Welcome back, and in this video what I'm going to do is I'm going to teach you guys how to get input from the user, how to have the user type in things on their keyboard and get that information and use it in your computer program. It's going to be pretty sweet. So let's just go ahead and make a simple program just so they have something to type in. I'll have them like type in their name and the name of like their crush, and it'll be like, hey, you're going to get married to this person. It'll be pretty cool. So let's go ahead and, don't even got my mouse in the right place. we'll just go ahead and make a couple strings first because, of course, they're going to be storing their name in a string. So I'll just put that as a first name array, and we'll give them 20 characters to work with. That'll be long enough unless anyone has a real long name. Another thing is crush, which is going to be the name of their crush. Mine is Rachel McAdams. Gonna get married. And the last one is int number of babies. We'll say how many babies are they going to have. Now, the reason I want to have a different data type is because you actually have to treat this a little bit differently, and I'll show you that later on. So basically, the first thing we want to do before they type something in is we always want to give them a prompt. So that way, it's like, hey, type your name on the screen. If we just have a cursor blinking on the screen, they're not going to know, am I supposed to type in a number, my name, what the heck? So let's just go ahead and add a simple printf. And we'll say something like, I don't know, what is your name? And might as well pump that on a new line. Now, the function to allow the user to input information is scanf. Now, this is actually really similar to printf in a lot of ways, so you guys are probably going to like it. So the first parameter it takes is, of course, a placeholder which they are going to fill with whatever they type into the keyboard. So since they're going to be typing a name, we need %s because that's going to be a string. So the next piece of information is whenever we get this input, what variable do you want to store it in? Well, the first thing they type in, the string, is going to be their name, so we're going to store it in first name right there. So basically, like I said, whenever this line runs, it's pretty much going to be a blinking line on the screen, and whenever they type in something like Bucky and hit enter, it says, okay, now store the string Bucky in first name. So then we can just print it out and use it as a normal variable, just like we've done for the last like dozen tutorials or whatever. So I actually can copy this because I'm lazy. And the second question is, how are we going to say it? Like, who are you going to marry? And of course, for this one, you want to store in the crush array. It sounds like you want to smash something, but basically, it's going to do the same thing. And the last one, and the reason I needed int is this. We're actually going to use, well, we can actually copy all this. So for the last question, we'll just be like, how many kids will you have? Now, of course, since they're going to be entering a number, we don't want to store that as a string. We want to store that as a %d for integer. And for crush, of course, let's change that to number of babies because that's the variable. Now, one thing that you need to pay attention to is this. Right before number of babies, right before the n, go ahead and hit the ampersand, the symbol above the 7 on your keyboard. And you guys are going to understand exactly what the symbol is when we talk about pointers later on. But for now, just remember this very general rule. You need to use that ampersand symbol before every single variable except arrays. Arrays have pretty much a built-in ampersand. I know I didn't talk to you guys about pointers yet, but that symbol's already built into an array, more or less. So anytime you use a float, a character, an integer, you always want to put ampersand right before the variable name, or else it won't work. Your program will crash. If you don't believe me, try it out. So now that they entered, definitely don't want to do that. Alright, so now we have all of the information stored inside these variables, so let's just go ahead and print something out on the screen. So printf, and this will just verify that we have everything in there correctly. So we will say something like %s and %s are in love, and we'll have %d babies. And of course, this will fill with the first name, and then the name of your crush, and what's this? Number of babies. So hopefully, if we didn't forget any semicolons or anything, we can run this and check it out. And I want to note one other thing. Before we learned this tutorial and how to use a scanf function, our program basically ran all at once and then said, okay, return 0, good to go. However, whenever we use scanf, what's going to happen is our program is running line by line from the top down. So it's going to say printf, what's your name? And that's what you see right here. But when it gets to scanf, it pretty much pauses your program and it waits to continue it until you type in something. So this isn't only a place to allow the user to type in, it's basically pausing your program and waiting for you to hit enter to tell it to continue. So what is your name? I'll hit Bucky, hit enter. And also another thing I want to point out is my crush is Rachel McAdams. However, whenever you use a space with scanf, it thinks that it's the end of the string. So never use spaces. Just go ahead and type in one word, Rachel. If you want to like make a program to have a first name and a last name, then you're going to need another variable. So you would put something like crush first name, crush last name. But for this simple program, can't talk. That's what we're doing. So Rachel, hit enter. Now Rachel is stored in crush. And how many kids will you have? I'll just put, something small like 53 and hit enter. So now it says Bucky and Rachel are in love. She does love me. And we'll have 53 babies or more, probably more. So hopefully you guys understand how to use scanf. Again, it's really similar to printf. This is how to pretty much give information to the user by displaying it on a screen. And this is how to get information from the user. And also, remember this, use the little ampersand sign before every single variable, except when you're using arrays, you don't need it. So, well, that's it for this tutorial. Thank you guys for watching, and I'll see you next time. Alright guys, welcome back, and in this tutorial we're going to be learning about the mathematical operators. Because if a computer is really good at one thing, it's math. It's pretty much the best calculator in the world. So, well, let's just go ahead and get started. Now, we already saw in a couple examples before, I think I added some things and might have subtracted some stuff. But let me go ahead and just make a little variable. And my cursor's messing up at the beginning of every tutorial, like usual. And I'll just name it weight. And I'll put my weight in there, set it equal to, of course, my weight, which is 595 pounds. Now, let's just go ahead and print out something real quick so we can start testing these bad boys. And I'll put, if I eat a watermelon, I will weigh, not weight, weigh, and we'll put something like %d libs. Now after this, of course, what we can do is we can just go ahead and put a variable name in, but I also want to mention this. What people can do, and I don't really see this a lot, and it's really useful, is they can actually write an entire equation in place of just a variable name. So you can put something like weight plus, I don't know, what's the weight of a watermelon? 12 pounds, maybe? I don't freaking know. So what this is going to do is it's pretty much going to calculate this expression right here, which is 595 plus 12, and then output it on the screen. Let me pump that on a new line, and my old program's still running from the last tutorial, and run this bad boy. So apparently, if I ate a 12-pound watermelon, I'm going to weigh 607 pounds. Simple enough. So we saw that we can add using the plus sign. And another thing that we can do is subtract. Of course, to multiply, it's the asterisk. It's the little symbol above the 8 on your keyboard. To divide, it's the /. It's, I don't know where it is on your keyboard. It's next to the shift on my keyboard. And one other thing that we can do is actually this one right here, the %sign. Now this is called the modulus, and let me show you what it does. So this doesn't really make sense because, if I eat a watermelon, I weigh 7 pounds. So you're wondering, how the heck did it get 7? Did it divide by something? Well, what the modulus is the remainder whenever you divide. So whenever you divide 595 by 12, you're going to get some number, and you're also going to get a remainder of 7. So whenever you want that remainder, again, use the %sign. It's called the modulus. Now, let me go ahead and show you guys something else. And this is probably going to help a lot of people understand why they're getting some different values in their program. So let's go ahead and make a few numbers. A, and we'll set this equal to 86 or something. And B, set equal to 21. And then we'll just go ahead and print some crap out. And might as well just print like, I don't know, keep it simple, I guess. So we'll print out the result of an equation, and that's A over B. So why the heck am I telling you that? You know, we already learned that you can put equations in there, no big whoop. But check this out. Let's say that we had a float as well, and let's just name this like C or something. So float C, set it equal to 86.0, and float D, and we'll set this equal to 21.0. So let's just copy this bad boy, and of course we're not going to use %d, we're going to use %f, which means print out a float, and we're also going to use C and D, CD. So what I want to talk about right here is this. Whenever you're using equations in here like this, and you're dividing numbers, whenever you divide an integer by another integer, check it out. The result is going to be an integer, 4. Now whenever you take a float and divide it by another float, the result is going to be a float. So that's going to come in handy later on whenever you guys get a bunch of bugs. And also, if you guys are like, alright, I'm dividing 86 by 21 and I know it's not an even number, so why the heck is it giving me 4? Because, you know, 4 times 21 is 84, so what the heck? So just remember that, because if you don't, you're probably going to come across some trouble in the future. So whenever you want a float result, use float numbers. Whenever you want an integer result, use integers. Simple enough, easy to remember. So for now, that's it. In the next tutorial, we're going to be talking about the order of operations, and also I'm going to be showing you guys a cool way to assign values to more than one variable. It's going to be awesome. I'll see you then. Alright guys, welcome back, and in this video, as promised, I'm going to be talking to you guys about the order of operations in parentheses and how to use it whenever you're working with C programming. So let's go ahead and might as well get our hands dirty, and I'll show you guys exactly what I'm talking about and the problems that you might run into. So let's just go ahead and make an integer called A, and we'll set this equal to a real simple equation, 4 plus 2 times 6. And then we'll just go ahead and print it out on the screen, printf. And of course, just go ahead and print D and bump that to a new line. Actually, let me go ahead and put this result, that new line, and of course, print out A. Now I actually want to copy this, and do I want to do it now? Yeah, okay, I'll go ahead and run it now. So this equation right here, you might be thinking this, okay, 4 plus 2, that's 6, times it by 6, 36, piece of cake. Run this, and 16. Okay, so I'm an idiot. What did we do wrong? Well, I don't know if you got, I'm sure you do learn about the order of operations already. I don't know how old you guys are watching this tutorial, but basically, the order of operations in real life is the same as they are in C programming. So I learned like PEMDAS, I think, which is parentheses, exponents. For now, just remember that multiplication and division come first, and then addition and subtraction. Meaning that whenever you have an equation that has both multiplication and addition, what it's going to do is it's going to do your multiplication first. That's kind of a tongue twister. So it's going to times 6 times 2, which is 12, and then add 4. However, what if we actually wanted to add 2 to 4, which is 6, and then multiply it by 6? Well, whenever we want to do that, we actually need to, do I want to make a new variable? Nah, I'll just stick with this A. So whenever we want to do that, actually just copy this. Then here's what we do. Just like in real life again, surround the thing you want to do first with parentheses. So you can use parentheses basically to overrule the rules of math. So right now we're saying always do the things in parentheses first. So now what we're going to do is you do this equation first, which is 6, and then times the result by 6, and hopefully, if my computer is not broken, it would print out 36. So again, the first one is just the default way of, I don't know, just like how math works. And the second one, we overwrote it and used parentheses to make our own equation, I guess you could say. Now, another thing that I want to teach you guys, since this was kind of a short tutorial, do I want to teach you guys this now? Actually, I got to vent a little bit, and I want to save this for the next tutorial. So that's all I have for you guys. You guys can check out the next video, but if you guys want to stick around, listen to the story. So last night, a couple people came over and we were just hanging out front because I don't know, that's what we do for fun. And this stupid cat walked right up to me because my neighbor, she left, and she was like a cat lady and she left all her cats here, so now they walk around my house. So this cat walked up to me and I'm allergic to cats, so I was like, get the heck away, cat. And this girl named Emma, who was with me, she was like, hey, don't be mean to the cat. And I'm like, whatever. And she wanted me to feed the cat, and I'm like, no way, I'm feeding this cat. So she went in my house and she was gonna get some food for the cat so she could feed it. I guess she felt bad for it or something. And you know what she walks out with? A bagel, a freaking, a freaking bagel. I'm like, Emma, what are you doing? What the heck? And I tried to like explain to her that cats don't eat bagels, and she's like, it'll be fine. My dog eats bagels. And so I'm like, wow, really? So eventually, I just let her do her thing. So she actually sets the bagel down, and I was scratching my head because in my house I actually had a couple cans of tuna fish that she could have got, but she sets the bagel down, and I'm like, this cat is like gonna like flip you the finger, and the cat actually starts eating the freaking bagel. I'm like, what the heck? And now I look like an idiot because this stupid cat is eating this stupid bagel, and I don't know. So that's basically the story of my night. And now the cat always comes around and meows whenever I'm making a tutorial because I don't know. I guess he just wants more freaking bagels. So if you hear meowing in the background, it's that stupid cat. Blame Emma. Anyways, I'll see you next time. Alrighty guys, welcome back, and let's just go ahead and get started because I'm going to be teaching you guys, well, a couple different things. The first thing is a quick and easy way to assign a value to multiple variables at once. Doesn't sound that exciting, but it is going to save you a whole bunch of time in programming. So let's just go ahead and make a couple stupid variables: int A, int B, int C. And of course, whenever we want to assign a single value to all of these variables, I don't know, maybe we're making a game and every player starts out with the same amount of points, or these are be like a bunch of monsters with the same amount of health or something. What we can do is, of course, do it the old-fashioned way. A equals 100, B equals 1. Oh my god, it's taking too long. So we know that we can do it that way, but the way that I wanted to show you is this. What you can do is, I'll just type it out and then you're probably going to understand just by looking at it. So what this is going to do is it's pretty much just going to read it from right to left. So what your computer sees is this. Take the value of 100 and assign it to C. So now C equals 100. So whenever you do this, take the value of C, which is 100, and assign it to B. B equals 100. Take the value of B, which is 100, and assign it to A. So now all of your variables, A, B, and C, equal 100. Don't believe me? You shouldn't, because I lie a lot. But anyways, I'll prove this one to you. So let's just go ahead and put, I'll just print out the, won't do anything fancy here. %D, and A, B, C, good to go. So let me print this out and check it out. 100, 100, 100. So again, I know that it isn't really like handy right now, but later on you're going to see when we have a ton of variables that we need to create for programs, we can do it all in one line of code instead of like 50 lines. So let me go ahead and delete this stuff right now. And let's actually put this to use. And let me, I don't know, I'll make like a quick program that can calculate the average ages or something. So say that we had like 3 people and we wanted to calculate their average age. So we can put float age 1, age 2, age 3, compact that. Now we also need to float for average, and might as well stick that up there too. So all of our variables are defined on one line. Now, of course, let's go ahead and just go ahead. How can we do this? Okay, so the first person and the second person will say have the same age. So age 1 and age 2, we'll set them both equal to 4 years old. So maybe this is like my kindergarten class. So boy A and girl B are both 4 years old. And then let's go ahead and get the age of the user. Make this thing interactive a little bit. And we'll just say enter your age. Bust that on a new line. And of course we need to give them a way to actually enter their age if we're asking them for it. So again, what they're going to enter is stored in a float. It's actually going to be stored in this age 3. So %f, and remember also that whenever you use a variable that's not an array, then you need to use that little ampersand, and we're going to store whatever value they entered in age 3. So now we have all the data that we need. We only need to make one other calculation, and that's average. And of course we know how to figure out averages. Age 1 plus age 2 plus age 3, and take that entire equation and throw it over 3, and that's going to give you the average age. And now we just got to print out the result on the screen. So we'll say, and we actually probably want to put this on a new line as well, that average age of the group is %f, and of course %f is average. So let's go ahead and run this bad boy and check it out. Nothing is happening because my computer is freaking slow, but eventually it says enter your age. So how old was I in kindergarten? I think I was 42, and hit enter, and it says the average age of the group is 16.666. Okay, I'm old. I freaking get it. Well, basically, you know, my age, guys, that's not even important. Don't worry about it. What I want to teach you is how we can pretty much compact our code, make it a lot neater, and save ourselves a whole lot of typing. So that's how you do it. Cool little program to figure out your average age. And well, thank you guys for watching. I'll see you later. Alright guys, welcome back, and in this video what I want to do is I want to teach you guys a nice little shortcut to when you're writing certain equations. You can use this, and also it's good for things like I know you can't use C with web programming, but like to increment page views, or maybe you're making a program to calculate compound interest or just basic interest, anything like that. So what it is I'll do it the old-fashioned way, and well, it's not the old-fashioned way, I mean it works, but then I'll show you guys a better way. So say we wanted to calculate views for a website, so we'll put int page views, and might as well just set this to 0 at first, because of course when our website's first created we don't have any views. And of course page views is equal to page views plus 1. So what's going to happen is every time we get a new page view, we basically want to add 1 to the value, so 1, 2, 3, so on and so forth. So what this is basically saying is take the old value of page views, which is 0, and add 1 to it, so now the new value is 1. So again, the 1 on the right hand side of the equal sign is the old value, and the new variable's value is whatever this equation is, so it's now 1. So what I want to do now is just print f, and we'll just verify this a couple times. So page views, and then we'll put %d and bump it to a new line. And I probably need quotations around that day. Wow, I can't freaking type today. Alright, and of course for %d, what do we want to use? Page views. And actually I'll copy this a few times, so it's actually not stupid. Now let's go ahead and run this bad boy, and we can see the first time it prints out is 1, then 2, then 3. And again, the reason it doesn't start at 0, even though we set it 0, even though we set it equal to 0 up here, that's what I was trying to say, is because it ran this equation and set that equal to 1, and this was the spot where it printed out for the first time. So we know how to make a little incrementer, but there's a faster and easier way. So instead of actually using page views, because that doesn't even apply to C, because you can't use C for a website, let me go ahead and make like a interest calculator. So let's go ahead and make a balance for a bank account, and we'll set it equal to 100. Actually, you know what? This is our money. Set it equal to 1,000. Why the heck not? So what you can do, and let me give myself a little space to work with. So what you can do, instead of having balance equals balance whatever, you can actually do it all in one shebang. So if you hit the asterisk, which of course is multiply, and hit the equal sign, then what this is saying is, well, actually I'll type in the equivalent line of code. Equals balance times 1.1. So this is pretty much a shorthand way of writing this. These do the exact same thing. And I know that this is kind of awkward to look at, but once you do it a couple times, it's going to become like second nature. So basically, like I said, this is taking the old balance, multiplying it by 1.1, and then returning that new value in the variable. So now we can just go ahead and print, let me steal this from up here. I'll put balance is %F, and of course that's the balance. So if we wanted to make a program, like I said, to calculate if we had $1,000, and we'll say that I don't know, every time we print this out, it's like 1 year or something. So after 3 years, what would our balance be? Anyone want to guess? Too bad, gonna run it. So alright, so after the first year, how much interest did you earn? $100. After the second year, our total amount is 1,210, and after the third year, 1,331. We are becoming rich. How freaking awesome is that? So again, that is a quicker way to do it, and eventually when I talk to you guys about these things called loops, they're pretty cool. I'll show you guys an even faster way to do this. So our skills are just getting more and more efficient, but for now I think you guys need a break, so I'm gonna go ahead and feed Pussycat another bagel, and I'll see you guys in the next tutorial. Alrighty guys, welcome back to another sweet video, and in this tutorial I want to talk to you guys about something called typecasting. Now typecasting is pretty much a way that you can temporarily change the data type of a variable. So you can pretty much turn floats into ints, ints into floats, tomatoes into tomatoes, potatoes into potatoes. So let's make a quick program. Let's say that you own a pumpkin farm and you want to figure... Really, someone is freaking texting me. I'm gonna read this. Who is it? Oh, it's my mom. No, someone else. Oh, Buddy is going to Cracker Barrel later, and he want to know if I want to go. But I'm trying to make a tutorial about pumpkins here. So basically, you own a pumpkin farm, you sell pumpkins every day, and you want to figure out how much money you make on average each day. So let's go ahead and do that. So of course we're going to need a couple variables to store these values in. So float, average profit, and this pretty much is the end goal that we're going to be looking for. So in order to calculate that, price pumpkin. Alright, so we sell our pumpkins for, I don't know, how much does a pumpkin cost? $10 maybe? So that's what that's going to be. Our int sales, how many pumpkins did we sell? 59. And of course int days worked, and we'll just set this equal to 7. We'll say we worked a full week, no days off, because we are the best pumpkin farm there is. So you might be like, okay, I know how to do this, no problem, Bucky, I don't even need to watch the tutorial. What you do is you pretty much take the price of pumpkin and then you multiply it by sales, and that's going to give you pretty much the total amount of money you made. And then I'm just going to go ahead and divide this baby by days worked, and that I think would give me the average amount of money I made per day. I mean, it looks pretty good right now, so let's see what happens. So printf, and we'll just put like average daily profit, and of course it's a float, and we'll use the dollar sign, why not? So dollar sign, and then you put ampersand. Where you at, ampersand? And, or excuse me, not the ampersand, what the heck am I talking about? And percent sign, float, and since this is a dollar indeed, let's go ahead and use 0.2, because you know, it'll be like $1.50 or something, 2 decimal places. And of course, the float that we want to use or output to the screen is average profit. Alright, so let's see how much money we make a day. Okay, so the average daily profit is $84. Okay, well, hold on a second. Let me just check something here. Calculator. You know, I have to verify this. I need to be very specific. So basically what I'm going to do is, okay, price of pumpkin, so that's the 10, and what do? You times that by sales, do you? So where's the times on this thing? So times 59, and then, okay, take that value, and you divide it by 7, and, whoa, what the heck is going on? This thing, the calculator that we made, is telling me 84, but this stupid thing, you know, I'm calling Microsoft, they might be wrong, because I know that this code is perfect. Well, check it out. The reason that this doesn't work as expected is because C doesn't have a very good time, or it's not very happy when you try to combine floats and ints together in equations. So it says, okay, if you're going to multiply stuff, make sure they're all the same data type, and also make sure that someone stops freaking texting me in my middle of the tutorial. Anyways, so in order to take these variables and convert them to floats, what you want to do is right before the variable name, add parentheses and type the data type that you want to convert it to. So now what this is going to do is it's temporarily going to change this price of pumpkin, which was an int, into a float. And again, it's not going to change it permanently. If you ever use it in your program again later on, it's still going to be an int. Just for this line, in this line only, or this instance of the variable, it's going to be a float. Alright, so what else do we need to do? We need to convert sales to float and days work to float, because we want this average profit to be a float. So now let's go ahead, and now that everything is converted, we'll go ahead and run this and check it out. 84.29, that's what I'm talking about. We finally got that 29 cents that we worked our butts off for. So again, if you have something like this and you're converting them to floats all the time, then that probably means that you should have started with floats to begin with. This is really only for instances where you need to temporarily change it, only you know, not throughout your whole program, only in one place or maybe two. So that is how you do that. Again, it's called typecasting. And oh crap, you know what? I gotta go work on my pumpkin. So well, I'll see you guys later. Actually, I'm going to Cracker Barrel, not gonna lie. So anyways, I'll see you then. Alright guys, welcome back to another tutorial, and in this video we're going to be making our programs a lot smarter than they have been, because I'm going to be teaching you guys how to create a computer program that can make a very simple decision. Now the decision that it's going to be making is, we're going to give it some code, we're just going to like print something out on the screen, and our program is going to decide whether it wants to run it or not. And if you guys are like, okay, it's a computer program, it does what I tell it to do, so it has to run it, right? Well, not exactly. So let me show you guys what I'm talking about. I'll type the syntax in right now and show you guys the basic structure of it. So what you do is you type the keyword if, and right after that type parentheses right there. Now in between those parentheses we're going to be giving it some sort of test, and we'll just make them really simple, like check if a number is equal to another number, or like check if one number is less than another number. So these tests can be kind of confusing, but I'm just going to show you guys some real basic ones for this tutorial. Now after that, put two little curly brackets, and any code that's in between your brackets is going to run if that test is true. So again, we're going to be putting the test right here, and the code, we'll just write something simple like print something out on the screen. But this is the basic structure of how to allow your computer to make a decision. So I'm going to go ahead and show you guys the actual example so this makes sense. So like I said, just test something really easy, like is the number 4 less than the number 10? Well, of course we know that it is. So in this case, it would run whatever code is right here, like print something out on the screen, and it'll just put like a easy house. So whenever we run this, we see that it does indeed print out easy house. So, of course, what your computer did is it said, okay, you want me to test this. Okay, is 4 less than 10? Yes, it is. Run this. So now let me show you guys an instance where the test would be false. And I'll talk to you guys about the different types of tests that you can do. But, of course, right now you know that you can do less than. You can also do greater than. So let's do that. So this, it says, is 4 less than 10. This one right here, this does not equal true. 4 is not greater than 10, so any code that goes right here, like print out meatball, if we try to run this, we see that it does not print out meatball. So even though we typed this line of code right here in our program, check it out. It doesn't print it out because we gave it a test, it wasn't true, and it made the decision not to run it. Pretty sweet. So before I show you guys an example of when you would actually use this in real life instead of just printing out meeple on the screen, I'll talk to you guys about the different types of tests that you can use. So, of course, you knew less than, greater than. There's also greater than or equal to. And this case would be like if you want to test if someone is like can enter a website, their age would be like greater or equal to 18. There's also less than or equal to. In some other ones, let me go ahead and type some numbers in here to test. And another one that you can do is test if two numbers are equal to each other. Now, whenever you do this, you actually use two equal signs. And you're like, okay, well, in math class, I just write, is x equal to 10 or something? And the reason you don't use one equal sign in computer programming, because remember, whenever you're making variables and assigning values to variables, you write something like x is equal to 10, and one equal sign in C programming means assign a value to a variable. Two equal signs means test if one value is equal to another value. So again, just remember that. You'll get used to it after a while. It's very simple. Now, the only other test I want to talk to you guys about right now is this. Not equals to. It's basically the opposite of equal to. So in this test right here, whenever you want to test if something is not equal to 5, it's going to be true in every instance except 5. So this, of course, is basically the opposite of equals equals to. 5 is indeed not equal to 5. That's true, so we ran this bit of code. So let me go ahead and show you guys an actual example of when you would use this. And what we can actually just code that one that I just talked about. We can allow the user to enter their age, and if they're above 18 or if they're 18, then we can allow them to enter some sort of website. But you know, like what website would the user need to be above 18 to enter? I don't know, I can't think of anyone, but we'll code it anyways. Easy caps lock. Okay, so int age, and then we'll just go ahead and give them some little prompt on the screen, printf. Enter your age. Actually, I want to ask them a question. How old are you? New line. And of course, if we're asking them a question, we probably should give them an area to write into. And this is just going to be a simple integer, so %d, and of course ampersand age. So now we have the user's age, which is some number in the variable age. So now we need to make that basic if statement to test if their age is above 18. Simple enough. So if age is greater or equal to, because remember it said they can also be 18. So this is going to be true in anything like 18, 19, 84. It's going to be false, and of course 4, 3, you know, like a bunch of 3-year-olds use computer. But anyways, let's go ahead and just print something like print. You may enter this website. So we can go ahead and run this, and hopefully if it works, how old am I? 27. you may enter this website. Cello. Now, another thing that we can do is we can also output something if they are under 18. And that's simple. You can just write if, and let me give myself a little bit of space to work with right here. So if age is less than 18, what can we write? Just write, holy, nothing to see here. So run this, and of course, if we say something like, how old are you? 86, it still says you may enter this website and nothing else. And if you run this again, how old are you? Well, I'm actually only 6 years old. Nothing to see here. So pretty sweet. Our programs are getting a little bit more interactive. And actually right now, I guess this is a good time to talk to you guys about nesting if statements. So I'll actually put that in the next tutorial. So, I don't want to overload your guys' brain in this one. So in the next tutorial, I'm going to show you guys how to nest if statements, make decisions like right after another. So it's going to be awesome. Thank you guys for watching. Alright guys, so in the last video, what we did is we made a very simple program to test the user's age. We allowed them to input some number, which was their age, and if it was 18 or greater, we just said you may enter the website. If not, then we said nothing to see here. Simple stuff. But now what I want to do is, I want to say this. If they were allowed to enter the website, then let's just go ahead and give them a custom welcome message based on their gender. So, of course, we need a variable for gender, name it gender, and we also need a place for them to input it. So we'll just copy this, and we'll put something like, what is your gender? And make sure to give them options. We'll say M/F because, well, let me go ahead and type this so I don't forget. Gender %C. Now, the reason that you always want to give them options is because if you just ask the question, then some users might type in male, some users might type in dude, some users might just press F. You want to give them one option only on how they're supposed to format their answers. And also, another thing I want to point out, and you guys should probably do this all the time, is sometimes whenever you put this %D for scanf butted right up against a quotation mark, it sometimes can confuse your computer. Not a lot whenever the user's inputting numbers, but especially with characters and like words and stuff like that. So it's common practice, and I'll do it from now on, to add a space between the quotation mark and the percentage sign. Again, it depends on your compiler and all that stuff, but this is kind of behind the scenes stuff. It's always good programming practice to leave that space. Again, your program might work without it, but let's have it anyways. So what we're going to do is, let's go ahead and put our code right in here. So basically, we're going to be putting an if statement inside another if statement. So basically, we're telling our computer to test this thing first, and if it's true, test something else. And of course, we want to test their gender. So if gender is equals to, because we want to make sure it's exactly equal to, and we'll just do we'll say if they entered M first for male, so single quotes M. So right now it says you may enter this website with a space after it, and so let's just go ahead and print out, I don't know, what would you print out for a guy? Something like dude. So, well, let me go ahead and finish this code, and then it'll be easy to see what's going on. Now, if their gender equals F, they must be a girl, so what do we say to them? M'lady. So basically, I'll run this program right now, show you guys a quick example. How old are you? I am 27. What is your gender? I am a male. Hit enter, and it says you may enter this website, dude. Pretty cool. Now let's go ahead and run that again, and we'll say, okay, but what if, I don't know, it's my sister. How old are you? 15. Hit enter. What is your gender? She is a female. And hit enter one more time. It says nothing to see here, and that other decision never gets made. Because basically what's going to happen is it's going to say, okay, you're not above 18. So I'm going to hop right down here. I'm going to actually skip over all of this crap right here, and I don't even use that gender variable ever again. Now, I'll actually show you guys what I'm talking about right now. Say that we actually didn't use that space, and I know it works on, or it doesn't work on this compiler, and we try to run this program. How old are you? Okay, looking good. 27. Hit enter. Oh, what the heck? It didn't even. It just ran right past that scan F right here, and it didn't even give me another option. So this gender variable never even gets filled. It pretty much is a bug, and it skips over the program. So if you ever want to make a program with a bug, then that's how you do that. Why would you want to do that? You would never want to do that. So just don't do that. I'm just showing you guys. Make sure you have your spaces in there from now on, and that's what we're going to be doing. So anyways, thank you guys for watching. Don't forget to subscribe, and I'll see you guys later. Alright guys, welcome back, and in this video I actually want to show you guys something real cool. And actually, don't even mind this code right down here, because whatever I teach you in like the next minute, I'm going to be applying to changes to the program that we made in the last couple of tutorials. But for now, I don't want to delete it all, so just pay attention to what I'm about to type. So before, what I showed you guys is how to have your computer make a simple decision if, and then you tested something, and if it was true, it ran this bit of code, but if it was false, then it just pretty much skipped over it. It didn't do anything. Well, what if you want to say, okay, actually, I want to give you a test, and of course, if it's true, run this bit, but if it's not true, then just don't do nothing. If it's not true, then run another bit of code by default. Well, the syntax for this is else, and then the code that this is going to run by default is in between another curly bracket. And another thing I want to point out is for the else, you don't need any test because it's not testing anything. It's just the code that runs by default if this test is false. So what the heck am I talking about? How can I use this in an actual program? Well, check this out. What we're doing right here is basically saying, okay, this is the code that runs if the user's age is above or equal to 18. And this is the code that runs if they're under 18. So we really don't need to be testing 18 a bunch of times. We really only have two choices. Are they 18 or greater, or are they not? Simple enough. So this is an instance where we can actually use that else statement. So I'll just go ahead and copy this code and delete this right here. So what we can do now is whenever this if gets done, right after it, type else and add two brackets and put that code right in there. So this is basically saying right now is, okay, is the user's age 18 or greater? If it is, run this bit of code. Else, that must mean that they're not 18 or greater, run this bit of code. So now we can run this, and it says, how old are you? Of course, I'm only 12. Hit enter. What is your gender? I'm a male. And of course, nothing to see here. Now, another way that we can do this is we can actually use this else statement on male or female. Because, excuse me, that else statement is awesome whenever you have two decisions. So 18 or not 18. Male, female. Perfect. So let's go ahead and copy this right here. Or excuse me, I'll just cut that and delete it. So if they are a male, do this. Else, if they're not a male and that's false, well then they must be a female. So we can go ahead and type m'lady. So again, if they're not 18, then they must be under 18. Duh. If they're not a male, they have to be a female. Duh. So if the test is true, do this. If not, do this. Simple enough. So now we'll just go ahead and check for bugs one more time if I can move my frickin' window. And let's get to an old lady. So how old are you? Well, of course, I'm 541, and I'm a female, the oldest female in the universe. Hit enter. You may enter the website, or you may enter this website, m'lady. And of course, the path we took on that one is 18 and m'lady. Simple stuff, but had to teach it to you guys. And like I said, this is the key concept to take away. The if-else statement is really good when you have two decisions, 18 or older, or excuse me, 18 and above or younger, male, female. But now you're saying, okay, what if I have like more than one option? What if I'm selling T-shirts and I have small, medium, large, extra large? I can't just use if else. That won't work. Or like, what if I'm making something for grades and it's like A, B, C, D? What the heck do I do then? Well, in the next tutorial, that's what we're going to be talking about, and we're probably going to be building the coolest and most useful program yet. So, well, that's all I got to say. Hopefully, you guys stick around, and I'll see you then. Alright guys, welcome back, and in this tutorial what I want to do is I want to show you guys one last piece of that mysterious if statement, and it's called the else if, kind of a combination of the other ones, because we know that the basic if statement is good at testing one thing. Now we know that the if else statement is good between choosing between two decisions. But what if we have more than two decisions? And an example of this is, of course, let's say you own a t-shirt shop, like I said last time. We're going to have more sizes than just one or two. We're going to have like small, medium, large, extra large. So unless we wanted to write just a bunch of if statements, what did I say, statements, which can be kind of confusing, we need a better way of doing this. So let me go ahead and actually code a program right now to explain this to you guys. This is actually pretty useful. We'll say that we'll make a program to give the user the average of 3 test grades. So, of course, the grades that they have to choose from is A, B, C, D, and F, or E, some people have. But we'll say float grade 1, and I'm going to copy all of these, float grade 2 and 3. So what the user is going to do is we're going to give them an area to enter 3 test grades, type it in the screen, and we'll store it in floats. So printf, just tell them what's going on, enter your 3 test grades, and yeah, might as well give them a little prompt, kick it to a new line, scan F, and we don't need to give them a prompt for everyone. So for the scanf, since it's a float, of course, we will use %f, and remember to add that space. And this one, the first one they enter, we can just go ahead and store in grade 1, grade 2, and grade 3. So now we basically have 3 numbers from them, and the only thing that we have to do now is get the average. So make a new variable called float average, and of course we know how to do this. Set this equal to grade 1 plus grade 2 plus grade 3, and once we have the sum of that, go ahead and throw it over 3, and that is your average. So I guess the first thing we should do is just print out their average on the screen. And since I'm too lazy to type 5 little characters, I guarantee you, that copy and pasting takes longer than if I was to just freaking type it, but oh well, don't feel like moving my fingers, fat little sausage fingers. Alright, so %.2f in, I don't know, we'll just go ahead and display to 2 decimal places because why the heck not? And of course, what are we doing? We named it AVG. So right now we can actually run this program and it should run fine unless I mess something up. Enter your 3 test grades, and we'll just make sure it works by giving a nice easy average to work with. 70, 80, and 90 should be 80 average. Alright, so this works right now. But now what we want to do is we need to take that average and print out a grade for them. Something for the report card A, B, C, D, or F. So we need to test 5 different criteria. So the first thing we can do, we know how to do this. Let's go ahead and work our way down from A to F. So we'll test if average is greater or equal to 90, then let's just go ahead and did we kick it to a new line already? Yep. So printf, we'll just print I don't know, something simple like grade is A. Make sure you got your semicolon. Now this is the part we run into where we would have some trouble before, because if we just wrote else, I mean, we can, okay, that's kind of confusing because we have like a bunch of letters to choose from. So this is where the tutorial comes in handy, because we can now use a new keyword called else if. Now what this is basically another option that it can choose from. So it's first going to test, okay, is your average greater or equal to 90? If so, just run this code and boom, your program's good to go. But what if it isn't? Well, let's go ahead and go to another option, which is this one. And of course, we need to give this one a test because it's not just a default. So the test is, of course, we'll just say, okay, well, is it greater than 80 then? And if so, then we'll go ahead and print out B. And saying, okay, well, what if it's not even greater than 80? Well, this kid must be dumb. So let's go ahead and put an else if greater or equal to 70, do C, and I might as well type it so you guys can get it stuck in your brain. Else if it's not even greater than 70, then test if their average is greater than 60. I don't even know if this is the grading system now. But in this case, print out D. Now here's the point where I want to take a break and mention what's going on. So basically, what's going to happen is our program is going to test first if their grade is above 90. If it is, then it's going to go ahead and skip the rest of this statement because it only can choose one of these options. If it's like greater than 70, it's not going to print out C, B, and A. It only runs one of these things. Once it finds the criteria or a test that passes, it only runs the one in that block, not everything else. No need to test anything else. So what we did is we said 90, 80, 70, 60. Okay, if none of those are true, then we can go ahead and just add that default statement, because if none of those are true, then they must have gotten an F. Their grade must be less than 60. Nothing else is possible in the world of math. So print F, and of course, instead of just writing grade F, we'll just go ahead and write something like you are dumb, because any kid who got less than 60 on any test, again, this is probably why I'm not a teacher in school, but it's a pretty funny program. So if we run this right now, everything looks good. It says enter your 3 test grades, and let me just go ahead and put like a 73 right now, and I'll make sure that I have like a see what that is. So my average is 76.67. So what happened is it says, okay, that's your average. We stored it in this variable right here. So first I tested if it was greater than 90. It wasn't, so I hopped down here. I tested if it was greater than 80. It wasn't. Tested if it was greater than 70. It was. So I printed this out and I just skipped everything else. So no need to test this or this because we already found our answer. And if there is any code like down here, then this is where it would pick back up and start running again. So very simple. And also what we can do just for fun is run this program, and for some reason I just wanted to print out what if a kid got a 21, then he studied and he got a 56, and then he got a 4. Hit enter, his average is 27, and it says you are dumb because he was dumb. Simple enough. So that is how you make a very simple program, and that is also how you make one decision, decide between 2 things, or decide between unlimited options. So now that we got that taken care of, I'm going to show you guys some other sweet stuff. You guys are like becoming a pro in C programming. So thank you guys for watching. Don't forget to subscribe, and I'll see you next time. Alright guys, welcome back to another video, and I actually just want to tell you guys a story that happened to me in this tutorial, and that is this. Last night, some software came to me. It was the biggest software company in the world, and they're like, Bucky, you're the greatest programmer ever, so we want to tell you about a program we're making. We plan on building a robot that's going to replace every teacher in school. And I'm like, okay. well, what do you want me to do? And they're like, Bucky, we need you to build the brains for this robot. So I'm like, listen, leave me alone. I got this. So I rolled up my sleeves and I started coding. I'm like, okay, well, the teacher needs rules to go by. So what are they going to check for? Well, they're going to check for if the students studied enough, and they're also going to check if the students beat up kids, because that's the only two criteria and what makes a good student. So first, make a integer variable, say int hours studied, and for now, just by testing, we'll put it at like the optimal student studies for 60 hours a week, at least. Now, let's go ahead and just write a comment right here. Like, okay, what makes a good student? A good student studies for like, I don't know, 10 or more hours a week. And this student just testing had studied 60, so that's good. Now, what else do we need to test for? We need to test for how many kids they beat up this week. So int kids beat up, and again, we're just testing, and we'll put 0 right now. And let me give myself a little space. And we'll say the rule for a good student is they have to beat up 0 kids. So in order to have a good student, they need to study for 10 or more hours, and also they need to have beaten up 0 kids. I don't think that's that much to ask for. So now what we need to do is we need to make a simple decision to allow our robot to go on something. So we can't just use two if statements, because we actually need to test all of these in one decision. If we're just testing for hours studied or kids beaten up, then we would need two if statements, but we need to test both of those things together. So how do we do that? Well, we do it like this. In your test, and actually let me go ahead and write the print first. So we'll print f and just put something like, you are a good student. So basically, like I said, we need to test two things. So how do you test more than one thing? Well, in between your parentheses, give yourself a little space to work with, and in the first piece of the puzzle, you add the first test. So test 1. Now, what you do is you add 2 ampersand signs, and then in another set of parentheses, you add test 2. Now, what this is going to say is basically test 2 conditions. If both of them are true, and in this case, if they studied for 10 more hours and they beat up 0 kids, print out you are a good student. So hours studied, test if this is greater than 10, actually greater or equal to 10, and for test 2, test if kids beat up was exactly equal to 0, or we can even say, well, that's the easiest way to say it. So basically, if this is true and this is also true, then print out you're a good student. And check it out, in this case, our kid beat up 0, studied for 60 hours, so it should print out you are a good student. Now, of course, if we have something like, okay, how many hours did he study? Well, he only studied 2 hours. How many kids did he beat up? Well, he actually beat up 9 kids that week. So, of course, if we try to run this, it would not run that code, because both of these were false and not true. Now, what if you're saying, okay, well, what if he was a really smart kid? What if he studied for actually 80 hours that week? However, he was in a bad mood. I don't know, maybe something happened to him, so he beat up 12 kids. Well, it says, okay, I'm going to test this. This one is true right here. Good job. You studied, the adequate amount of time. However, this is false. You beat up some kids, dude. So what's going to happen is this is true and this is false. So this entire thing is not going to run, because this only runs if both of these tests are true. So again, like I said, look at that. Even though he studied the proper amount of time, he beat up the kids, so that test was false. So again, the point of this tutorial, and you know what, I have to tell you the truth, no software came to me, that was just an example. But anyways, the point of this tutorial is whenever you want to test more than one condition, then what you need to do is use those ampersand signs, and that means this has to be true, and this has to be true, and if so, run this code. And another thing is, you can use as many of these as you want. You can put ampersand test 3, test 4, test 5. Just separate all of your tests with these two ampersand signs. And what this would mean is this has to be true, and this has to be true, and this has to be true. If one of them is false, then this code doesn't run. So hopefully you guys enjoyed my tutorial. I'm going to go beat up some kids. I'll see you later. Alright guys, welcome to another video, and in this tutorial I want to show you guys another way, and this is actually kind of a simple way that you can test multiple conditions as well. So this is actually really good whenever you have the user enter input into the keyboard and you want to check and make sure they entered it properly. So let's just go ahead and make a simple program to ask the user if they like bagels or not. Because I know that cat outside my window, he loves bagels, so he would say yes, but we'll see what the user has to say. So go ahead and we'll just have the user type in Y for yes and N for no. So we can just store that in one character. So char answer is what we'll put their response in. And for the question, we'll just print it out. And we'll just say, do you like bagels? And also let's give them that little prompt Y/N to let them know they can only enter yes or no. And also for the scan, we'll kick that to a new line. Now of course give them a place where they can enter their answer, scan F. Now for this, remember, in between your parentheses hit a space, %C, since we're only doing one character. And where do we want to store their answer? Well, we want to store it right in the variable answer, and we need that ampersand sign because it is not an array. So basically right now we stored either the letter Y or N in answer. Now we want to make sure that they actually did write Y or N and they didn't type something stupid like P or type the word meatball or anything like that, because if they did, well, then it just like broke our computer program. So let's go ahead and make the basic structure first. So we'll just go ahead and make a test eventually that if they enter the correct data, then we'll print out, I don't know, what can you say? Like, we'll just say, I feel this. No, what can you say? Good job. You didn't mess anything up. We'll say we're taking a survey about bagels or something. Now else, what's going to happen is we're going to say, basically, we're going to test if they entered Y or N. And if they did, good job. Else, they must have like typed in the word tuna fish or entered like the word or the letter X by accident or something like that. So we'll just print out something very mean, like keyboard much? Alright, so now we need to figure out how do we test this thing. And the reason that it's a little bit different than that and is because remember, last time we used two ampersands and both of those things had to be true. However, we can't do it this time because there's no way that the user can enter Y and N. Both of those things can't be true. So we need to use a new test, and that is called OR. And that, if you look on the enter key on your keyboard, you see the backslash, at least it is on mine. If you hold shift and press it twice, I call them the pipe symbols. I don't know what they're really called. I think they're called something like that. But in C language, two pipe symbols stands for OR. So basically we're going to have test 1, which we're going to say is the character equal to Y, and we're going to say test 2, which we say or is it equal to N. As long as it's equal to one of those things, then it's good to go. So the first thing we'll put is answer equal to Y, or is their answer equal to N? As long as it's one of those things, at least one of these things has to be true to say good job, you didn't mess up. If it's not and both of those things are false, then we'll just say keyboard much. So run this and we'll say do you like bagels, and we'll hit N, hit enter, and it said good job, you didn't mess up anything. Now let's say the user types in something silly like do you like bagels, Z, hit enter like an idiot, and it says keyboard much. And of course we typically want to display like a proper error message like hey dude, you actually need to press Y or N. But that's the basics of OR. And also, if there's an instance like this where both of these conditions were true, then this would still run. Basically, just one of these conditions need to be true. This one, or both of them. And let me show you guys an example of both of them. So we'll say is 5 less than 90, or is 10 equal to 10? Well, this is true. 5 is less than 90, and 10 is equal to 10. So even though both of these are true, you still need to do this, even though it doesn't really matter. We still get this. So I just want to explain to you guys that the first one has to be true, the second one, or both of them. It only doesn't return true if both of these are false. So hopefully you guys understood that, and if not, just play around with it for a little bit and you guys will get it. So that is pretty much all of the basic tests I want to talk to you guys about. And in the next tutorial, well, I guess I'll just teach you guys that in the next tutorial. So thank you guys for watching. See you then. Alright guys, welcome to another video, and in this tutorial what I want to do is I want to show you guys something called the shorthand if-else statement, and it's basically a way where you can write very small if statements. So if you actually have you're having your computer make a decision and you have a bunch of code in your if statements, stick to the other one. This is for when you only have like 1 or 2 lines to execute, and I'll show you guys the syntax for it right now. So you actually don't even ever type the keyword if, but inside parentheses, just go ahead and write your test, which is like is 5 less than 10 or anything like that. Now press a space after your test and write a question mark. So it's pretty much, you can read it as a question. Now after your question mark, if it's true, then the true code executes. Else, pretty much in place of else, you use this colon. This is your false code. So this is a syntax for it. This isn't actual code. Test question mark, basically saying is 5 less than 10? If it is, do this. If it's not, do this. So let me go ahead and show you guys an example of when this is actually useful. So what we can do is we can say that we're making a computer game and we wanna distribute players on each team based on their name. We'll say if your last name begins with M or above, like mine does, Roberts, we'll put you on one team. If it's M or below, we'll split you up on another team. So of course we'll put char last, one second, got an itch, last name, and we'll just put 20 for the last name. Hopefully no one has a really long last name, and give them a little prompt. And of course we'll say something like enter your last name. New line. So of course what we can do is put scanf. And remember, since this is indeed not just one character, we actually need to put scan in a string. So %s, and that string is going to be stored in last name. So remember, a string and a character array are basically the same thing. A string is a list of characters. Simple enough. So whenever we're scanning in a string, such as last name, we use %s, and also take note that it doesn't use the ampersand, because it has arrays pretty much have a built-in ampersand, and I'll talk to you guys about pointers later on. But anyways, what we did now is we got the last name, which is going to be, in my case, Roberts, stored in this array or string, whatever you want to call it. It's actually the same thing. So now what we can do is use that syntax of what are we testing for first. And let me actually just type that out so you guys know what's going on. So this is our test. This is the code that's going to execute when true. And this is the code that's going to execute if our test is false. So the test is just testing for the first character in their name. In my case, it would return R for Roberts. So how do we get that first character? Well, remember, to access individual items in that list, you type the name of the array or list and you write 0, because remember, I told you in programming every list begins with 0. That's just, I don't know, that's how it is. So 0 is going to return R, 1 would return O, 2 would return B, so on and so forth. So this is going to be R, and we'll say, is R less than M? So I don't know if you guys knew this, but you can test characters just like you can numbers. So of course, like A and B would be less than C, D would be greater than B, and so on and so forth. But one thing I want to point out is there is a difference between uppercase and lowercase. So make sure the user types the uppercase R in this example, and I'll tell you guys how to convert everything to uppercase or lowercase later on. But for now, this is pretty good. So we'll say, is R less than M? If it is, we'll just say printf. You're on the blue team, and you actually don't even want that semicolon right here. Else, you're on the red team. And let me put a space between those because it's kind of annoying me. So basically saying, okay, anyone whose name begins with something M, or excuse me, under M, which is A, B, C, D, all the way to M, then put them on the blue team. However, anyone else, put them on the red team. So run this, and I'm going to say, okay, enter your last name, Roberts. So you're pretty much going to hit enter. It's going to take that R from you, and check it out. My R is indeed greater than M, so it says, this blue team is only for less than M, so you are on the red team. And one other thing I want to point out one more time is make sure you don't have a semicolon after this. Whenever you have a shorthand if-else statement, like I said, it's not for a code where you're going to write like lines and lines of it. It's for one short code, one line here and one line here. Pretty sweet, and you can just read it just like a question. So this question mark is like, is the first character less than M? Oh, if so, do this. If not, do this. Reads like a freaking book. How easy is that? And let me actually go ahead and show you guys right now why I use it all the time. So you know how there's an instance where this is kind of confusing. Whenever you say I have 0 friends, I have 1 friend, I have 2 oops, forgot about that. So it says, okay, if you have 0 friends, then you say I have 0 friends. 1, you don't add the S. 2, you add the S again. And that's why I hate the English language, because it's kind of confusing. So you need a special instance to say, okay, whenever you just have 1 friend, you don't include the S, which is really probably confusing to like whenever anyone's trying to learn language, like babies or foreigners or anyone. So it's actually really easy to do in computer programming though. So let's make a variable called friends, and we'll set it equal to 87. And this is also a different way where you could use the if-else statement. It's actually a really cool shorthand one. I can't even type. So printf, and as the first part, we'll just put I have %d friends, and also, excuse me, just go I have %d friend. So again, if this is 1, then this is fine. However, if it's anything other than 1, then you can put %, and of course what this is going to be is S, because we're just gonna, I'll show you guys what we're doing later on. It could also be C, but you know, tomato tomato. So now it needs 2 parameters. The first one is spelled friends, which is basically going to say I have 87 right now. Now for this next parameter, we have to take care of this %s, which is going to be an S or not. So now we can say our test is, let me give myself a little space to work with. What we're testing for is this friends variable, and we want to test if it is not equal to 1. So that is our question that we're pretty much asking, and we'll say if it's anything other than 1, then just go ahead and use S as the string. Else, and you can just put a blank string. I don't even know if I told you guys that, but you can indeed have a blank string. And what this is pretty much going to mean is this: I have whatever number it is friend, and then it's going to say, do I add the S or do I not? Well, in order to answer this question, here is your little shorthand if-else statement. And the test for this is, okay, is friends, the amount of friends, anything but 1? If it's not equal to 1, then add the S. And this is the case, 0, 2, 3, 4, 5, so on and so forth. However, if it is equal to 1, add nothing. So now we run this. I have 87 friends with a S. Printing this out right here. Now if we change this to 1, I have 1 friend. Because it said, okay, it's not equal to 1, that's false, and whenever it's false, run the else statement, which is nothing, or empty. So this is actually what I use on my website. So, you know, if you ever go to Bucky's room and said, okay, Bucky has 1 friend, Bucky has 0 friends, or 87 friends, that's how I do it. So now you guys know, there's my secret. Thank you guys for watching, and well, go check out my website. Alright guys, welcome back, and in this tutorial I want to show you guys about this cool little bit of code called the increment operator. Now what this is it's a really quick and efficient way to either add 1 or subtract 1 from a variable. And we'll see later on why this is actually not even useful, but like pretty much necessary. So let's just go ahead and make a quick little variable right now, and actually I don't want to name it X, that's boring. Let's name it tuna because I love tuna. And that sounded kind of weird, like I love tuna, I don't know, whatever. So anyways, we'll just go ahead and print it out on the screen. Printf, do love tuna though. And since this is %d, and we'll kick it to a new line. So we print out tuna right now, and of course it prints out 20 on the screen. Nothing that exciting about that. So the cool thing I want to talk to you guys about is this operator. And what it is it's basically a symbol that you add right after your variable name. So type in your variable name, in my case tuna, and add 2 little plus signs. Now what this is going to do is it's pretty much going to say, okay, I'm going to add 1 to your variable, so increase its value by 1. So now tuna is equal to 21. So if I copy and print it out now, check it out. It was 20, that's why I printed this out, and then I added 1 and it printed out the new value. Now you can also do this with minus minus. Of course this takes away 1 or subtracts 1 from your variable. So let me close this and run it again. And that's why you got 19. Now another thing that I want to point out, and that confuses a lot of people, is this. If I just showed you guys this example and I put that increment operator before tuna and ran this, you guys are going to be like, okay, 24, 21. So it really doesn't matter if you have it before or after the variable because it adds 1. What the heck? I never even... Oh. Same guy's texting me again. Freaking wanna... Every time he wants to eat Cracker Barrel. Cracker Barrel. Shut up. With bagels with my stupid cat. Alright. So right now you may be thinking, alright, it doesn't matter if you have this before or after tuna. It adds 1 to it. Tomato, tomato. But actually, even though it looked the same right now, there is a huge difference. And I'll show you guys an example. And once you guys see this, everything is going to become crystal clear. So let's go ahead and make 3 variables. A equals, set it equal to anything you want. Set mine equal to 5, B equal to 10, and let's just like go ahead and multiply these numbers together. So restore that value in answer, and right now it's equal to 0, but we'll change that later on. So let's just do something stupid like take answer and set it equal to, what would it do first? Plus A, and remember that's the increment operator, so it's going to add 1 to the value of A, which would become 6, and multiply it by B. We'll just keep B the same. And now I just want to show you guys the answer on the screen, and we'll just put the answer %D, and we'll bump it to a new line. So that's pretty much going to say, okay, A times B, print it out on the screen. Easy enough, simple stuff, and you actually probably need answer right there if you want to print something out. And now what I want to do is I actually want to copy all of this, and I want to do the exact same thing again, but just changing a few things. Now the first thing I want to mention is this. The reason that I copied this first line as well is because I want to reset our variables back to normal, because right now we added 1 to A, so that's going to become 6. Oh, excuse me. So reset that back to 5, and also answer is going to go from 0 to whatever this is, so reset that back to 0 so we can calculate it again. And also, whenever you're resetting your variables values, make sure that you get rid of that int keyword. That is only for, you only need to say that one time just to tell C what type of data you're going to store in that variable. You don't need it again. It already knows that we're storing ints, so get rid of it. So right now, these pretty much print out the exact same thing. So what I wanted to demonstrate is what happens when you have those plus signs, called the increment operator, on the right hand side instead of the left. So run this bad boy and check it out. Even though we use that same increment operator, and even though we use the same equation, one time we got 60 and one time we got 50. So what the heck is going on? Why did that do that? Because we know that this plus sign, as we saw before, it just adds 1. It turned that 20 into 21. So why are we getting different answers? Well, the reason is because whenever you use the plus sign on the left, it works a little bit differently than on the right. Whenever you use it on the left, it changes the value of A before it runs this equation. So you can kind of think of this as that. Add 1 to A here. So it adds 1 to A before it changes the equation, and then this becomes 6 right now, so that's why we got 60. Now whenever you have it after the A, it pretty much runs the equation with the current value, which is 5, and then it changes the value after it. So if we were to print out A after this, it would be 6. So just remember, that's basically what's going on. When you have it on the left hand side, it said, okay, change the value of A before you do anything else. When you have it after it, it says, okay, do the equation, run this line of code, and then change A after. So that is why we get these little differences, and you know, even though it's just a small detail to take care of, when you're talking about 60 and 50, that can be, you know, a difference between like 60 pounds of gold and 50 pounds of gold is a big mistake. So if you're programming, then that's another thing you want to keep an eye out for. So hopefully you guys understand. I know it's like 2 little symbols and I spent a lot of time on it, but I'm going to show you guys why this is incredibly useful in the future. And well, thank you guys for watching, and see you next time. Alright guys, welcome back, and in this video I want to talk to you guys about not only one of the most important, but also one of the most powerful tools that we have in the C programming language, and this is called a loop. Now, it's actually incredibly important because what this does is it allows you to run a certain piece of code over and over and over again as many times as you want. So I'll show you guys the structure for it right now. It's going to look kind of familiar to an if statement, and it actually is really familiar to it. The keyword is while. Now inside the parentheses right after it, you write some test, and the test is pretty much the same ones that you could use for if statement. And then after it, you have the code that you want to execute. So let me show you guys a really simple example of a statement right now. So say that we have, I don't know, just get any variable to test. I'm going to name my tuna, and I'm going to set it equal to 1. Now for the test, we'll just say, I don't know, is tuna less than 5? If so, print out something on screen. So printf, and we can just write, we'll just write tuna is now %d, which would give us the value of tuna. So pretty much what this is going to do is it's a program that's going to first set this variable of tuna equal to 1, and then it's going to test, okay, is 1 less than 5? As long as it is, run this bit of code. So if you run it right now, it just says tuna is now one forever and ever. And you guys see how this is blinking? It's like printing it out a million times a second, or however fast my computer is. So now you're saying, okay, well, that's kind of a stupid test because tuna is always going to be less than 5 unless, the universe or math changes, and that's probably not going to happen anytime soon. So we need a way, in order to end this loop, we need a way to increment tuna. If there is only like something called an increment operator or something. Oh, that's why we learned the increment operator in the last tutorial. So if you guys thought it was useless and you're never going to use it again, whenever you're using loops, you use it all the freaking time. So check this out. What we can do is change up our loop to say something like this. So what this is going to do is every time this loop occurs, it's going to add 1 to tuna each time. So if you run this, check it out. So the first time tuna was equal to 1, it tested if it was less than 5, printed out tuna, 1. Did the same thing for 2, added 1, did the same thing until it got to 4, and then once it got to 4, check it out. Once the value of tuna was equal to 4, it said, I'm going to test this again. Or excuse me, once it got to 5, it tested it one more time and it said, okay, is 5 less than 5? Well, that's when this test was false, so that's why it didn't print out tuna is now 5. So again, what a loop does is it basically loops something over and over and over again until the test becomes false. Pretty freaking sweet. So let me show you guys a really cool example of actually I got a really cool example I can show you. So get rid of this and clear out everything except like the bare bones, so we just have an empty while loop. And this is actually something that you guys probably saw before. My math teacher taught it to me when I was in like I don't know, 6th grade maybe. He's like, alright, would you rather have $1 million right now, or I can take a penny and double it every single day for a month, and then you can have however much money that is at the end? And everyone was like, I'll take $1 million, $1 million. And so what he did is he actually figured it out, and I will show you guys how to do that. So put int day, and right now we'll just set it equal to 1, even though we're going to be running it for 31 days. And for the penny, we can just do float amount and set this equal to 0.01, 1 cent. So now, what do we want to test for? Well, we pretty much want to double it for 31 days. So we'll keep track of days and add 1 to it every single time this loop runs a process. So we're testing for days, so is day less than or equal to 31? As long as it is, continue this loop. Once it gets to day 32, then we can quit because there aren't 32 days in a month. So the first thing I can do is just print out how much we have, just so we know. So printf, and I'll just put something like day %d, and might as well give you a tab, and then we'll do amount, and then after this we'll just go ahead and put the $sign, and then we'll build a float. And new line, actually you want to do 0.2, new line, and of course the 2 pieces of info we need for this are day and amount. So this is pretty much going to tell you on your first day you had 1 penny, tomato, keep track of all of that for us. So after this, what do we want to occur? What do we actually need to program? Well, the only things we're going to be doing is taking our amount and we're going to be multiplying it by 2. So remember that little shorthand I told you guys earlier, multiplied equals 2? It pretty much multiplies this by 2 and sets it as the new value for amount. So it's pretty much equals amount times 2. That's all. Now after this, we need to add 1 today, because remember, if we don't, then this program is just going to keep running forever, which isn't that bad because we keep making money, but it needs to stop eventually. So I think we are good to go. Let's run it and see what happens. And I gotta close out this. Alright, check it out. So on day one, move this over so you guys can see the code. So on day one, you had 1 penny. It pretty much said, okay, of course the day's 1 right now, which is less than or equal to 31. That is why I print that out. And then it goes ahead and it times your penny by 2 and also adds day, or excuse me, adds a value of 1 to day, so day is now equal to 2. So then it tests the day. Is it less than or equal to 31? Yes, it is. Print that stuff out. And it did it all the way, and your penny kept doubling. 1, 2, 4, 8, 16, all the way until you got to day 31. And check this out. Holy crap. Okay, I can't even read this. Okay, so we have $10,737,418. So whoever decided to double the penny was a lot smarter than whoever just took the $1,000,000 on day one. Even though, you know what, I'd probably be happy with both. So that is what we did, and that is an example of an awesome way to use a loop. So if we didn't know how to use loops, then we would have to type this code pretty much 31 times, and it would be a pain. Our program would be like, I don't know, like 900 lines long. So now we could just do it in, what is this, 5 lines of code. Pretty freaking awesome. So again, that is what a loop is, and that's why, one of the reasons why computers are incredibly powerful. So anyways, for now, hopefully you guys understood the concept. In the next tutorial, I want to talk to you guys about another kind of loop, which is pretty stinking awesome too. So thank you guys for watching. Don't forget to subscribe, and I'll see you next time. Alright guys, welcome back to another tutorial, and in this video, since we learned last time that loops are freaking awesome, what I want to do is I want to teach you guys a new type of loop called the do while loop. Now, it's pretty much a way that you can run a loop just like before, but you can guarantee that your code runs at least once. So let me show you the syntax for it and when you would actually use this. Type do, and then without any parentheses, we're not testing anything so far, hit the curly brackets, and inside here is where the code's going to go. The meat of your code, anything you want to run in this loop, it's going to occur right here, just like the while loop. Now for the test, outside your curly brackets, that ending one, type while, and this is where you test it right here. So basically what's going to happen is it's going to run your code, and then it's going to make the test after it to see if it's true. If it's true, it's going to run your code again over and over and over again until the test becomes false. So the syntax is a little bit different, and like I said, what it does is since your computer programs run from top to bottom, it's going to guarantee this code runs at least once before the test even occurs. So if this test is false, you already ran your code once. So I'll show you guys why this is useful right now. So you know, a couple tutorials ago I showed you guys how to make this program that allows the user to enter 3 test grades, and then it gave them the average of those test grades. Well, whenever you're making a program like this, you want to make it adaptable for any users. You don't know if they're going to enter like 3 test grades, 10 test grades, if it's a big, I don't know, college that wants to enter everyone's test grade. So you want to make, like I said, a program that can accept as many test grades as you want and still gives you the correct answer. So let's go ahead and make that right now. And I want to delete this because this fake code is kind of, I don't know, cramping my style. So we need a couple variables, and we'll make them all floats. It'll be easier to work with. And we'll set them all equal to 0 by default. So this is pretty much going to keep a running score of all your grades. So if you enter 3 scores of like, I don't know, 50, then 50, then 30, then your grade is going to be 130. And the reason that we need to keep track of all the scores combined is in order to get the average, we take all your scores combined over total amount of tests you took, and it gives you your average. Simple stuff. So the next thing is we need a variable to, can't type and talk at the same time, to pretty much store whatever they entered for that test. So the current score that they entered and typed in, we'll just go ahead and store it in score entered. And actually, let me just do this, since I'm a lazy bum, and all of these are going to be equal to 0. So the third variable we need is just number of tests, and this is 0 right now, but we can go ahead and increment it each time using that auto increment. Remember that? So the last one right here is just the average. And of course, we know what that is. That's pretty much the end goal. Their average test score, we'll print it out right there. So now that we have all of these, we can go ahead and add some. Actually, let's go ahead and give them a little prompt right now. Printf. Alright, so this program, like I said, is going to allow them to enter an unlimited amount of grades, and it's always going to give them their average and some other stats as well if we want. So how do we tell the program that it's time to stop running? Well, we'll say that we'll just make a simple condition right now. We'll just say whenever the user types in 0 to quit the program. So that's going to be the test. So press 0 when complete, and just add some new lines so, I don't know, it just looks a little bit neater that way. Now in your do statement, remember, this is going to occur at least one time by default. So the first thing I want to occur is pretty much just to print out those stats. Basically saying your test and your average as well. So it's pretty much going to say, well, I just said it, so it's kind of stupid. So tests, which is going to be 0 by default, and it's going to increase by 1 every time they enter a new test. And remember, this is a float, so put %f. And remember, what we did up here is we made everything a float because we saw that your computer works really well when everything is the same data type. But if you think about it, you can't like take half a test, and by default, floats occur, or excuse me, display 6 decimal places. So you don't want to display like 1.000 tests because he's like, what the heck is going on? I can't like have 1.5 tests. So whenever you want to kind of cheat, you don't have to typecast this. You can just press 0.0, and it's just gonna display the whole number of the float, like 1, 2, 3, so on and so forth. So it's just a quick little tip. So that's going to be how many tests they entered, and this average of course, you know what that is, %f, and we can display this to like, I don't know, 2 decimal places. That'll be good. Now kick that to a new line, and of course it says, okay, well now you need to give me a float and the average, and this first one is how many tests they entered, and the second one is average. Sweet. Now after this, what we need to do is just give them a little prompt to actually enter their test score. So put enter test score. Actually, what I want to do is kick this one on a new line as well. And I actually don't want to break to a new line after this because I think it'll be cooler if it just displays this on the screen and they can just enter it to the right. It'll be a blinking line on the right. Look pretty cool, in my opinion. So now, of course, scanf. What kind of data are you entering? Well, we are entering a float. And after this, where do you want to store it? Well, we just want to store it in the variable score entered. Now remember to put your ampersand there because it is not an array. So pretty much the user is going to type in some value, hopefully like 90 something. And the first thing that we need to do is take whatever they entered and add it to grade, because remember, grade is the running tally or the running total of all of your scores entered. So grade plus equals score entered. So if they entered 50 over and over again, this would be 50, 100, 150, 200, and score is not going to keep increasing. It's just going to be different every time. Some like 0 to 100. So after this, what we need to do is increase the number of tests by 1. And we can just do that with the little increment operator, plus plus. So okay, we added the score to grade, we increased number of tests by 1. Now the only other thing we need to do is calculate the average. That's the goal of the program. So to calculate their average test score, easy stuff. All we do is take their grade divided by the number of tests, and boom, there you go. And also, we don't print it out right now because that's what we do in this line right here. So the last thing that we need to actually do is just remember, right now this is going to keep running and running and running over and over again because we don't have a condition to tell it when to stop. And we'll say the test for this is when score entered is not equal to 0, keep running. So it's pretty much saying if they entered anything other than 0, do this loop again. So once they enter 0, it's going to break out of it and your program is going to end. So let's go ahead and run this right now and see if I messed anything up, which I did. And what I do, undefine a reference to print because I didn't put printf, and any other bugs. Looks good. Alright. It like took me a second to figure out what's going on. So pretty much said press 1 0. Okay, everything looks good right now. Enter a test score. Let's see if this bad boy works. We'll put 70, 80, and 90 so we can just make sure that everything's working correctly. Okay, so after I entered one test, test 1, average equals 70. Hit 80, well, you entered 2 tests, your average is now 75. Enter 90, you entered 3 tests. After 3 tests, your average is 80, and you can keep doing this forever and ever. 54, and eventually what's going to happen is once the user hits 0, check it out. That's going to process and say, okay, I'm only supposed to do this loop whenever, as long as you didn't enter 0. You did enter 0, and this text down here is pretty much saying end of your program. It returns 0 right here, which signifies the end. So that is a do loop, and it's a pretty cool way that you can enhance your, what's it called, this like average calculating test program, whatever the heck you want to call it. But hopefully you guys understand how that works. If you don't, then just ask me any questions you have, or if you have a bug in your program, post the code on my forum. I'll be happy to answer it for you guys. But for now, thank you guys for watching, and I'll see you next time. Good day, ladies and gentlemen. Welcome to another video, and before I actually start talking to you guys about for loop, which is pretty much what I wanted to teach in this video, I want to mention one thing, and you guys probably already noticed. I included 3 other files, the C-type, string, and math.h, and I actually don't even need them in this video because I'm just talking about loop and they aren't included in any of these. But the reason that I include them right now is because in the future videos, probably like the next dozen or so, I'm going to be showing you guys some really cool functions that are built into C, and they're actually included in these files right here. So since I'm going to be kind of concentrating in this area right now where we're going to be doing the majority of the programming, I want to tell you guys to include them right now, because then later on when we need them, or I teach them, they're going to be there. So I didn't want to forget them, but I had to mention it. So now on to the good stuff, this video, for loops. So what the heck is a for loop, and why the heck do we even need another loop? Well, a for loop is really good when you know exactly how many times you want to loop. You know, whenever we were like working with a while loop, it pretty much looped until something happened or until we told it to break. But for loops give you a lot of control over exactly how many times you want to loop, which are good if you know that in the future. So I'll show you guys the syntax for it, and later on, whenever we're making programs, you'll see why sometimes you need for loops and sometimes they're a lot better than either while or do while loops. So right now, let's just go ahead and I'll show you the syntax. So make any variable an integer variable named bacon, and then a couple lines down, type the word for. Now the basic structure for it is basically the same as a while loop. You just use the word for, or the keyword for, instead of while. However, inside the parentheses, it's going to take 3 different pieces of information, and they're called expressions. Now, the thing you have to do is, unlike just a normal function or something where everything is separated with the comma, these actually get separated with a semicolon because they are indeed expressions. Now, the very first expression, you pretty much have to say, where do you want to begin your loop? So I'm just gonna go ahead and begin at the number 1. So that's why I'm gonna put bacon equals 1. Now the next expression is pretty much gonna say, okay, well, when do you want to end? Well, let's just go ahead and print out 10 numbers. So I'll say bacon is less than or equal to 10. So of course the first two pieces of the puzzle are easy, pretty much where you want to start and where you want to end. So the last piece is actually saying how much do you want to increment by. So if we increment by 1, then it's going to print out 10 times. If we increment by 2, it's going to print out 5 times. And I'll show you guys a sample of this later if you're better visually understanding. But I want to increment by 1, so I'm going to put bacon plus plus. So now, basically what this is saying is begin at 1, stop at 10, and go up by 1. So then this loop is going to loop 10 times. Whatever code we put in here, that's what's going to happen. So printf, and in here, I'm just going to print something out on the screen. And I'll put bacon is, and I'll write the number of the loop iteration that we're on. So %d, and then I'll push it on a new line. I'll just print out bacon so you guys can see what's going on. So let me run this and check it out. So pretty much, as I stated before, it starts at 1, it ends at 10, and because we have bacon plus plus, which means add 1 to bacon every time, that's why it goes in steps of 1 at a time. Now, we're not just limited to steps of 1 at a time or 2 at a time. We can do something like step up by 8 at a time. So let me do that. Let's go ahead and begin at 0 and go all the way to 100 and say that we wanted to step up by 8. Well, in order to do that, just put bacon plus equals 8. So basically this is saying start at 0, go up to 100 like I just said, and go in steps of 8. So now when you run this, check it out. It says 0, 8, 16, and it keeps adding 8 until this condition is met right here. Bacon is less than or equal to 100. So the next one after this would be 104, so that's why it didn't print out. So again, I know this was a real quick tutorial, and you guys are probably still wondering, okay, well, I could have done all of this with a while loop, so why the heck would I even use this? But later on, you're going to see while sometimes for loops are incredibly powerful and why they are incredibly also beneficial in the future programs. So thank you guys for watching, and well, I'll see you next time. Alright guys, welcome back to another video, and I know in the last tutorial I was like, in the future we're going to be looking at these for loops and you're going to be seeing exactly why they are useful. However, I thought I might as well take a break and show you guys a cool little trick, something that I like to do a lot whenever I'm working with programs that simulate, I don't know, like Excel or spreadsheet type programs, and that is how to make a cool little table using something called nested for loops, a for loop inside another for loop, like for loopception. So of course the first thing that we need to do is make a couple variables for int columns and int rows. Now using this program, we're going to be able to tell it exactly how many rows and how many columns we want to print out. Now eventually, if we're reading from a file or something, we're going to get the number of rows and columns from the data, but for right now we can just input however many we want to print out manually. So of course, make the first for loop, and we want to add some space in there. Now the first thing we want to do is create the rows. So put rows equal to 1, that's what you always start at. And for the second parameter, what you do is put less than, or it's technically called the second expression, less than or equal to however many rows you want to create. So let me just pick like 6 or something. And of course, we're just going to do it one at a time so we can create 6. So basically what this for loop is going to do is it's going to loop through 6 times, and I'm going to be printing a new line, and I'll actually do that right now. Printf new line right there. So pretty much every time this thing loops, it's going to bump it down to a new line. That's going to create your rows. So every piece of the information that we print out is going to be on a new line, aka new row. So how do we create the columns now? Well, we need to add another for loop, and inside this for loop, we'll just go ahead and like print out the number. So printf, and we'll just print out, I don't know, like %d. What are you doing, cursor? Obviously not the cursor. Obviously it was me, but you know, gotta blame it on the cursor. Why not? So we're gonna just print out some number right here, and now we have to take care of the columns. So just like before, put columns equal to 1. That's where we always want to start at. And again, just like before, we pretty much now have to say how many columns do we want to create. Well, what we're going to do is set this less than or equal to, I'm just going to put mine at 4. So pretty much I'm going to have a table that's 6 rows by 4 columns. So 24 elements in my table. And I'll just put columns plus plus, and I'll just go ahead and print out the name of the column right here. So now basically what's going to happen is this. For rows, what do I do? Input rows for that. So check this out. As you can see, this first loop right here is going to run 6 times, and that is responsible for printing a new line every time. And the reason that it bumps down is because of this statement. So it's going to run this, then bump it down, so that's why it gets 6 lines. Now on each individual line, all this for loop does right here is it pretty much prints out a number 1 space, 2 space, 3 space, 4 space. So it pretty much just loops through and prints out 4 numbers with a space after it. So whenever we do that for every single line, it pretty much visually looks like columns. So again, this is a way where you can create a fast table, and right now it just says 1, 2, 3, 4, not very useful, but whenever you're creating, like I said, a spreadsheet application or a database and you want to print it out to the user, this is pretty much how you say, this is how many rows we want, this is how many columns we want, and this little script right here creates a nice looking table. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, in this video I want to talk to you about the break keyword. Now the break keyword pretty much allows you to end your loop early. So why would you ever want to end a loop early? And I'll give you guys a really simple example, even though you probably would never use this in real life. Say you made a program to guess a number from 1 to 100. So it started looping through 1, 2, 3, counting, and the number that it needed to guess was 14. Well, once it got to 14 and it got the right answer, there's no need to continue the loop because you already achieved your mission guessing the number 14. So it pretty much saves your program time and resources by ending it early. So even though that loop was capable of looping all the way to 100, we stopped it early because we're good programmers. And it's actually really easy to see if I just build a simple program, so let me go ahead and do that. So the first thing we need is a couple variables. In A, that's just going to be the counter, and for this sample I'll make a for loop. You can actually use this break statement with any kind of loop, while, do while, but a for loop is going to be really easy to see what's going on. So next thing we need is a variable called how many. Basically what we're going to do is we're going to allow the user to enter a number how many times we want this loop to loop. And that's what how many is going to be, and the last variable is max amount, and we'll set this equal to 10. Actually, let's go ahead, yeah, we'll set it equal to 10, why not? And the max amount is how many times this loop is going to loop by default. So by default it loops 10 times, however if the user enters something else it's going to break early. So now what we need to do is give them a little prompt on the screen so they know what the heck they're doing. So how many times do you want this loop to loop? They probably know what we're talking about, even though loop to loop, they get it, you know. And we'll say up to 10. Alright, and actually another thing I want to do is this. I don't even want to add a new line because I think it would be cool if they enter their answer right to the right of that. So scanf, and we need to scan it in, which is of course %d, and where are we going to store that? Ampersand, how many? So what they did right now is they're going to type in a number and it's going to be stored in this variable, how many. So let's go ahead and build the default loop, which is this, for, and we start at 1, and we'll set it less than or equal to max amount. So like I said, by default, this loop is going to occur 10 times. Of course, just increment it by 1, not getting fancy here. And what's this loop going to do? Let's just do something stupid like print it out on the screen. So we'll print out whatever iteration is on %d, and might as well bump it to a new line. Be a little easier to see what's going on. Alright, so again, by default, it's going to loop 10 times. Let's see if it's working right now. How many times do you want to loop? Let's just say 2, enter, it loops 10 times. Okay, so we need to add something into our program to say, hey, you need to check this number right here because I told you to loop 2 times and you loop 10 times. Stupid program. So let's go ahead and do that. And in order to do that, you need to add this statement right after the print. So just add an if conditional and say, okay, if this number right here, whatever loop you're on, is equal to whatever number they entered, which was how many, then break the loop. Now what break the loop is going to do is it pretty much says, okay, what loop is occurring? Well, it's this loop right here, the for loop. So I'm going to stop that and then just continue on to the rest of the program, which is pretty much just end the program, return 0. So now, let me run this, and hello, what are you doing? Actually, let me give myself a little more space. So how many times do you want to loop this loop? Well, I only want to loop it 5 times, so hit enter, and there we go, 1, 2, 3, 4, 5. So basically, it got to this loop and it says, okay, so I'm running this loop 10 times because A is less than 10. So I'm going to run 1, 2, 3, 4, 5, but then it got to that 5 and it said, okay, I have to check this right now. Is 5 equal to the amount they entered? Well, yes it is, so I'm going to break out of this loop. And again, what break means is pretty much discontinue this loop, stop it. So that's why it never hit 6, 7, 8, 9, or 10 because we broke out of that before it can continue with the rest of the loop. Now another thing I want to mention is this. What if the user enters a number above 10, like 26? Well, again, this only loops 10 times because it never hits this conditional right here. A is only equal to 1 through 10. So it's never equal to 26, so this loop never gets broken. So that's a way that we can have the user enter a number, and of course they understood the rules up to 10, they didn't follow them, so they got all 10. So hopefully you guys understand the break statement. Pretty much whenever you want to end a loop early or discontinue it, just give it the break statement, and well, that ends the loop. Simple stuff. Thank you guys for watching. I'll see you next time. Alright guys, welcome back, and this time I'm going to show you guys another cool keyword that you can put inside your loops, a little bit different from the break statement. This one is called continue. Now what this keyword does is it pretty much tells your program, ignore the rest of the code that's inside this loop, but don't completely break out of it. Just go to the top again and restart from another iteration or a next cycle. Kind of hard to just explain by talking, so of course let's look at an example. So let's go ahead and set this num equal to 1, and let's say that we're the coach of a hockey team and we have 10 people on our team, cannot talk today, and we're handing out numbers to every kid. Now some numbers have been taken already, so if that's the case, we're pretty much just going to say, hey, this number is not available, and we're going to be doing that through the use of continue. Now I'm just going to be making a do while loop because I'm kind of sick of those stupid for loops. And the condition is while num is less than or equal to 10. So you pretty much have the numbers 1 through 10. Now, I don't know why it gives me that much space. I don't want that. Jesus Louises. Spend half my tutorial just getting the cursor in the right spot. Okay, so the first thing we need is a condition of when to continue because, of course, well, that's the tutorial. So we'll say, let's pretend that the numbers 6 and 8 are already taken. So if num equals 6 or, two little pipe signs, num equals 8, then what we want to do is num plus plus, because if we don't have this right here, then it's just going to be stuck on 6 or 8 forever, and it's never going to break, or it's never going to get completed, I should say. So num plus plus continue, and I'll talk to you guys in detail exactly what that does after I run my program, because it's going to be a little easier to understand. So this right here outside the condition is what's going to run by default if you don't hit this if statement. So printf, and let's just go ahead and print out the numbers. So %d, and we'll put is available, bump it to a new line, and of course the thing we want to add is the only variable we have, which is number, which is basically the number of their jersey, and num plus plus, so we can go to the next iteration. So again, let me run this right now and you guys are going to see what's going on. So what's going to happen is it's going to say 1, 2, 3, 4, 5. It's going to skip over 6, go to 7, and it's also going to skip over 8. So why did it skip over those things? Well, that's the beauty of the continue keyword. Basically, what this program is saying is loop through the number 1 through 10. That's what it does by default without any of this code right here. However, we added this code to pretty much say check for the number 6 or 8. If you come across that number, then add 1 to it, and that's just so the loop can finish and it doesn't get stuck on the same number, and continue. Now what continue means is this: whatever's after this loop, whatever code comes after continue, just ignore it. As soon as you hit this continue keyword, go right back to the top and start this loop again from 7. So again, once it got to 6, it said okay, don't even run this at all, just go back to the top with 7. So that's why it never printed out 6 and it never printed out 8, because it never got to this line. It just continued, which aka means hop back to the top before this line could even be printed. Now again, it's a little bit different than break because it doesn't completely break out of your loop and continue with this line of code outside your loop. What it does is it stays in the loop and keeps going and going. It just ignores the rest of the code. So hopefully you guys understood, and if you didn't, then just build a simple program like I did, and you guys are going to get it after like 2 times. Very simple concept. So for now, thank you guys for watching. Check out my website, I guess. I don't know what to say. It's always like weird at the end of tutorials. I'm like, well, like see ya tomorrow or whatever. But anyways, see you tomorrow. Alright, y'all. Hope you guys are ready to learn the switch statement, a very cool way, and see that you can pretty much take a variable and test it against several different possibilities or options. Now, this is kind of the same as an if, else statement, but it's a lot cleaner syntax, and you can do a couple different and cool things with it as well. So in this example, I'm just going to be taking a grade, like a student's grade, A, B, C, D, or F, and using that to test, because we know we have limited options. It could only be equal to one of those 5 letters. So let's do that right now. So char grade, set this equal to C, and now here is the syntax for the switch statement. You type the word switch, and then right after it you type what you're going to be testing. So what is the variable that can have those possibilities? Well, it's grade. It can have one of 5 possibilities, which is the letters A, B, C, D, and F. So in between curly brackets, in between these are where we're going to be explicitly writing all of those possibilities that could have. So in order to do that, we use kind of a weird syntax. We type the word case, hit a space, and then type the value that it could possibly be equal to. So again, the first thing is A. Now after this, add another space and add a colon. Not a semicolon, just a regular colon. Now you can pretty much read this like a sentence. So it's saying test grade to see what it's equal to. In the case of A, colon, what do we want to happen? Well, after the colon, you can type either just one single statement, a bunch of statements, as many statements as you want, just like you would inside an if statement. So what I'm going to do is just pretty much print something out on the screen. What would we say to the student who got an A? I don't know. I just say something stupid like sweet, and I don't know why it says sweat with the ANSI. Accidentally hit caps lock there, but I'm just going to leave that. Okay. So apparently if the student got an A, we're going to yell sweat to them. Why? I don't know. Who the heck cares? Now after this, under the statement right here, I'm going to add the keyword break. And once I get done with this entire switch statement, I'm going to explain to you guys why I did that. Because if I just say it right now, it's not going to make sense. So this is what you do if the student gets an A. Yell sweat to them and then just add this keyword break, whatever that does. So on the next line, we need to build another case. So in the case of B, we need to print out something else other than sweat. We'll say, could have tried harder. You know, we got to be rough on the kid. You know, that's parenting 101. Don't take it easy on them. Never. Okay, so now, got a couple other ones to take care of. C. Okay, what would you say if your kid got a C? Well, I would say, I see you didn't study. And that is why I am not dad, because I wouldn't make a very good one. Because I would always use puns when I should be, you know, actually having a conversation with them. But, whatever. Alright, now what would you say if they got a D? Well, I would tell my kid is, that's embarrassing. Is that how you spell embarrassing? I hope so. If not, well, that is embarrassing. How ironic is that? Now for F, what would you say in the case of a F? I would be, actually, let's do this. Let's say in the case of F, we just tell them that that's embarrassing. And if they get a D, just tell them that you love the D. That, again, thank God I'm not a father right now. Now, what this switch statement says right now is this. Test this character right here. If it's an A, do this stuff. If it's a B, do this stuff. So we can pretty much see the syntax of it right now. However, when all your cases are done, we're going to add one last case, and that's default. Now what this keyword basically means is if you go through the options A, B, C, D, and F, and this character isn't any of those, then run this statement by default. So what if we tested every character and none of them equal A, B, C, D, or F? Well, then that grade wouldn't even make sense. So it'd be like, that doesn't even make sense. Explanation mark. Why the heck not? In a new line. Now, if we run this right here, check it out. Right now, it's C. So it said, okay, I'm going to test this. In the case of A, print this out. Well, it's not A, it's not B, it's C. So what do you want me to do since it's equal to C? Well, just print this out. I see you didn't study, which it did right here, and then break. So if we added something else like, I don't know, what's even not a letter, like P, and then we ran this, what this program is going to pretty much read like is, okay, you want to test the grade, is it equal to A? Nope. B? Nope. C, D, F? Nope. So by default, if none of these cases are true, then this is what you want me to do. And it just says that doesn't even make sense because P is not a grade, so that's what happened. So the only other thing we need to figure out right now is what the heck does this break statement mean? So let me go ahead and type B in there so we, forget about the P, and check this out. What this break statement means is just like a loop, it pretty much breaks out of it or discontinues it early. Now, why would we want that? Well, it pretty much is good for speed, and well, let me tell you what it does first. The reason that we want to break early is because we found our answer. There's no need to test if it's C, D, or F. Once we found the case we're looking for, why would we even want to run these? Because we know they're not going to occur. So what break does is say, okay, once you find it, skip over all of these and continue. Pretty much just helps you save memory and makes your program run a little bit faster. So that's what the break does. Again, you already know the break keyword, so you probably already understand it. So hopefully now you guys got a pretty good grasp on the switch statement, and in the future tutorials I'm going to be showing you guys another way that this is incredibly useful. But for now, I actually have nothing to say. So thank you guys for watching. I'll see you later. Alright guys, welcome back to another video, and this video is actually going to be pretty interesting because I want to talk to you guys about a pretty cool concept that we have to learn about in C if we want to become an expert programmer, and that's this. The truth is, even though we can store like stuff like strings and characters and variables, your computer never actually stores the character itself. Computers can't understand characters or words or text like human beings can. They have to convert everything to numbers. So in order to store that character, it actually converts it to a number, and that's how it stores it in its memory. So why am I telling you this? You guys don't care about, the internal workings of computers. You just want to learn how to program, right? Well, the reason I'm saying that is because quite often you're going to come across something like this in your code. Say int tuna, and before, how I don't know, I told you guys that you could set this equal to 74 and like whatever number you wanted to. Well, you can actually set int tuna equal to a character as well, such as B. So before, if you guys saw this in your code, you're like, okay, Bucky told me that this can store integers like whole numbers, so why the heck are you doing this? You're supposed to set it equal to char, you idiot. Well, this is pretty much explaining what I just said. And another cool thing I should point out is whenever you're programming in C, you could pretty much use ints and characters interchangeably almost all of the time. So, okay, I got like a ton of crap to teach you guys. I don't even know where to go from here. So the first thing I want to point out is, how I told you guys to include this file right here? Well, this C type gives us a bunch of built-in characters, so we can actually test, is this a character or is it a number? Because your computer treats everything as a number, and us humans, us mere mortals, we don't do that. So C gave us some cool ways to test if that character is actually a letter or a number. So I'll show you guys how to use those functions right now. So again, make sure you have this imported because I'm going to be using functions from that file. Now the first function I want to tell you about is alpha. Basically saying, is this character, does it belong in the alphabet? Is it a letter? So we need to pass in tuna because of course we need to give it something to test, and this is going to return true if it is indeed a letter. In this case, it will return true since B is a letter. So we can just go ahead and print something out on the screen. And we'll put, I don't know, something stupid like %C is a letter. Now just go ahead and print out tuna and check this out. It says B is a letter. Now you know how I told you guys that you could use ints and characters interchangeably? Well, this is another one of those examples. We declared B as an integer value, but then right here we didn't press %D, we press %C, which means print a character. So that is one of those examples where ints and characters are being used interchangeably. Pretty confusing at first, but you guys are going to get used to it. So after this, I'll show you guys another cool function. and that's this: if is digit. And of course, unlike is alpha, what this is going to do is it's going to test if this is equal to a number. So instead of b in here, just write the number like a 9 or something, any number that you want. So of course, this is no longer going to be true because 9 is not an alphabetic character. It is not in the alphabet. So right here, we'll just print out C is a number. So again, we can still use this character symbol right here, even though we declared it as an int. So run this baby, and we'll say that 9 is indeed a number. Now, another cool thing that we can do is, check this out. Just copy this. Say we have a character that's not a number or a letter or anything like that, like I don't know, a dollar sign. Well, then we can use this else condition to say C is OMG, WTF is that? You know, something simple like that. So if you run this and test the dollar sign for alphabetic, it's not in the alphabet and it's certainly not a number, then it says dollar sign OMG, WTF is that? Pretty freaking cool. So again, right now you guys are like, okay, so behind the scenes it converts everything to integer, but I'm just going to stick with characters for now. However, later on you guys are going to see why this information is useful and how you can do cool things other than just test a stupid character and print out something on the screen. So again, now that you have that knowledge in your brain, make sure it stays there because you're going to need it later on. But for now, thank you guys for watching. Don't forget to subscribe, and I'll see you guys next time. Alright guys, welcome to another tutorial. I don't know why I say that every time. I said I'm not going to say it, and you know what, I went ahead and I freaking said it. It's like a habit or whatever. But in this video, I'm going to be teaching you guys one more cool function, and that is how to test if a character is uppercase or lowercase. And then I'm going to be giving you guys a challenge at the end, and I want to see if you can complete it. So since this function tests if a letter is either uppercase or lowercase, we don't need to include it right here because this bit of code is only going to run if this is numerical or not a letter. So we only need to put it in alpha because that ensures that it is a letter. So the if condition is this. The function is called isUpper, and what it does is you pass in a character and it returns true if it's uppercase. So if you have something like F, this would return false, but an uppercase F would return true. So from here you can just print something out on the screen like C is an uppercase letter. Now else, since we already know this is a letter because it passed isAlpha, it passed this test, and it's not an uppercase, we know that if it got to this line of code it would be a lowercase letter. So now let's go ahead and run it against capital F. Capital F is an uppercase letter, and just make sure everything is working correctly. Lowercase g is a lowercase letter. So now we know how to test if something's a letter, if something's a number, if something is a symbol, if it's uppercase, lowercase. So you guys have some homework now, and you're like, what? Just watching a YouTube video, this isn't school, gonna give me homework? Well, actually we'll call it a challenge, and that's this. This function right here and these functions that I've been teaching you guys for the last couple of tutorials are really useful whenever you're building a piece of software and you want to ensure that the user enters a good password. So I want you guys to build a program where the user enters a password by scanning it in, and it checks it for an uppercase letter, a number, and we'll say a dollar sign. So again, check or write a piece of code that checks the thing they typed in and make sure it has an uppercase letter, a number, and a dollar sign. And if it does, then just output, okay, your password is good to go, or something like that. If not, output, hey, your password sucks. Now once you're done with it, post it in the forum and hopefully um, we're going to see a bunch of awesome looking programs. And also, whenever you're writing it, if you have any trouble, then post it in the forum as well, and I'll show you guys what you did wrong and give you guys some tips on how to complete it properly. So hopefully you guys have the knowledge to do that so far, and well, looking forward to seeing your programs. Alright guys, I am in an incredibly good mood right now because about 2 days ago, gotta tell you guys a little story before I start teaching you this tutorial. 2 days ago, I was walking around and I bumped into one of my friends, and she was with this other girl that I never even met before, but she was not my friend. The other, I mean, my friend's pretty too, but the girl she was with was, oh my god, incredibly hot. She was like way out of my league. So later that night, I sent her a friend request because I don't know, I'm an idiot, and I was like, why the heck not? And just like 2 minutes ago, got a chime on my phone. She just accepted my friend request. So I don't even know what to say to her because I'm nervous. And like I said, she is like a 9, and I'm not like a like disgusting, but I don't know. Just saying she's out of my league. So if anyone has any suggestions what I should say to her, thinking about just messaging her back, hey, but that's stupid. So give me something good, and later on I'll send that message, and we'll see how it goes. Keep you guys up to date. But for now, let's get back to programming. And the first thing I want to talk to you guys about is how to convert a lowercase letter to an uppercase one. So, I'm probably going to be giddy all tutorial because this girl accepted my freaking friend request, but you should see her. Alright, so, see if I can concentrate. So let's make a couple characters. First one's going to be a lowercase. The second one, char B, set this equal to char A, and I'll just copy this because I'm lazy. Char A, char B, and we'll set this one equal to uppercase, which is F, and we'll set this last one equal to, do we want to set it, yeah, we'll just set it equal to like a number or something. So now we have three characters. One is lowercase, one is uppercase, and one is a number. You can use a symbol too if you want, like a dollar sign, parentheses, whatever. So basically what I want to teach you guys is how to take a lowercase letter and convert it into an uppercase letter. So of course we're going to print out a character on the screen and just print out each of these on a new line. And the function for this is toUpper. toUpper. Kind of looks like a cool little word. But whenever we pass it in a character, such as A, of course what this is going to print out is an uppercase A. So before, I think this is one of the first functions where we actually modified the variable. I mean, in the past functions, what we did is we were just testing it. We didn't actually change the value, we just tested it. Was it alphabetic, was it a digit, so on and so forth. But this is actually going to change this lowercase a and print out an uppercase A. So now you're wondering, okay, well, what's going to happen if I pass it in a number that's not lowercase, such as capital F, or something that isn't even a letter, like 7? Well, the rules for this function are this. Whenever you pass it in a character that's lowercase, it's going to turn it into uppercase. Whenever you pass it in anything else, it's pretty much going to give you back the same thing that you passed it in, since it has nothing to do with it. So again, it's going to turn A into capital A. It's going to turn capital F into nothing, leave it the same. Same thing with numbers. Simple enough. So the reason that you might want to use this is, I don't know, maybe you're making a program and you let people enter their first and last name. Well, if they enter their name like this, Bucky Roberts, what you would want to do is take that first character and uppercase it. And also, it's pretty cool because you can use that same function and run it on that first character no matter what. If it's uppercase, hey, run it anyways, it stays uppercase. Pretty freaking sweet. Definitely useful. This is one function, of course, I don't use C, but I use it on my website, my social network. Very handy. So now we're going to take a break from characters, and I want to talk to you guys about a couple string functions. So of course, that is why I included this little file right here, string.h. This header file comes with a bunch of cool built-in string functions, And with strings, you can do things like replace them with each other, combine them, tack them onto one another, and I'll show you guys what I'm talking about right now. So go ahead and make a string and make it like 100 characters long, because we need to make sure it has a bunch of space in there for what we're about to do to it. And I'm just gonna put something stupid in here like hey right now. So right now we have this string called ham, and it's actually a character array, but right now it's just equal to hey. Pretty freaking stupid. So let's see if we can spice this up a little bit. So the first function I'm going to be teaching you guys about is string cat. Now, unfortunately, that doesn't mean strangle my cat outside. It means string concatenate, which pretty much means, in everyday language, tack on one string to the end of another string. So this takes a couple pieces of information or parameters. The first one is, what is the original string? Well, in this case, it's just ham. It's just this string right here. Now, the second parameter that it takes is, what do you want to tack onto it? What other string do you want to add to the end of this? And we'll just add the string Bucky. So if we printed this out right now, which I guess we can do. Now to print out a string, remember it's %s. And we'll just bump it on a new line. And we'll print out ham. So basically what this did is it took the original string, which was hey, not hey like a horse, just like hey, what up, beautiful girl that I just met, and it added another string, in this case Bucky. Now the cool thing about this is this string is now part of ham. So we need to make sure whenever we're creating this original string ham that it is long enough to hold whatever strings you're going to tack onto it. So originally this was 1, 2, 3, 4, 5 bytes long. Remember, all the characters plus the null terminator, that 0 special character at the end. So this one, 1, 2, 3, 4, 5, 6, 7, we need to make sure that we never pass 100 because this can only hold 100 characters. So if we keep tacking on strings to the end of this bag, hey Bucky, you, what else can we say? You smell. So if we add something like that, again, just reiterating one more time, make sure that make sure that your original string is long enough to hold anything you add on to the end of it, because if you go past it, you're going to have a real bad time. So another thing I want to point out is, actually I'll teach you guys about one last function for this tutorial, and this is called strcpy string copy. And what this does is it essentially replaces one string with another string. So the first one is, what's your original string? Well, it's ham, and right now ham is equal to hey Bucky, you smell. But say we wanted to get rid of that completely because, guys, I don't smell, I promise you. We wanted to replace it with Bucky is awesome. Well, what this is going to do is it's pretty much going to take this string and it's going to overwrite everything in this string right here. So now Bucky you smell is no longer more, and now ham is equal to, let me fix that, it's annoying me, Bucky is awesome. Pretty freaking sweet. So I know that these functions look kind of similar, but string cat means tack something onto the end of a string, and string copy means replace one string with another. Simple stuff, and we're going to be using this a lot in the future. So for now, thank you guys for watching, and guys, give me something good to say to her. I can't F this up. She is freaking hot. So, well, I'll see you later. Alright guys, welcome back, and in this video I'm going to be teaching you guys two new awesome functions, and those are called puts and gets. Now, puts and gets are two awesome ways of A, printing strings to the screen, and B, getting strings from the user. If you guys are like Bucky, we already have a way to get stuff, and that's scanf. They can type crap into their keyboard, but if you remember, scanf has one huge problem, and that's whenever it tries to scan in a string with a space, it pretty much breaks our program. For example, if the user tried to type in something like Bucky Roberts, it would scan Bucky, and it would view this little space right here is the end of the string. So it wouldn't even read this last one, this last name at all. Well, in this video, what I'm going to do is I'm going to show you guys a way to scan in strings incredibly easily that can have spaces in them as well. So let's go ahead and make a couple character arrays. I'll just print out something like cat's name and make this equal to 50 or something. So the goal of this program is it allows the user to enter a cat's name and also we'll say like a cat's, I don't know, food or something, and it'll just print it out on the screen. We'll say like cat's name eats cat's food. Now the last thing I want to do is I want to make a blank. And we'll set this equal to 75. Can't even talk while I'm typing. I want to make a blank character array, and this right here is where we're going to be storing the final result that we're going to print out on the screen. So pretty much the user is going to scan in a string for this, and then we'll use the functions that we learned before to develop a new string. So in order to just print out a string on the screen, we can use printf, but I got to tell you guys a new way, and that's puts. Now, in between puts, it only takes one parameter, and that's what's the cat's dumb name. Now, another thing I want to mention is this. Whenever you use puts, unlike printf, it automatically adds a new line to the end of this. So you don't need to add one explicitly unless you want two new lines, or in other words, a space in between the next line. So again, even though you can't see it, there is a new line character there. So this next function, gets, which is going to act like scanf, at least it's pretty much a scanf that you can use spaces with. And the only parameter that this takes is where you want to store the string that you're scanning in. So again, if we just run this right now, you guys are going to see that this cursor is on the next line because that's how puts works by default. So we can just enter a name like hey, because it doesn't have any functionality right now, so let's change that. So right now, whatever the user types in is stored in the character array or the string cat's name. So for this next puts right here, we can put what does he eat. Now you can type anything you want and it's going to be stored in cat's food. And that's all you have to do. That's how simple it is. So again, like I said, it's a lot easier than using printf with a bunch of different parameters or scanf for gets with like the ampersand and all that confusing crap. So we basically have two strings that we could use. So how about we use one of those cool functions, string cat, and what this is going to do is tack on one string to the end of another. Now since this sentence is the final string that we're going to be using, let's go ahead and first tack on the cat's name to this. So after this line completes, this sentence is pretty much just going to be equal to the cat's name. We'll say it's Bucky. So after this, we need some text in between, and we'll just put loves to eat. So after this line, it says Bucky loves to eat, and now we can just go ahead and add the name of the food, which is cat's food. And the last thing that we need to do is, since we built the string piece by piece, it started off blank and now it has three parts to it, all we need to do is print it out on the screen. And of course, to print stuff out on the screen using this cool new function, we use puts, and the string that we want to print out is sentence. So let's see how this program works right now. So what's the cat's dumb name? Well, my cat's name is Pussy McStanky, and again, I'm using a space in between here. Hit enter. What does he eat? Bagels. I'll just make a simple string for that to show you guys that it can also take simple strings without a space. Hit enter, builds the string, and our final one is Pussy McStinky loves to eat bagels, and indeed he does. So again, prints a string out on the screen, gets can get a string from the user, and the cool thing is that that string can also have spaces, and the string cat can build a string piece by piece by piece and print out the final one on the screen. So pretty cool string functions, and definitely a lot easier than using printf and scanf with a bunch of those optional parameters and ampersands and freaking weird stuff like that. So for now, thank you guys for watching. Don't forget to subscribe, and I'll smell you guys later. Alright guys, in this video we're going to be starting to talk about some cool math functions. However, before I do, I want to show you guys what someone posted on Bucky's room real quick. For some reason, I thought this was probably more funny than it actually is. Probably because it has a cheeseburger in it, and I think cheeseburgers are hilarious. But it said I asked for a MacBook Air for my birthday, and they posted a picture of a Big Mac, a book, and a bag of chips, which is mostly Air, as you know. Ugh, cheeseburgers gets me every time. So, like I said, in this tutorial I'm going to show you guys how to round up and down numbers, and the built-in functions for this are in this math header file. So if you didn't include it before, make sure you're including it now. So whenever you're rounding up and down numbers, you always want to use floats, because if you use ints, it's going to be worthless because they don't need any rounding, they're whole numbers. So make a float and call it bacon1, or else it won't work. I'm just kidding, it'll work if you name something else, but who doesn't love bacon? Actually, let's set this equal to like something stupid like that. So we'll make a float bacon1, and we'll also get a number that we can round down. Like, I don't know, make this one a little easier. 3.3. So now we have 2 slices of bacon, and the first thing I'll talk to you guys about is floor. So we'll just print out the final number right now. So we'll put bacon1 is, and we'll just print out the 2 decimal places. Why the heck not? %f, 0.2, and of course right here we want to put in bacon1. Actually, not just yet. So the function that we need for this is called floor, and the only parameter it takes is that float that you want to round. Now, no matter what this number is, it's going to round it down to the nearest whole number. And you guys are like, okay, well, in math class, whenever I was rounding numbers, I said, I looked at the decimal place, and if it was 5 or above, I rounded it up, and if it was anything less than 5, I rounded it down. Well, your computer isn't as smart as you. It either says, okay, am I gonna round this number up or down? And you have to tell it explicitly what to do. So no matter what it is, floor is going to round it down. So I'll demonstrate that by putting bacon2, and I also want to copy this and show you guys the other function, which is seal. And make sure you don't spell it like this, seal, because that will not do anything. Now seal, what this is going to do is it's going to take whatever float you pass it in and round it up to the next highest number. So check this out, and actually I should include a new line, or else it might be a little bit difficult to see what's going on. So again, bacon1 was 9.6 something. Now whenever we hit floor, it rounded it down to 9, and whenever we hit seal, rounded it up to 10. Bacon2, same thing, even though it was less than 5 or 3.5, and in your head you might be thinking always round it down. Floor rounds it down to the next whole number, and seal rounds it up to the next highest number. So again, rounding in C works a little bit differently than rounding in real life. You need to tell it explicitly whether to round up or round down. So now that we understand that concept, we can now move on to some little more advanced math functions, and that includes absolute value, and I want to show you guys also how to use something like power, square root, and a random function to generate random numbers, something you're going to use a lot whenever you make computer games. But for now, thank you guys for watching, and well, smell you later. Alright guys, it's time to learn about absolute values because you're going to be using them a lot in computer programming, and the reason for that is because they are awesome whenever you're doing stuff like calculating dates or maybe the weight of something or the distance, because you're going to allow the user to enter two values, such as maybe they're calculating their age. Well, what if they put the year that they were born first, like 1986, and they try to subtract the current year from it, like 2014? Well, if they did that, then it's going to give you a negative number because you're subtracting a bigger number from a smaller one. And of course, their age wouldn't be negative 28, so you need to convert that to a positive number so your program doesn't crash. So again, it's good for distances and weights and ages. So I'll show you guys how to build a simple program like that right now. So we'll go ahead and put int year 1 and int year 2, which is pretty much going to be the 2 years that they enter to calculate the age of something, and we'll store the final age right there. Now for printf, let's just go ahead and give them a nice little prompt on the screen. Be like, enter a year. No, enter a tier. You have to be crying to use this program. Alright, enter a year, new line, and we'll just scan F. And for this, of course, we're scanning %d since we love working with integers, and ampersand year. Ampersand tier, year 1. Alright, so now whatever value they entered, hopefully it was an integer, we store it in year 1. Of course, we need to do this again. Enter another year and store that in year 2. So now we got two numbers, integers. So the first thing we need to do is make an equation to calculate the age. So age equals year 1 minus year 2. Now this actually doesn't matter since we're going to be using absolute value. You can put year 2 minus 2, 1, you know, it won't make a difference. Cool little thing about this. So what I want to do after this is actually print out the value that we came up with first. The value, or the original value, that we calculated without using absolute value. So print out %d, new line, and age. Now after this, what we're going to do is we're going to figure that this number that we came up with can either be the correct one if they entered you know, one of the numbers first, or the wrong one. It can be negative if they entered the smaller number first. So no matter what, we want to go ahead and calculate the absolute value using the function abs. So whenever we pass age into here, if it's a negative number, it's going to convert it into the positive number. If it's positive, it's just going to leave it the same. So now when you print that bad boy out again, check it out. Enter year 1986, enter another year 2014. Okay, so this one, it tried to subtract 2014 from 1986 and it got negative 28. Well, you don't want to put that in your program or else it's going to crash everything later on. So the absolute value converts that to 28, and of course, if they entered it correctly, which is 2014, 1986, it calculates 28 and leaves it at 28. So again, whenever you're developing software, you always want to assume that the user is going to F something up, and you want to make your program as user-proof as possible. So using absolute value is a great way to do that. Sometimes it's necessary whenever you're using distances. Like if I was to put two distances in there, then either way would be the correct way for the user, so you'd still need to use absolute value. Same thing with weights and so on and so forth. So for now, that's probably good for this tutorial. Thank you guys for watching. Actually, might as well show you guys some other small ones real quick, and let's see what I can do. Go ahead and do this. So we'll just use one print statement and we'll print out a couple floats, and I don't need to make a whole tutorial for these. The first one is this function, pow. Now what this means is whenever you run this, you have to punch your computer as hard as you can until your fist goes pow. I'm just kidding. Actually, it stands for power, and you need to enter two values for this. The first one is the base, and the second one is the exponent. What this is pretty much saying is I want to see 5 to the third power. So if you guys don't know what this is, it should be 125. So pretty much 5 times 5 is 25 times 5 is 125. So that's what that does. Again, I don't need a whole tutorial explaining that. And the only other one I wanted to mention real quick is SQRT. This stands for squirt, and you have to squirt water on your computer. Just kidding again. So this actually stands for square root, and whatever number you pass in, like 164, it prints the square root of that number. So before I run this, can you guess what it is? Square root of 164. Probably, I don't know, 12.6 something? 12.8. I was close. But basically, the square root of 164 is 12.8. Maybe you guys guess closer than me. So those are a few math functions. Again, out of all of those, you're probably going to be using absolute value the most, but now you have the power function and the square root on hand. So, well, for now, thank you guys for watching, and I'll see you later. Alright guys, welcome back to another video, and in this tutorial, I'm going to be teaching you guys about my favorite math function of all time, and that is rand. It's the function that generates a random number, and the reason that I love this so much is because whenever I'm making computer games, this is the piece of code that makes it fun and unpredictable. Without a random number generator in computing, every game would be like boring and bland. So let me go ahead and show you guys how to use it, and then I'm going to show you guys how to tweak it to tune it specifically to the game you're making. So I'm going to make a loop to print out a bunch of random numbers. So for that, I need a counter variable, and later on I'm going to show you guys how to get a random number in a custom range, such as if you're making a dice game, you just don't want any random number in the world. You want a specific set of numbers, in this case 1 to 6, because those are the numbers that are on a dice, not like 800. So let's just go ahead and make that for loop right now. And the first thing I'm going to do is set I equal to 0, and how many numbers do we want to generate? Doesn't really matter. I'll just put I is less than 20. Print out 20 or so. That'll be good. And of course I++. Now the first thing I want to do is just show you guys what it looks like by default without any customization. So printf. Of course, what this function does is it generates a random integer. So just press %d, and might as well bump that to a new line. If we don't, it's going to look like one big number. Now the function is called rand, and if you don't add anything in there by default, then what it's going to do is it's going to return a random integer from 0 to somewhere above 32,000. I think it's 32,767 by default. And the reason that this sounds like a weird number and, you know, kind of a random one is actually it's a very precise number. It has to deal with how your operating system stores bits and bytes on your computer. For now, you just have to remember that it's somewhere from 0 to 32,000 and something. So let me print this out on the screen, and you see we get a bunch of random numbers somewhere in that range. Pretty cool, but like I said, we typically just don't want a bunch of random numbers. What we want most of the time is just a range of numbers. Like I said before, you're rolling a dice. Whenever you're rolling a dice, you want the numbers 1 to 6. So how can we take this function, which gives us the range of 0 to 32,000 and something, and make it only output 1 to 6? Well, I'll show you guys how to do that right now. So take this dice roll and plop it down there, and the equation for this is going to be parentheses, and in those parentheses type the function rand. Now right after this, hit modulus 6. Now remember, what modulus does is it takes this number on the left and divides it by the number on the right. However, it doesn't give you the result, it gives you the remainder of that. So whenever you divide any number by 6, you're going to get the remainder 0, and that's if 6 fit into the number perfectly, like 36 divided by 6 gives you 0, or it's going to give you the number 1 through 5. So this entire function is either going to give you 0, 1, 2, 3, 4, or 5. So of course, we're pretty much off by a step of 1 because the dice is not 0 to 5, but 1 to 6. So now all we have to do is take that expression and add 1 to it. So now dice roll is equal to the numbers 1 to 6. Simple enough. So now we can just go ahead and print that out. We could actually didn't even need to delete that earlier. But %d, kick it to a new line, and dice roll is what we want to print out. So again, run this bad boy and check it out. What happens now is it prints out, and actually, do we have no 3 in here? Cool. Oh, there's a couple. How did I miss those? Right in the middle. But basically what this does is it prints out somewhere in the range of 1 to 6. So if you want to have any kind of dice game, then this little formula would be perfect for it. So again, the only other confusing thing might be this right here, because I think it was the first time we actually used that modulus operator in a useful function. But for now, here's what I want you guys to do. Since you have all the building blocks to build a more complex program, this is your next challenge. I want you to create a game where the user rolls 3 dice and it prints out their total to them. Dice A plus dice B plus dice C. So after it gets the sum, the user is going to look at it and it's going to guess if the next row is going to be higher, and if it is, they'll just type in H and press enter, lower, and they'll press L, or the same, and they'll press S and hit enter. And then they're going to roll the dice again, and if they got it right, if they guessed correctly, we'll just like print out good job. If they got it wrong, print out you suck. And well, that's it. So I think you guys can complete this challenge. If you can, then post it in my forum, and well, I'll congratulate you. If not, then post where you're having trouble with in my forum, and I'll help you out with it, or someone else will. A bunch of people there are willing to help. So that's your challenge. Thank you guys for watching. Don't forget to subscribe, and I look forward to seeing your games. Alright guys, welcome back, and in this video I want to start talking to you about int and float arrays. Now, there are actually a lot of differences between int and float arrays and character arrays, so I'm just gonna cover those in this video and probably maybe even the next video. I'm not sure, who the heck knows. So what we're going to be doing is I'm going to be creating a basic array, looping through it, and showing you guys the differences and where you might get stuck up on them. So int I, that's just going to be my counter whenever I loop through them. Now, of course, just like a character array, what you do is you put the data type, and I'm just going to make a simple int array, which is going to hold integers, and I'm going to name it meatballs. Now, in between the brackets, of course, you write how many elements you want to hold. Now, whenever you want to populate your array, what you do is you use curly braces, and you pretty much type a list of numbers in here. So just put 7, 9, like 43, 21. Now this, of course, is called initializing the array. Pretty much the spot where you create the array. Simple enough. Now, one other major difference I want to point out is int and float arrays are different than character arrays because they don't have that null character at the end. They don't have that null 0. So that's more for the internal stuff, but you probably should remember that because it's going to come up later if you try to get the size of the array or anything like that, or you're looping through it and it doesn't seem quite right. So just remember, whenever you're working with numbers in an array, there is no null 0. That's just for strings and character arrays. So now let's go ahead and make a for loop so I can show you guys what up. And in 0, and I'll put I is less than 4 and I plus plus. And in a second I'll show you guys how to populate an array through a loop. It's kind of different than this line right here. But for now we'll just printf. And what can we do? We'll put like element %d, and then we'll put %d, and for the first one we'll just print out I, which is whatever loop we're on. And the second one will access an individual element using meatball. And of course, just like before, we put the element's name in between square brackets. So, actually, let me put a new line here and print this bad boy out. So just like before, starts at 0, 1, 2, 3. That means it has 4 elements total. 7, 9, 43, 21. And again, no 0 at the end. So I guess we have time for it in this tutorial. So now what I want to show you guys how to do is populate an array using a loop. Because even though this is really simple syntax right here, it's not very useful and also not very practical. Sometimes you're going to want to read through a database, or you're going to want to let the user enter a series of numbers through the keyboard. So I'll show you guys how to do that. So we can actually get rid of this right here, and let's make an array with 5 in it. That'll be a little bit better, a little bit more even for my ADD. Alright, so let's just go ahead and build a simple program where we let the user enter 5 numbers, we store it in an array, and we'll say we'll calculate the average or something. So we'll say that the user is going to enter how many meatballs they ate, and we'll calculate the average of, how that means you ate this many per day. Simple enough. So we got int I for our counter. Int meatballs is going to be how many they ate. And of course, whenever we're calculating average, we need total balls, which is going to hold the total amount. Just set that to 0 for now. Alright, so pretty much every single loop, we'll go ahead and give them prompts. Be like, how many meatballs did you eat on day %D? And kick that to a new line. And then, since this is going to start with 0, what we want to do is put I plus 1. And this isn't going to change the value of I, it's just going to display whatever the current value is plus 1. So it's perfect. It'll be better for the user to see what the heck is going on. So now let's give them an area where they can scan in a number that they entered. And of course we want to store this in meatballs. So ampersand and I, looking good. So basically right now, whatever they enter, and they're going to enter it one by one, it's going to be stored in meatballs, in first meatball 0 all the way to meatballs 4. So now we have a populated array, an array full of numbers. So the only thing we have to do now is loop through the same way we did before, but now we're going to use those numbers to calculate the average. So we're going to store the total number right here, and for each element of the array, we pretty much add it to total balls. Total balls, kind of funny variable name. Alright, so say we enter 1, 2, 3, 4, 5. It's going to add 1, then 2, then 3, then 4, then 5, until total balls now equals the total amount of balls. So now we have to get the average of those. So int, make a new variable for our average, and set this equal to, of course, you guys know how to calculate average, the total over how many days. Well, we inputted 5 different numbers, so that means 5 different days. And now we just print this crap out on the screen. So the first, well, what can we do? We'll just put something simple. Put you 8 percent meatballs total. That's an average of %D per day. Simple enough. Looks alright. So the first one is you ate total. Give them their total first. And their average is, of course, the average. Let me kick that to a new line because it's bugging me. And actually, I want to put this on a new line. Give myself a little bit of space to work with. So now, if everything looks good, alright, I think I'm good to go. So how many meatballs did you eat on day 1? I only ate 12. On day 2, I was pretty hungry that day, 98. Day 3, 561. On day 4, I only ate 2, and on day 5, I ate 66. So I ate 739 meatballs total, and this is actually pretty accurate because I do love meatballs. I get like a meatball sub every other day. Average 147 per day. Pretty sweet, and that again is how you let the user enter or populate an array manually. And whenever you're reading like from a Excel file or a comma separated file, you're pretty much going to use the same concept of taking pieces of data and entering it into an array, but it's going to be slightly different. But now that you understand the concept, it's going to be really easy to understand later on. So for now, thank you guys for watching. Don't forget to subscribe. Check out my website. I'll see you later. Alright guys, welcome back, and in this video I'm going to be teaching you guys a program that is pretty much the reason why I got kicked off of a fantasy hockey website. And if you don't know what fantasy hockey is, then I'll explain it in like 2 seconds. It's pretty much a game that you can play on the computer, and you can actually bet money for it. A lot of people do. That's what I was doing. And what you do is whatever players are playing in a hockey game that night, you pick whatever players you're going to think are going to do the best, score the most goals. And whoever picks whatever players correctly, and they do score the most goals, then they win the money. So what people usually do is they look at last year's stats for that player, but this can kind of be deceiving because some players score a lot of goals just because they played in a lot of games. It doesn't mean they're a real good player. And another example is sometimes a really good player gets injured, so maybe they didn't score a lot of goals that year, but you know that they're really good. So instead of just looking at the total amount of goals they scored, it's really good to see how many goals they scored per game. So I'll show you guys how to calculate that right now, and we're going to use something called parallel arrays. And if you guys don't really understand how fantasy hockey works or anything like that, it's going to be real simple to follow along. You guys are going to, I don't know, probably want to play by the end of this tutorial. So we're going to be creating a couple arrays and looping through them all at the same time. So let's go ahead and make a counter variable. And what we're going to do is we're going to make our first array of players. Now say that we only want to test 5 players right now, but usually this is like 500 or everyone in the entire NHL or whatever it is. So I'll just put the player's number right here. So there's a player with a jersey 58, 66, 68, 71, and 87. Sidney Crosby. Awesome player, except Malkin is my favorite. But anyways, let's focus here, Bucky. Alright. So the next array I want to output is how many goals they scored in total that season. So again, 5, and in curly brackets I'll put, I don't know, something like 26, 39, 25, 29, and 31. So what this is basically saying is the player 58 scored 26 goals, 71 scored 29 goals, so on and so forth. So all of these arrays are related. So now we just need a couple more things now that we see how the arrays are related. So int games played, and set this equal to, and the values don't really matter here as long as you have 5 values in there. I'm going to set this equal to 30, 30, 28. We'll say that there's 30 games in a season. So a couple players played in all the games, and of course this player only played in 28, and this player, he got hurt, so he could only play in 26. So I actually need 3 more variables. Or one of the other ones I need is an array called PPG, and this is points per game. So again, this is how many goals they scored, but it doesn't tell you who's the best because we want to find out how many goals did they score per game. So for example, let's look at something. So this guy, he played in 30 games, but he scored 39 goals. So it's better than this guy who played in 30 games, but he only scored 26 goals. So again, this guy would be better, and you guys are going to see real easy later on what I'm talking about. So the last thing that we need is a float and this is going to store the best, pretty much the best player's points per game, and we'll just set this equal to 0.0 right now. And the last thing we need is int best player. So I know that those are a lot of variables in arrays, but it actually only takes like 3 or 4 lines of real code aside from the loop to figure everything out. So now I'm just going to create a basic for loop, and again, the idea of this for loop is to loop through all of these players one by one and calculate their points per game average. Very simple stuff. So for the counter variable, just put I equals 0 to start, put I is less than 5, and I plus plus. So this is going to loop through 5 times, like I said, 1 for each player. So in order to calculate the points per game, see right now this is empty, and that actually should be a 5 in there. See right now this is a float array that can hold 5 different floats, and it's going to hold the points per game for each player. So we'll put ppg and I, and just like before when I showed you guys how to manually type stuff in, well, you can also do it algorithmically. So of course the points per game is goals of that player, and each player is I over the games played for that player. Now check this out real quick. The points per game is pretty much a statistic, and any statistic we want to make sure to include the decimal point. It's a float. However, goals, of course, you can't score half a goal, and you can't play in half a game. Well, maybe you can if you get injured, but not in this case. So what we want to do is, since we're looking for a float right here, we need to typecast these ints into floats. So that's a case scenario where typecasting does come in handy. So even though these are ints on the right hand side, we want to treat them as floats, so that way whenever we do this arithmetic, we get our answer, points per game, in a float in a nice decimal. So the next thing I want to do is just print out something on the screen. So I'm going to loop through 5 times, and I'm pretty much going to print the player's stats on each row, so it looks like a real pretty looking table. So again, the first thing I'm going to print out is their number. So %d tab, I'll print out the number, the goals, the games played, and the points per game. So %d, actually I can do this, %d, 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 and the last one is the float. So that's why I want to do %f, and we'll just display to 2 decimal places. And remember, each player is on a new line, so kick it on a new line. And now you have to say, okay, well, this is the format. What exactly do you want me to print out? Well, the first one is just the player. So this is going to print out their jersey number. The second one, what did I want to do? I'll go ahead and print out their goals. How many goals they scored that season. The third one is games played. And the last one is what we just calculated, points per game. And this is pretty much the value that we're looking for. The player with the best points per game, as you know, is the one that we want. So right now, we can actually just do something like this. If we run this baby right now, and we get an error because why? And it is because this goal is supposed to be goals. Alright, now try this again, and check it out. So this is what we have right now. The player 58 scored 26 goals in 30 games, so he had an average of 0.87 goals per game. The player 66, he looks like the best because he scored 39 goals in 30 games, 1.3 points per game. This guy down here, 87, pretty good too. He scored 31 goals, not anywhere near the most, but it only took him 26 games to do it, so that's why his stats are so high. So we could actually just finish this right now and say, okay, find the one with the highest points per game. It's 66, easy enough. However, the problem with this is whenever you're doing this for an entire league, whether it's a soccer, a football league, or a hockey league, looking through all that data can be kind of painstaking. So what I like to do is add a really simple condition right here that just at the end, it just tells you who the best player is. And this is actually really easy to do. So of course, we get the best player based on their points per game. So we'll say that if points per game for whatever player you're currently looping through is greater than the best points per game, and again, this is going to say, okay, the first time, we'll say that the first player is the best, since by default it's 0. And then every other time, so right now on the first loop, 58 is the best. On the second loop, it's going to say 66 is the best. And he's going to remain the best as long as no one beats him out. So as long as no player is better than the current player with a high score, I guess you could call. And the logic that we use to do that is this. Should probably type this out before I start talking. And the best player, which you stored right there, is equal to player I. Where you at? Player I. And I'll actually just finish this program real quick, and then I'll explain to you guys what this last line does. So printf. And I'll kick this to a new line too. I'll put the best player is %d, new line. And of course, we're going to store the best player in this, and let me print it out, and then I'll talk you guys through it. So right now, it pretty much not only calculated the player's points per game, which is awesome, but it also automatically just gave us the best player at the end. So we don't have to, look through 500 pieces of data manually. Now we already know what this for loop does right here. I just explained it. But the reason that we get the best player at the end is because it always stores the guy with the highest score until it gets overridden. So this is the player you're looping through, and this condition is only going to be true if they're better than the current best points per game player. So if they are, then we say, okay, the best points per game is now this points per game, which would mean that the best player is that player. Again, both I, which in this case would be 0, 1. Pretty freaking sweet. So that is how you check for the best player, and he gets stored in this variable until you decide to print him out at the end. So if you guys don't quite understand how fantasy hockey works, then at least you understand how to loop through, and these are called parallel arrays. They're pretty much arrays that you can use in parallel with each other. For example, every player has goals, games played, and points per game. And well, whenever you're making something like a spreadsheet or something like that, you're going to use these a lot. So well, that's actually all I have for you for now. I don't want to blow your brain up. So I'm going to go cheat at fantasy hockey a little more. If you wanted to, I welcome you. If you want to add some more columns, then add them, post them on my forum so I can check them out. I'd love to see them. But for now, thank you guys for watching, and I'll smile you later. Alright guys, welcome back to another video, and in this tutorial, what I want to do is I want to talk to you guys about sorting. How to arrange elements in your array from either lowest to highest or highest to lowest. And unfortunately in C, there's not a built-in function to do that, so we need to make our own. And there are many different techniques that you can use to sort things. I'm just going to be showing you guys a really simple example. It's called a bubble sort. So we're going to be creating a random array, or excuse me, an array of random numbers. We'll say like 10 numbers or something. And then we'll sort it so the lowest or the smallest numbers are at the top, and it goes from small to big or low to high, whatever you want to call it. So let's go ahead and get started. I'll just put int I, temp, and swap. So basically we're going to start with 3 integer variables. This I, of course, is just a counting variable whenever we use our loop. This temp, whenever we switch one number with another number, if we just try to switch it all in one shebang, then one of the numbers is going to get overwritten. So that's why we need this temp variable. It's temporarily going to store a number. And the swapped is either going to be 0 or 1. And it just keeps track of when basically when we're done sorting our list. You guys are going to see later on. So now, just to keep things simple, I'll put how many I'm going to set this equal to 10, but basically this is the variable to say how many elements are going to be in your array. I'm just going to have 10 numbers in it, so of course 10. And I'll say that I'm a coach of a hockey team again, since I love hockey, and I'm arranging my players' goals from lowest to highest, see who's the best player. So how many? So I have an array named goals, and of course it's going to have 10 different players in it. Simple enough so far. So the first thing I want to do is actually create that array, which is going to be just random numbers. So create. Actually, I won't even add comments. I'll add comments whenever I post a source code on my forum, but for now, I'll just, wow, do not want to do that. My voice can be the comments. So for I equals 0, and then we'll put I is less than how many? And of course, I plus plus. So this array is going to loop 10 times, and for each loop, all we're going to do is take that element and fill it with a random number. And we already learned how to generate a random number. So put rand modulus. Oh, we'll say that this is going to be from like 0 to 25. No one's going to score more than 25 goals, so do that plus 1. And of course, whenever you do this in real life, you're going to have like the data from a database or a separate file, or you can even enter it manually. But right now, what I have is just an array of 10 different numbers, 0 to 25. So next thing I want to do is just make a quick bit of code just to print out the array. So print, I'll just put original list, new line, and we can actually use this loop again. So of course the print something out, printf, %d, which is going to be the element that we're on. And I messed up my freaking code again, ticking me off. And goals. So right now all we did is we created a random array right there, and we just printed it out. So in this case, this is our original list. We have 20. Okay, we have some players that weren't too good. This guy scored 5. This guy scored 2. And as you can see, this is kind of hard whenever you're trying to look at your best players and your worst, because you got to find them and pick them all out. So it would be really handy if we had a way to sort this array. That was kind of confusing to say, from the least goals to the most. Alright, so let's learn how to do that right now. So the first new technique I want to talk to you guys about is called an infinite loop. And if you just put while, inside the condition put 1. Now whenever you have 1 right here, 1 is the same thing as true in programming. So this loop is going to continue forever and ever and ever until you tell it to stop. And the only way that we can tell a loop to stop is to add a break statement. So essentially what we're going to do is we're going to say keep sorting this list and sorting it and sorting it, and when it's finally sorted, we're going to add that break statement, and it's going to say, okay, now it's time to quit, and I'll show you guys how to add that, or where to add that break statement later on. So the first thing we need to do is add this swapped variable and set it equal to 0. So eventually what you're going to see is whenever this swapped variable equals 0 at the end, it pretty much means that this list is sorted. Now when it's not sorted, we're going to set it equal to 1, and it pretty much means do the loop again. Kind of confusing now, but once I write a little bit of code, you guys are going to understand what I mean. So the first thing that I need to do is actually copy this for loop, and this is going to be the main sorting algorithm. So I want to indent this. Alright, so what I'm going to say is for I equals 0, input I is less than how many minus 1, I plus plus. Now the reason that we have this for loop inside this main while loop is this. What we're going to do in order to sort this loop is we're going to take every number, and actually I'll run this right now, is we're going to take every number and compare it to the number after it. So we're basically going to say compare 25 to 2. Well, this isn't in the right order because we want the smaller numbers at the top, so switch them. So that's what this does. It compares every number to the number after it. So that's why I added this -1, because the last number, this 10 right here, it doesn't have anything after to compare it to, so we can't just go I is less than how many. So what this -1 does is it stops at the second to last number, so every number is going to have something after it. So the next thing that we need to do inside this for loop is this. So like I said, the essence of this program is pretty much going to take every number and check the number after it. And if the number is bigger after it, or excuse me, if the first number is bigger, then it's going to swap them. So I'll show you guys how to do that in code. I'm a lot better just writing code than I am talking. But we're going to say if goals I, which is the first number it's looking at, is greater than goals I plus 1, which is the number after it, then we want to switch them. Because if this number, the first number, is bigger, we want to switch them because the bigger numbers should be at bottom. And of course, if you want to sort it from highest to lowest, then just switch this around, it'll work fine. But now we need to switch two numbers, and it's not as easy as it sounds. What we need to do is we need to, well, let me go ahead and type this and then you guys are going to see. Goal I, and what was that, goals or goals? Alright, now set this equal to, and those should be square. Don't know why I put I plus 1. And just a second, I'll explain everything that's going on. And I plus 1 is equal to temp, and set swapped equal to 1. Alright, so apologize for keeping you guys in anticipation, but this bit right here, all of this code is responsible for swapping one number with another number. Now, the reason that we just can't go ahead and set the second number equal to the position of the first one is because whenever we do that, the first number is lost. It gets overridden. So what we need to do is we need to take that first number and store it in some temporary variable, temporary in, cyberspace. So then we can take that second number in the list and replace it with the first one, and then this original one, which was the first one, put it in the second spot. And whenever we do that, we say, okay, we swapped a number right here, swapped is equal to 1. Now, the reason that we have this line of code is whenever we say we did swap a number, it must mean that the list is not in order yet, so it needs to do it again. So, you see how your for loop is right here? Right outside this for loop, we need to add one more condition, and that's if swapped is equal to 0, then that's when we need to add that break statement. So this is pretty much complete. The only other thing that we need to do, or we don't even need to do this, but we probably should, is look at the sorted list. And do we need to add any more? Yeah, let's go ahead and just add this. A new line, clean things up, and check it out. So this was the original list, 24, 10, 12, 8, obviously not in order, and at the end we get a nice sorted list, small numbers at the top, big numbers at the bottom. Boom, check it out. And let me guys talk you through this code one last time. So up here, you know what's going on. We just created a random array of 10 elements, numbers 0 to 25. We printed it out right here, so this was the original list. Now, what this hunk of code does right here is the main meat of this tutorial. This variable just checks, is the list sorted or not? So I probably should have called this sorted, but swapped works just as well. Now, the only time that it's going to be equal to 0 is if it is in order already. If it's not and you swapped elements, then it's going to set it equal to 1. Of course, do the loop again. Now, of course, we had a for loop in here, which was pretty much the brains behind everything, that took every single number and compared it to the number after it. And it did that using this if statement right here. And said, okay, if the first number is bigger, change them around. If not, leave it be. And if it got to the end of the entire list and it didn't swap any numbers, well then that means that your list is in order and you're good to go. So once that happens, we just printed out the sorted list and boom. So I know that bubble sorts are kind of confusing at first, and like I said, there are a million different sorting techniques. Not like there isn't one that's the best, but this is probably the easiest one to understand, even though it seems kind of confusing at first. But if you don't quite get it, then just look at the code, break it down piece by piece, and after a couple minutes, you guys are going to understand exactly what's going on. But for now, thank you guys for watching. Don't forget to got a freaking whooping cough. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, welcome back to another video, and in this tutorial, what I want to do is I want to start talking to you guys about something called pointers. Now, a pointer is a kind of confusing concept whenever you start to learn it, but it's something in C that you need to learn if you want to learn how to build really powerful and really awesome applications. So again, a lot of people get confused at first, so what I'm going to do is I'm going to teach you guys the core basics of it, and then I'm going to be showing you guys why it's useful, and eventually showing you guys how to build awesome pieces of software with it. But for now, let's just go ahead and stick with the basics. So the first thing that we need to do is go ahead and create any old variable, make it an int variable, and set it equal to anything you want. I'm going to call my tuna, going to set it equal to 19. So the first thing I'm going to display is I want to show you guys how and where your computer actually stores this variable in its memory. So use printf, and in order to print out a memory address on your computer, it's not exactly a number, so we can't use %d. It's not exactly a string, so we can't use %s. It actually needs a special symbol to let it know, okay, I'm going to be printing out a memory address, and that is %p. And as you guys are going to see later on, that stands for pointer. Now, of course, if we just try to print out tuna, it's going to try to print 19, which isn't the case. We want to see where in our computer's memory this is printed out. So in order to do that, we need to use a special symbol called an ampersand right there. You guys know what it's called. I don't know why I said that. But basically, ampersand and then the name of the variable says print out the memory address of where this tuna variable is on your computer. So let's do that right now. So this tuna variable is stored somewhere in our computer in memory 0028FF1C. Okay, that's I don't know, kind of interesting, Bucky. I mean, computers obviously store variables a little bit different than we think they do, and the reason for this is because if we just try to use that memory address instead of this variable name, I mean, it's kind of hard to work with, it's kind of hard to remember and understand. So what C allows us to do is use this name instead. Okay, cool, but who cares? You know, who cares what happens behind the scenes in our memory? Not important, kind of interesting, but who cares? Let's skip pointers for now. Well, just a second. There are some instances where you need to actually work with the memory address of your computer, and in about 3 tutorials you guys are going to see exactly why, but for now let me display a couple things to you. So what we can do is I'm going to be building a little program in this tutorial that basically shows you guys the address, the name, and the value of a few variables including pointers. So the first thing is we're going to be printing out the memory address, just like we saw, and then the name of the variable, which in this case would be tuna, and then the value of it, which would be 19, but it's going to be a little cooler than that. So of course, well, I guess we can, let's just keep that line simple. We'll keep this program really easy to understand. So in this print statement down here, we'll do it first for this tuna variable. So of course the first thing we want to print out is %p, and then tab that, and then the name of course is just going to be a string. This is just going to say tuna, so %s, tab, and lastly the value, which is %d, and kick it to a new line. So we'll print out tuna, the address of tuna, which is going to be 00 whatever, tomato tomato, then the name, which is tuna, and then the value. And of course, just like before, whenever we want to print out the value of a variable, just use this name on %d, run it, and check it out. So now we can visualize this a little bit better. So this tuna variable has a value of 19, and to us, we can just use the word tuna because C is pretty cool and it allows us programmers, us stupid human beings, to use simple names for stuff. But of course, there's not just a random spot in your computer's memory named tuna waiting to be filled with some number. So we made this, but what your computer actually sees is this space right here. That's a space that was waiting, and whenever it actually uses this variable, that is the address that it has to go to. Alright, so that was pretty interesting. So what the heck's a pointer? Well, we know that this right here is a memory address, and what a pointer is a special type of variable that can hold this address. Because look at it, 0028FF1C. Well, we can't just store it in like an int because it has characters in it. We don't really want to store it in a string because it's kind of like a mixed up, has numbers. So we need to make a special type of variable whenever we want to store these addresses, and those variables are called pointers. I'll show you guys how to do that right now. So in order to make a pointer variable, you type what data you're going to be storing, or we'll store a pointer to this one, which was an int. So put int. And if we just type the name after it, it's going to be a regular integer variable. But we say we want to store the memory address of an integer variable. So if you type the asterisk, it's above the 8 on your keyboard. What this is basically telling C is we're going to be making a special type of variable to hold a memory address called a pointer. Now, the truth is you can name your pointers anything you want. You can even name it tuna2. But it's common practice among programmers to begin all pointer names with a lowercase p and then type the variable name that it's pointing to. And that's just so later on you can see, okay, this p tuna is a pointer to tuna, you know, just common sense stuff. So of course, this isn't going to be holding the actual integer, it's going to be holding the memory address. Now we already know how to access the memory address with an ampersand and then the name of the variable. So now what we can do is we can use this p tuna interchangeably whenever we would have used this, and I'll show you guys that right now. So let's print something else out right now, and we'll just change this one right here. I guess I'll type it out. P tuna. So what this line prints out and what this line prints out is essentially the same exact thing. So we can now use this variable p tuna instead of accessing the memory of this directly. And I know you guys are saying, okay, that still doesn't explain why I would ever need a pointer, and for right now we kind of just need to understand the basics before we learn about things like how arrays are kind of pointers and the heap and all that crap and how to make cool expandable applications. But for right now, as long as you understand this, you'll be good to go. So the one other thing that I want to do, just so this sticks in your brain, is this. So let me actually print out the memory address of this pointer variable, and then I'll put ptuna and ptuna, and change this to a p right there. Now if you run this, check it out. So of course, this is the information for tuna. These top two lines, they're redundant. This is where tuna is stored on your computer. So is this, and the value of tuna is 19. But this last line right down here, this third one, it prints out the information for the pointer of tuna. Now, as you can see, the value isn't 19. The value of p tuna is the memory address of tuna. The 0028FF1C is equal to the memory address of tuna. So that's what we said in this line right here. We're going to be making a special type of variable called a pointer, and its value is equal to the memory address of another variable. So actually, let me go ahead and delete this line because it's probably confusing you guys a little bit. So again, if you take one thing away from this tutorial, it's this. You can make a special type of variable called a pointer, and its value is something weird. It's not a number, it's not a character, it's the memory address of another variable, in this case tuna. So in order to get the value of it, it says, okay, go to tuna, find out what its memory address is, and store it in this new pointer variable. And of course, since this is a new variable, it has its own memory address somewhere on your computer. So the last thing I want to point out is that I know you guys don't understand why the heck we would even need these pointers yet, because right now we're just learning what they are. But in the next tutorial, I want to teach you one more concept, and then after that we're actually going to be using them in an application, and you guys are going to see why they are incredibly cool. But for now, thank you guys for watching. Don't forget to subscribe, and I'll see you next time. Alright guys, now that we understand exactly what a pointer is, I'm going to go ahead and show you a cool trick that you can do with pointers. And this program right here is the same exact thing. I just deleted some extra lines and moved some things around, but it's the same thing I taught you guys in the last tutorial. What I did in this line is make a variable, then I made a pointer, and then I printed out the variables information and then the pointers information. So again, like I said, I just cleaned it up a little bit because the last program was kind of messy. But all that stuff right there. So what I wanted to teach you in this tutorial is how to dereference a pointer. Essentially, it's actually probably easier if I just print it out and show you guys, because just me trying to talk to you about memory addresses, you're gonna be like, what? So make a print statement and then type this code. So actually, let me stick this in between two new lines. So right here, what I want to do is press ampersand P tuna, and that's just literally going to print out this right here. And after this, put a colon and press %D. Now that %D value is what I'm trying to display in this tutorial. So again, the new thing that I'm going to be printing out is this right here, ampersand P tuna. And as you can see, whenever I print this out, it prints out the value of 19. Pretty weird. So what ampersand does whenever you add this special symbol before the pointer variable's name is it's called dereferencing a pointer. Now what it does is it essentially says, okay, you want me to dereference P tuna, so I'm gonna go to the variable that I'm pointing to, which is this right here, tuna, or this is the address, and get the value of it. So again, whenever you dereference a variable, it goes to the variable that it points to and it gets the value of it. So if this ampersand P tuna is equal to 19, does that mean this? That ampersand P tuna that equals 19, and also the regular tuna variable up here, we also saw that that equals 19. Does that mean that this is essentially the same thing as this? Well, indeed, yes it does. So these are pretty much two different ways that we can access the value of the variable. We can dereference its pointer and access it, and we can also just use the regular variable name and access it. So with this new information that we learned, let's set this equal to a new value, 71, and print it out again. So copy, print this out, and we can actually just print out tuna, doesn't even matter. So tuna, let me run this and check it out. So this was all the old stuff, and this is when we just printed it out the first time, which I showed you guys in the last time we ran this. And then after this, we took ampersand, oops, I forgot to get rid of this. We took ampersand P tuna, which essentially dereferenced it and set it equal to 71. So that's why this ampersand P tuna, which is dereferencing the variable, and tuna are both now equal to 71. So again, probably I'm going to delete this line before I post the source code on my forum. But again, the one last thing you have to take away from this tutorial is you can use this special ampersand sign to dereference a pointer. Why they named it dereference, I don't know. They just wanted to be confusing. But what dereferences a pointer means is basically go to that variable and get the value of it. So you can either get the value of a variable this way, be it by dereferencing a pointer, or just using the old-fashioned way, which is using the variable's name. So if we can just use the variable's name like before, why wouldn't we just always do that? Why would we need to do this new special dumb symbol? Well, in the next tutorial, I'm going to be showing you guys something cool about arrays, and after that, I'm going to be showing you guys how you can actually dereference pointers and do something useful with them other than just putting random knowledge in your brain. So for now, thank you guys for watching. If you have any questions, ask me on my forum, and well, stick around and you guys are going to see what's up with these cool things. See you later. Alright guys, now that we understand the basics of pointers, and I also taught you guys how to dereference a pointer to pretty much get the value that it's pointing to, I now want to talk to you guys about arrays and pointers in the real relationship between them. And by the real relationship, I mean that there's more to an array that meets the eye. So quote that, write it on your wall, don't forget it. I'm going to show you guys what I'm talking about right now. So what I'm going to be doing is creating a basic array and looping through it and showing you guys the details of each element just like we did in the last tutorial. And then after that, I'm going to be showing you guys a really cool trick, and it's something that is probably going to blow your mind. So of course I'm going to name my array meatballs, and it's going to have 5 elements and set these equal to any number. I'll put mine like 7, 9, 43, 21, 3. The elements actually don't even matter. Just make sure you have 5 integers in there, whatever pops into your head. So now make a basic loop, and I'll put I equals 0, I is less than 5, and I plus plus. So this is going to loop 5 times, and for each loop or iteration, we're going to print out this. The first thing is basically we're going to put 0 through 4 in here, and this is just a little indicator of what element we're on. So since we pretty much have to throw I in there, I is going to be 0 to 4, so it's a decimal, and then I guess we'll just print each on a new line. So tab. Now for each element, I want to show you guys the memory address of each one. So %p, and that's going to print the memory address, and tab it one more time. And the last thing is, of course, each element's value, which is going to be 7, 9, 43, 21, and 3. So those are integers, so we just use %d. Now for the first one, we can just throw I in there. Now for the memory address of each one, remember, anytime we want to print out a memory address, we use that ampersand sign and meatballs, and that's I right in there. So that's going to print out the memory address of each element, and to print out the value of it, which is right in here, of course we just do that. And I actually want to kick each of these on a new line, and let me bump that to a new line too. Do I want to? Actually, I'll do this. Right now it'll just print out each of these, but I'll give you guys a real quick indicator of which each one is, and this will be good for if you're just copying and pasting the source code on the forum. So the first one is the element, the second one is the memory address, and the third one is the value, and on a new line we'll print everything out. So as you can see, I made a simple program to loop through each element in the array, and it prints out the value of it and also where it's stored, the memory address of it. But if you remember, I already did this in the last couple tutorials. We already saw that variable, memory address, value. This is basic stuff. So why the heck would I waste the whole tutorial showing you guys this for an array? Well, it's because of this line right here. What I want to do is add one more print statement, and inside here, actually want to put this between 2 new lines. What I'm going to do is type meatballs in a tab and %p. And now, of course, actually let me tab that twice since we have 3 columns up here. And now, of course, this is going to say meatballs, and then it's going to give the memory address of meatballs. So I'm going to print this out, and you're like, oh, One second, Bucky, you got a little mistake. You told me that whenever you want to print out the memory address of something, %p, you need to use that ampersand sign right there. If not, then you're going to have a real bad time. But look what happens whenever I run this. It prints out the memory address just fine. So this is the first kind of key concept I want to talk to you guys about. For every array, the basic name of it, without any elements or brackets after it, an array name is just a pointer to the first element in the array. So I don't know if you guys noticed that, but whenever I ran this, meatballs, just the name meatballs and nothing else, is equal to 0028 FEF8. Well, if you look up here, that is also the memory address of the first element in the array. So the word meatballs is a pointer to the first element. It kind of blows your mind, but that is why we don't need the ampersand sign, because this already is a memory address. We don't need to explicitly tell it to get the memory address because that's what it already is. So just so it sticks in your mind, there it is one more time. Now, another thing I want to point out is what we can do is, since this is already a pointer, we can go ahead and dereference it. Now, whenever we dereference this, remember, it basically goes to wherever it's pointing to and it gets the value of it. So if we just dereferenced meatballs and nothing else, it would get 7. Kind of weird, but if you watch this tutorial twice, then you're probably going to understand really easily what's going on. So let me add some comments right here so you guys don't get confused. I'll put array names are just... So array names are just pointers to the first element. Now down here I'll put dereference it. I always have to remember to put the extra E. So I guess I'll just print this out right now. So everything looks good except on this line, what I'm going to print out is asterisk meatballs, which is basically going to dereference meatballs. And check it out. And that is the pointer, and we actually want D because it's getting the value. And check it out. So meatballs, just the name meatballs, is the memory address of the first element, meatball 0. So whenever we dereference meatballs, what it does is it goes to wherever it's pointing to, which is this one, meatball 0, and it gets the value of it. So dereferenced meatballs equals 7. Now the last thing I want to point out is a concept that we're going to be using a lot, and it's also a syntax that you're going to be seeing a lot whenever people dereference arrays specifically. It's this. Whenever we dereference meatballs plus 2, put that code right over here. So let me run this and look at it. Now, what we're going to see, a dereference meatballs plus 2 is 43. And I'll show you guys why this is. What happens whenever we made this an array is we're basically saying fill each block in memory big enough for an int. So what we're saying is we're going to dereference meatballs plus 2. So go to this pointer, which is basically a pointer to meatball 0, add 2 to it, 1, 2, and since it's dereferenced, get the value of that, which is 43. So again, we can do this all the way for meatballs 1, 2, 3, or 4, because we have 5 elements in our array. So I know that this is kind of confusing, but if you either watch this tutorial again, or just, I don't know, just try typing everything out yourself, then you guys are going to see basically what I'm talking about. So just to sum up everything for you guys, the core concept of this tutorial is this. The array name has a special meaning. An array name is just a pointer to the first element in that array. Now, whenever you dereference the array name, what it does is it goes to that element and it gets the value of it. So a dereferenced array name is the first value in your array. And of course, if you want to loop through or get other values in the array, you just type the array name plus however many you want, dereference that, and it gives you the value. So I guess the only thing you guys are wondering about now is, okay, This is interesting. Arrays are pretty much like pointers, but still, what the heck can I do with them? This is just like information that I'm never going to use, so who the heck cares? Well, I know I promised that in this tutorial I'll show you guys something useful, but in the next tutorial, what we're going to be doing is I'm going to be beginning showing you guys why all of this information is actually useful whenever you're making programs. But for now, thank you guys for watching. Don't forget to subscribe and study this. When it's stuck in your brain, you're ready to move on to the next video. So thanks, and I'll see you next time. Alright guys, now that we understand the basics behind pointers and how to dereference a pointer, and we also learned a little bit more about arrays, what I want to do is talk to you guys about some more advanced topics, specifically learning why all of this is useful, or at least one way that it's useful. So the first thing I want to do is make a very basic character array, and I'll actually put examples of two movies. The first one will be movie 1, and just like before, set this equal to like the return of Bucky Man right there. So this is a very basic character array, nothing we haven't seen before. And you know how in the last tutorial I told you guys that the name of the array, in other words movie 1, was essentially a special type of variable. In other words, it acted like a pointer. Well, I explained it in a way that was easy to understand, but now let me talk about it some more. And the truth is, I kind of lied in the last tutorial because I called it a variable, and it's not exactly a variable. It's actually a constant. Now, I remember you guys way back when learning about constants and variables. You're like, yeah, well, they're pretty much the same thing, except with a constant, you can't change it. And that's the same thing for a pointer constant. Whenever you have the name of your array, you can never put it on the left hand side like this because it is a constant, and changing it will mess up the rest of your array. Remember, this pointer, movie 1, is basically going to point to the first element's address. So if you try to change it to anything else, say we want to change the name of this movie to Hey Now, what it's going to do is it's going to, as you see whenever you run this, we're going to get error because it says, okay, if you change this right here, you're going to mess up your entire array because I'm not going to know where any other elements are. You're going to give this array a new address or a new pointer, and then I'm going to be lost. So that's why you can never have the name of the array on the left hand side, because it says you're trying to change a pointer. The pointer is actually a constant, and dude, you can't change those. So even if you added those brackets afterward and try to change the name, run this again, not happening. Now, of course, we learned what happens when we actually want to change the name of that movie. Well, we need to use a special function called string copy, or what we can do is access each element individually, 1, 2, 3, 4. However, it's kind of a tedious way to work with strings because, I mean, it would be awesome if we could just work with these strings like a normal variable. Well, let me show you guys something right now. Say we have a pointer variable right now, and it's called movie 2. Well, let's go ahead and set this equal to something like I don't know, like Bucky is awesome, I love ham. Like I don't know, like that's the name of a freaking movie. Who freaking cares? Well, check this out. We already know that movie 1 is a pointer constant. We can't have it on the left hand side of an equal sign. We can't change it. We pretty much can't do anything cool to it. We have to treat it as a constant because that's what we told C it was. However, movie 2 is not a constant. What we did is we made this a pointer variable. So whenever something is a variable, we can indeed change it. In other words, we can print this out or put it on the left hand side of the equal sign. So now let me do something like this. Puts movie 2, and what puts does is basically takes this movie and prints it out on the screen just like a regular string. So it says Bucky is awesome, I love ham. Now the reason that it is able to print this out on the screen even though that this is technically a pointer is because, remember, what puts does is essentially takes a string and starts printing it out on the screen until it gets to that null zero, that zero terminator at the end. So what's going to happen is this movie 2, it's actually not even storing any characters or storing strings. It's storing the address of where this string begins. So whenever we print it out on the screen, it says start here and print letters out until you get to that null zero. So since this is indeed a variable as well, what we can do is this. We can put movie 2 and set it equal to new movie title. And now we can print it out again and check it out. So this was the original one, Bucky is awesome, I love ham, and then we changed it just like we did every other variable, such as floats, ints, characters. We didn't need to use string copy, we didn't need to access every individual character, we just treated it like pretty much how we want to treat it, and we printed it out perfectly. So I know that that's kind of a hard concept to understand, but now we have the knowledge and pretty much ability to treat these variables like we always dreamed of. At least I always dreamed of. This is the stuff that's in my dreams. So the key concept to take away from this tutorial is whenever you just make a very simple array of characters, it's hard to change because that name of the array is a constant and you can't easily change constants. However, whenever you make a pointer to a string, this pointer right here is a variable, so you can easily put it on the left hand side, since all this is doing is it's storing the address of something. So then we can treat it like a string saying start at this address, movie 2, and start printing crap out on the screen until you get to null 0. So again, I know that this is kind of confusing and kind of a hard concept to understand, but I mean, don't blame me because hey, whoever made C, go ahead and yell at them because they made it kind of a pain in the butt, but this is what it takes to become an awesome programmer. Alright guys, in this video what I want to do is I want to talk to you about some problems that we have with string lengths and some things that you definitely want to look out for if you don't want your program to crash. So let's go ahead and create a simple array, and we'll say that we're going to store the name of a movie. Doesn't really matter what. And so we have that, and then we'll put char, we'll make a pointer to it, all the stuff we learned in the last couple videos. And remember, whenever you set a pointer equal to an array, do not use that ampersand because the name of your array is already a memory address, so don't do it twice or you're going to mess some crap up. But anyways, we already know what those lines do, no need for explanation. The point of this tutorial is this. Right now we have an array that holds 20 characters, 20 items. But what if we're making a program where we let the user enter the name of a movie and their title has more than 20 characters? Well, then you're going to have a really bad time because some really messed up stuff is going to happen. What's going to happen is it's going to try to store that title, that long title, and in the process it can overwrite some of your data that's already in your memory because it's storing stuff that you didn't reserve space for in your memory. So what we need to do is we need to allow kind of check and balance just in case the user doesn't follow directions or accidentally enter something longer than 20 characters, and that is this little function right here. It's fgets. Now I'll explain exactly what this does, but basically the job of the function is to take input from the user, from the keyboard, and if they enter more than a certain amount, it just cuts it off. For example, put pmovie 20 and put std in, and I'll explain to you guys what this means right now. So just like gets, it pretty much gets input from the keyboard, and this standard in right here, that just means standard input. In other words, the standard input from your computer is your keyboard. Other types of input could be like from a file or I don't know, from the internet if you're using like another program language. But anyways, that's what that means right here. Now, what these parameters mean is pretty much store it in right here. So store the data in pmovie, and also this 20 means This is the maximum amount of characters that we're going to store in pmovie. If they enter a really long title, then take whatever at the end and just cut it off. So you only get the first 20 characters no matter what. So now we can just do something to display that, like puts pmovie, and whenever I do, check this out. I'm going to run this, and we don't have any prompts, but pretty much it's saying, okay, give me the title of a movie. I'll put something real long, like Bucky is awesome at programming and he likes dumplings. You know, probably a movie that I would definitely see in theaters, but hit enter and it's going to print it out and it's going to say Bucky is awesome at, and that's it. I told you had 20 characters, so dude, you can't store any more than that or you're going to mess up the program. So again, whenever you're allowing the user to enter titles and stuff like that, make sure that you use this fgets function. If you don't, your program's going to crash, your computer's going to be ruined, and you're going to go to jail for the rest of your life. But anyways, thank you guys for watching. Don't forget to subscribe, and in the next video, we're going to be talking about the heap. I'll see you then. Alright guys, so up to this point, the memory that our program was allowed to use was pretty much limited by whatever variables we declared. And what do I mean by that? That was kind of a weird sentence. So in the last tutorial, we made a simple array called movie, and we put 20. And what this means is that whoever runs this program, they can type in the name or the title of a movie, and it can have up to 20 characters. So pretty much whatever variables we make reserves memory on our computer, and that is what our computer program has access to. However, this creates a huge problem whenever you're talking about computer programs, and that's this. What if you're running a program and you need more memory than your variables reserve? Well, this occurs because say you made a program, I don't know, let me think of something, like for business owners to keep track of their employees. Well, you don't know how many employees that owner is going to have. Is he going to have 5? Is he going to have 8,000? Well, we actually need to know this before we start making these variables because it would be really handy. So that is why I need to teach you guys about something called the heap. Now, I want to explain one more concept and exactly what the heap is. So all of the programs that are running on your computer right now, actually if I do Control-Alt-Delete then and show you guys the programs, it's probably going to mess with my screen recorder, but basically all of the programs that are running and all of the memory that is being used up right now only accounts for a certain percentage of my computer's memory, and you can actually see it right here. See, I'm only using 22% of my computer's memory right now. Everything else is leftover memory that my computer is not using. This is called the heap, and with this extra memory, what you can do is you can access it with your program, do whatever you want to do with it, and then give it back to your computer when you're done with it. Pretty freaking cool. So it's pretty much like extra memory that you can borrow. I probably should have just said that. Would have saved me like a minute of talking, but now you guys really know what it is. So in order to use this extra memory, let me go ahead and I'll show you guys the 2 simple functions that you need to use, and in the next tutorial I'm going to be showing you guys an actual useful program. But for now, let's understand the concepts. So we'll say we'll make actually I probably should just code all of this real quick, but pretty much right here it creates an integer pointer and it's going to point to the first item in the heap. So after this, what you can do is something like this. So this points, and we'll say that this is just to store, like, I don't know, like the points of players on my team or something. That's what was going through my head. And let me type the syntax out first, because if I try to explain it, it's not going to make any sense. So int, you guys probably already know what that means. In this new one, malloc, what the heck is that? 5 times size of int. And I might as well type the rest of this. Alright, so what I just said, let me give myself some space to work with. So what I just said a few minutes ago is that the heap is a leftover memory that we can borrow whenever we need it and give it back whenever our program ends. So first, how do we borrow the memory from the heap? Well, what we need to use is this function called malloc. It pretty much means allocate memory or get memory from the heap. So the only parameter this function takes is how much memory do you need? Well, what we are doing, first of all, is we're going to store a bunch of integers in this memory. So that's why, of course, I use the int pointer. Makes sense. Now, I don't know how many bytes an integer is. And I don't know if it's stored differently on different computers. Maybe an integer is 4 bytes on this computer. Maybe it's 8 bytes on a Mac. Maybe an integer is 8,000 bytes. I don't freaking know. I don't freaking care. And it's not important. Because we don't need to type explicitly how many bytes an integer is. We just say the size of integer, and if an integer is 4 bytes, it's going to return 4. If a float is 8 bytes, it's going to return 8. So this little bit of code right here saves you from finding out how many bytes each system stores in its variables, or each type of variable. Now this right here just says, okay, multiply however many bytes an integer is by a certain number, in this case 5. So pretty much this allows us to store enough memory or allocate enough memory for 5 integers. So it looks really confusing, but this entire line, now that we broke it down, it says, okay, go in the extra memory and reserve space for 5 integers. Simple enough. Now the only other piece to this little thing right here is this int star. So what this is basically, as we know before, is it's an int typecast pointer. So a typecast pretty much means treat this as an int pointer, and this pretty much means that you need to use it whenever you're storing ints from the heap. So again, you know what typecast does, you know what a pointer is, and should be pretty easy to figure out. Pretty much this is an int typecast pointer. Whenever we're storing ints, use an int typecast pointer. Whenever you're storing floats, use a float typecast pointer. Tomato, tomato. So the first thing to save memory is malloc. The only other function that is new to us is this free. So remember I said, all of this leftover memory in your computer, we pretty much only need to borrow it for the duration of our program. Once we're done with our program and we close out of it, oops, wrong program there. Once we're done with our program, we can give it back to the computer. So whenever we want to give it back, you just use free and then type, of course you see right here, the name of whatever you're allocating, in this instance, points. So sometimes we're going to run programs and we're going to need extra memory. This is how you get that extra memory, and this is how you give it back. So now that we understand the very basic, and guys, there's a lot of crap to talk about concerning the heap, and this is actually the very, very basics of the heap. But now that we understand that, I'm going to show you guys in the next tutorial how to actually build a useful program instead of just, talking about the boring concepts. But for now, thank you guys for watching. Don't forget to subscribe, and I'll see you later. Alright guys, so now that your brain is bursting with knowledge about the heap, let's go ahead and actually make an expandable application utilizing the heap, because, I mean, that was the goal of all of this crap, wasn't it? So what I'm going to be doing is I'm going to be making a program where, I don't know, we'll say that the user can enter a bunch of numbers and average them together. However, we're going to be doing it a little bit differently than we have before, because before we can just be like, I don't know, create an array with like 10 numbers. Well, in this program, we're going to allow the user to enter exactly how many numbers they want to average together, and this would be awesome. Again, this is just going to be a really simple concept, but this is good for if you have a bunch of students in a college or employees for a company. You can use this and expand it to pretty much make any program you want. So we need a couple counters, int I and how many. This is just going to be the counter variable, and this how many is how many items you want to store, like students, employees, tomato, tomato. And now we just need some stuff to calculate the average. So total float average, and just set this to 0.0 for right now. We're going to be changing that. And from the last tutorial, actually tutorials, I guess I should say, int points array. Now the first thing we can do is pretty much give them a prompt. Be like, alright, I guess we'll just like average, I don't know, whatever number. So how many numbers do you want to average? And I guess we don't need anything else. So kick that to a new line, and now we need a way to scan it in. So scan F. Why do I keep hitting D? What the heck? %D, and of course, whatever they enter, we're going to store in this variable how many. So this is just a regular integer, so we need that ampersand, how many. So now we got how many numbers they wanted to average stored in that variable. We can move on. So what we need to do now is say, okay, go to the heap and create an array that's this big. So if they entered 5, create an array that's 5 elements long. That can store 5 integers in this case. So we'll put points array. Oh, it already did it for us. Sweet. Equals, what are we storing? Well, we are storing ints. So typecast this to ints because we need to do that whenever we allocate memory. And then malloc. And the first thing, remember, is how many of these items do you want to store? In the last tutorial, we just wrote 5, but now the user actually entered that value manually, and then multiply this by the size of however big an integer is on your computer. So again, if the user enters 5 and an int is 4 bytes long, it's going to say, okay, this is 4 bytes, multiply it by 5, so we have 20 bytes, then go ahead and reserve 20 bytes of memory so we can store a bunch of stuff in this points array. So now this points array is just like a normal array. We can use point 0. I might as well type that out instead. What the? That's not what I'm trying to use. There we go. So now we can use stuff like point 0, points 1, points 2. We can just treat this as a normal array. However, it's a lot cooler because the user kind of helped in creating it, and it's expandable. So pretty sweet. Let's go ahead and do something else now. So printf. So now that we have space to store a bunch of numbers, we can just give them a little prompt and be like, well, enter them, Haas. Give them an explanation. Let them really know that we really want them to enter them. So the next thing I want to do is this. Now that they pretty much have that little prompt, we're just going to loop through and allow them to enter 5 different numbers. So 4, and this is where that counter variable comes in. So I is actually, what the heck am I doing? I'm just thinking about Star Crunches, to be honest, because they are delicious and I have them stuck in my teeth because I just ate about 40 of them. So I is less than how many, and I plus plus. You know what? Actually been programming Python for the last couple, I don't know, the last couple days, and in Python you don't use any semicolons, and you don't even use these little curly brackets. It's really weird. So that's why I'm like, okay, how do you program C again? I don't know. I forgot. So, alright. So anyways, we need a way for these users to scan in a bunch of different numbers. So %D. And again, this is going to run 5 different times and store it in points array I. Alright, so after this, what they're going to do is they're pretty much going to enter a number, and you're going to store it in points array 0, 1, 2, 3, 4 until our array is completely populated with however many numbers they chose to enter. So of course, just calculate the average, we need the total or sum of those numbers. So points array I, pretty much for each loop, whatever number they enter, add it to a total, and this is just so we can figure out the average later on, which we will do right now. So now that we have an array, this is the easy stuff. First of all, set this equal to typecast the float total, and put this, I guess what, might as well add some space. Actually, I'm just gonna copy this because I'm too lazy to type 2 freaking characters. And how many. Now remember, both of these variables, total and how many, were integers, so the average is a float, so we need to typecast those to floats, and of course, in order to figure out the average of something, you take the total amount by however many items, and boom, there you have it. So printf, we'll just put something like average is %f, and average. So wow, I almost cursed there and probably shouldn't do that for YouTube. So pretty freaking sweet. And hopefully I don't have any bugs here. Alright, dude, how many numbers do you want to average? Let's just enter 5 numbers. It says, well, enter them, Haas. Oh, okay, take it easy there. Alright, so what are these? Like points? I'll put like 21, 28, 62, 87, and 4. This guy sucks. So hit enter. It says the average is 56.000. So if you ever want to know what the average of all these numbers were, there you go. And if you want to learn how to make an expandable program using the heap with all of the knowledge that we ever learned, then you also got that out of this tutorial as well. And by the way, in order to get a job programming C, the heap is one of the things that you definitely need to know like the back of your hand. So watch these last couple tutorials, learn it. If you have any questions, ask me on my forum. And in the next tutorial, I'm going to be talking to you guys about structures. So there's a lot more to the heap, but I just wanted to show you guys the basics, and now we can move on to something, and to tell you the truth, it's a lot easier than all this crap. So next tutorial is structures. See you there. Alright guys, so my boss just came to me and he asked me for a way to print out all the information about every employee in our company. So we have 500 employees and they each have a user ID, a first name, a last name, and we also store their age and their weight because, well, my boss is weird and he wants to make sure no one's eating too many cheeseburgers, so we also keep track of their weight. So this is what I did. I put int user ID, and then I put char to make a character array, first name, and no one has a first name longer than 25. I also did this for their last name, and I also needed to store and print out their age, so that's an integer, and their weight, which is a float. Alright, so this can store all of the information for user 1. And now let me just do this for user 2. Okay. Oops, messing up there. User 2. You know what? If I do this for 500 freaking people, it's going to be a pain in the butt. So I'm scratching my head and I'm thinking, wouldn't it be cool if we could just make this template one time, a template that could store the user ID, first name, last name, age, and weight, and we can use it over and over and over again. I know what I can do. I can use an array. You can store a bunch of crap in there. Okay, well, wait a minute. An array can only store a single type of variable. For example, it can only store ints or floats. You can't store an int and a char and a float in the same array. Oh, crap. So we can't use that. Well, ladies and gentlemen, welcome to the wonderful world, kind of a tongue twister, of structures. A structure is a way that you can group a bunch of variable types together and they don't need to be the same type. For example, you can pretty much create a blueprint for a person and store an int, a char, and a float all together. Pretty freaking sweet. So let me show you guys how to do that, and you guys are going to love me after this. Now I want to mention one thing. Whenever you make a structure, you can just go ahead and make it up here or wherever you want, but 99% of the time programmers like to make their structures in a different file. It just helps organize everything, and it's just, I don't know, common amongst programmers. So they put them in a separate header file, and maybe remember that we made this header file like, I don't know, 20 tutorials ago or something. So open that back up. First of all, cut this because we don't add any of our structure definition in the main file. So now let me show you guys the basic syntax of how to create a structure. Whenever you create a structure, the first thing you write is struct, pretty much tell C, hey, I'm going to be making a structure. The next thing you do is you need to name your structure. And this is just so if you have like a structure to store employee information, and if you have another structure to store, I don't know, student information, maybe teacher information, well, if you have multiple structures, you're going to need to be able to identify them. So we need to name it. So after this, what you do is add 2 little curly braces and a semicolon. The semicolon just says we're done with the structure. Now in between those curly braces is where we write all of those individual variables. These are called members of the structure. So a structure is pretty much just a group of variables, and those individual variables are called members. Simple enough. So now, basically, as I'm going to be showing you guys later on, what we can do is we can create a bunch of users, and they can each have an integer, a character for their name, all of this crap, and we just group together a bunch of variables of different types. Pretty freaking sweet. And if you're ever wondering, well, what's this useful for? It's really useful whenever you're working with, like users or employees, and you want to like display all of their information at once as a table or anything like that. So I'll show you guys how to actually use this structure right now. Now that we made it, might as well use it, right? So of course, since this is in a header file, the first thing we need to do is import this. So, or include it, I should rather say. I'm used to program Python. But anyways, include, and remember, we can just use those double quotes, Bucky's info.h, and what this does is essentially copy this and paste it right in here. It does the same thing, even though it's going on behind the scenes. So now we have that structure included, so let's use it right now. So whenever we use a structure, the first thing we need to do is, remember, we can store as many people as we want using the same template. So how do we store each individual person? Well, just say that we're going to be using a structure. What one are you going to be using? Well, you're going to be using the user structure that we just created, and after this you write like the name of the person. So we'll say for this one, for this template, we're going to do it for Bucky, and you can do this for as many people as you want. Now we're going to say, okay, let's do it again, and let's use another one for Emily. Okay, simple enough. So if you're saying, okay, so Bucky now has a user ID, first name, last name, age, and weight. Emily now has a user ID, first name, last name, age, and weight a lot faster than typing out, user ID 1, 2, 3, 4. Saved us a whole bunch of freaking code. But how do we actually set Bucky's weight to something or set Bucky's user ID to something? Well, in order to do that, you do this. Type the name of whatever you named it up here. So Bucky, and then after it, hit the dot, and this is a new operator that I want to tell you guys about. This is called the dot operator, and it's used for accessing individual elements or items inside your structure. And again, they're called items, or that's what I call them, but technically they're called members. So user ID is a member, first name is a member. So this is how we access each member or variable inside the structure. So we'll say to set Bucky's user ID, just put Bucky's dot operator user ID and just treat it like a normal variable. So what's my user ID? I don't know. We'll set this equal to 1. So whenever we're setting the user ID of Emily, user ID, of course she doesn't want 1, she wants 2, so on and so forth. Now after this, again, we don't just need to set it explicitly using the equal signs. We can do cool stuff like puts. We'll just give them a little prompt. We'll allow the user to run this program and like enter their first name or something. I don't know. So enter the first name of user 1. And I want to keep this. Okay, actually that's good. We'll keep this program simple. And of course, whenever we do gets, just like before, we put Bucky, first name, and typically this would just be like user 1 and user 2, but just so I can like really easily display what's going on, we just put Bucky, first name, a little bit easier. Now of course we can do this for enter the first name of user 2. Of course that would be Emily's first name, so whatever name they enter right here gets stored in the first name of Emily and Bucky, tomato tomato, simple stuff. So I guess now that we know how to access the members of a structure, how to make a structure, might as well just go ahead and print it out, get this tutorial over so we can move on to something a little cooler actually. So we'll put like okay, User 1, can't type. I'll print out Bucky's ID. User 1 ID is %D, and I don't know, kick that to a new line. Who freaking cares? So ID is Bucky's user ID, and copy this. Alright, so users 2, let's see. First name is, that would be a %S because it's a string, and that would be Emily's first name, which is hopefully Emily. Alright, and that's pretty much it. So now when I run this bad boy, come on, there we go. Alright, so enter the first name of user 1, well that is Bucky. Enter the first name of user 2, that's Emily. Check it out. User 1, which is me, my ID is 1. User 2, Emily, her first name is Emily. Simple stuff. So again, this isn't really useful in this sample because right now our program is really small. It only has 2 users. However, when you have bigger programs and when you're actually working for a company, what's going to happen is instead of having to type these variables 500 times for each user, you can just make one single structure and it can be a blueprint for every single user. So then you can do just cool things and loop through and like print out all of their items in a database or in a CSV file or whatever you want to do. But now you know how to use structures, and since we know how to use structures, we learn about memory. In the next tutorial, I want to start talking to you guys about files, how to create a text file programmatically, and some really cool things that you can do with them. So thank you guys for watching. Don't forget to subscribe, and I will see you later. Alright guys, it's time to start learning about files, and of course we already know why files are useful, because right now with the knowledge that we have in our brains, what we can do is we can create a cool program to, I don't know, like convert like dollars to euros or something, and we can run it and output it to the user. However, whenever the user closes their programs, that data is deleted forever. So it would be nice if we had a way to store the data that our program created, even not only when they close their program, but even when they shut off their computer, they could come back to it. So that's why files are useful, because we can store data that either our program creates or just needs to access. So the first thing I want to do before I start talking to you guys about how to create files, how to read them, how to add crap to them, is basically this. There are 2 different types of files that we're going to be working with, or working with files in 2 different types of ways, should I say. The first one is called sequential access files, and this is pretty much data that we need to create in order 1, 2, 3, 4, 5, 6, 7. The other type of file, actually I'll write this down. Sequential means in order, and we're also going to be working with random access files, and this pretty much means that we can store data all over the place. It doesn't need to be in any specific order. Doesn't make a lot of sense right now, but it will in like 2 tutorials, exactly what these types of files are. So the first thing I want to do is just show you guys the easy one, a sequential access file. So let's go ahead and create a basic file in C. So the first thing that we always need is a file pointer, and it's pretty much a way to keep track of where we are in our file. Pretty much saying, do you want to start writing text at the beginning, the end, the middle? Well, we need a file pointer to keep track of pretty much where we are, like I said, in our file. So in order to create that, write the name file, all in caps, pointer, because it's file pointer, and just name anything you want, F pointer. So pretty much you always need these 2 parts, and then you can name your file pointer anything you want. A lot of people name them FP, but I'll name it F pointer so you guys can easily see what's going on. So now we need to open a file to point to, or pretty much use a file. Now there are a bunch of different things that we can do with files. We can write text or create a file, and I'll talk to you guys about the different modes real quick. Now whenever creating a file or writing it for the first time, we use the keyword or the letter W. Whenever we have a file that already exists on our computer and we just want to read information from it, we use R, so W for write, R for read. And whenever we have a file that's created and we want to add to the end of the file, so pretty much add more crap to the file, we use A. A means append or add more crap. So obviously we didn't have any files that we created yet. We can just read, I don't know, find a file on my computer, but let's go ahead and create one first. And not you, freaking internet. Have it. So how do we create a file? Well, the first thing we need is our file pointer. Pretty much anything we're going to be doing in files, we're going to use this file pointer and set it equal to this. F open, and this open allows us to open a file and do something with it. So what we need to do is open a file and pretty much write to it. In other words, add text to it, create it. So the first parameter this takes is what is the name of the file that you want to open, aka create. And I'm just going to name mine bacon and make this a basic text file. Now the reason that I had this window open was to show you guys this is where my program is on my computer, and if you just write bacon.txt, we're going to be creating a text file in the same directory. So as you guys can see, there is no bacon text file right now. We're going to create it. So open bacon.txt, and since it doesn't exist yet, we need to write it. In other words, W. So what this basically does is it now opens your file bacon.txt, and if it doesn't exist, it's fine. It's going to create it for you, and it's going to say, okay, I am now ready to write crap in here. In other words, add text to the file. So in order to write stuff in a file, you need a different type of a print statement. It's actually printf, and this is going to look very familiar. Whenever you would just print stuff on your screen with printf, the function fprintf prints it to a file. Probably the easiest thing we ever learned in our life. Now this actually takes a couple parameters, and by couple I mean two. It's really easy. The first one is your file pointer, and right now this is just at the beginning of your file. So let me open up Notepad. So again, what your computer is seeing right now is pretty much this, a blank cursor at the beginning of a file that it's going to be bacon.txt. So the next parameter it takes, just like print, is basically what do you want to print or what do you want to write to your text file. And of course, the only thing we can write, I love cheese. And then we can put it on a new line, just like before, and end that. I'll give you a little space so you can see what's going on. So basically, if we just run both of these lines, then it's going to open a file, and since it isn't created yet, it's going to create it for you. We don't need to do it on two separate lines. Pretty freaking cool. And once it's open, it's just going to write something in it. Now, this is actually going to work perfectly, but the one other thing I want to talk to you guys about is just housekeeping stuff, and that is fclose. Whenever we're done with a file pointer, we're going to close it, and this just frees up any memory. It says we're done with this, give that memory back to the computer, you can have your resources. It's just good programming practice. So let's run this and check it out one more time. We don't have any bacon.txt file right now, so I'm going to run this. Okay, nothing displayed, but check it out. If I reopen this, oh, I now have a bacon text file right there. And it has, let's just say 15 bytes in it. So if I open this with Notepad, it says I love cheese. Boom, check it out. What we just did is we created an entire file with C. How awesome is that? Now, I want to point something else out. First of all, as you can see, whenever that little console opened, we closed it out, our file still exists. So this is a way that we can save data even when we close our program. Another thing is this little bit of information. Say we run this program again and we write bacon is good. Well, with this W mode, this write, what happens is it says, okay, this is pretty much creating a new file. So if you run this program again, since we already have a bacon.txt file, I'm going to say, okay, delete that old one and create a new one with this. So it runs it again, but now check it out. It says, okay, your file has been modified. Do you want to reload it? Yes. And now it says bacon is good. So remember, with W, whenever you run your program more than once, it overwrites the old file since it pretty much is always creating it from new. And if you guys want to know how to add stuff on to the end of your file, like you might have expected, I'm going to be showing you guys that in the next couple of tutorials. But for right now, This is how you open, aka create a file. This is how you add text to it, and this is just programming practice, how to close it, free up some memory, and now we're good to go. So in the next couple tutorials, what I want to do is show you guys, now that we have a file created, how to read from it, how to add on crap to the end of it, and also how to work with those things called random access files. It's going to be freaking sweet. I'll see you then. Like good day, mates. In this video, I'm going to teach you guys how to read from a file. And actually, what I want to do first is, right now, we just have bacon is good. Not very cool. I actually want a couple lines to read to, I don't know, if we just have one line to read, it'll be kind of boring. So go ahead and type, I don't know, 2 or 3 more lines. So bacon is good. I really like to eat, meatballs, and then we'll just say cheese. I don't know, like a freaking haiku or something. Bacon is good, really like to eat meatballs, cheese. So go ahead and save this, and so right now we pretty much created this file right here. We created it with C in the last tutorial, and then we edited it in Notepad or any text editor you have. So now let's go ahead and read it in C. So the first thing, remember, whenever we're working with files, is just that file pointer. I'm going to name it F pointer again. Why not? So what we need to do is read this. First thing, F open. Again, just think of this function is pretty much the equivalent of opening up your Notepad program. So F open pretty much opens up its own version of Notepad, even though that's not what it does. But if you think about it that way, it's going to be really easy to understand this function. And of course, whenever you have Notepad open, you need to select what file you want to work with. And we're just working with this bacon text file. So that's the equivalent of doing file open, that first parameter. And the last one is, what do you want to do with it? Well, in the last tutorial, we wrote that file, and now we just want to read it. So pretty much saying, whatever's in here, get ready to just give me that information. Read it back to me. Now, what I want to do is print it on the screen, and we actually need one other thing to just print it in this little command line thing. Because right now, here, let me close this. F close, F pointer. So right now, this command line, or this, yeah, I guess you could call it this little command line black box, this is a very simple program. It can't just take a file and read it. This actually needs variables in C. That's what it was built for. So in order to display the contents of our file in that little command line window, we actually need to first store the content in something that C can use, such as a character array. So I'm going to store it in this single line array because I'm going to be printing it out line by line. So once we have an array created, what I can do is just make a very basic while loop. And this is how you read a file line by line. Now the first thing is we need to say run this loop pretty much from the beginning of the file to the end. So by default, remember, our file pointer is going to start at the beginning. So we're pretty much going to say loop until the end. How do we do that? Well, we'll say, let me just type it and then talk to you guys about FEOF F pointer and hit enter. So basically, what this means is file end of file. In this explanation mark, you know that it means not. So what this is saying is, as you read the file, this file pointer is going to progress like this. It's going to go to the end and then start on a new line, and it's going to go all the way pretty much left to right, exactly how people read in real life, from left to right, line by line. And what this is going to say is keep looping until you get to the end of the file. In other words, as long as the file pointer did not reach the end of the file yet, continue to run this. Simple enough. So now we can just go ahead and the first thing that we need to do is actually say, okay, F gets one line, just like it does in the command line. So F gets single line 150 F pointer. What this is going to do is it gets a line. Now before we just used gets to get it from the command line, but in this case it's going to get your file line by line. So instead of using standard input such as keyboard, it's going to use that file. So the first time it's going to be equal to this, the second time it's going to be equal to this, and the last time it's going to be equal to this, which is cheese. So that's what fgets does. And now we can just use regular puts because we're not putting it to a file, we're just putting it to the command line for the user to see. And of course, the information was stored in single line. So just print out whatever it is on a single line. And that's it. So let's run this and check it out. So what it's going to do is it's going to go through and get all of that crap line by line and then print it out on the screen. So bacon is good. I really like to eat meatballs and cheese. Now the only other thing I want to point out is this. You see how there is a space between every line? Well, the reason for that is because this. Remember, puts automatically adds content to a new line every time. So we understand why this stuff is on a new line, but why the space in between? Where is that extra new line coming from? Well, it's coming from here. In your text file, even though you can't see it, your computer programs see this at the end of every line, a new line character. And this is how your text editor knows to put each of this crap on a new line. However, let me redo that actually. Redo. However, what's happening in this program right here is it's copying all of this with fgets and then it's putting it to a new line. So whenever it puts that to the new line, it adds the other new line from puts plus the new line that was already in this text file right here. So that's why you have a space between every line even though your text file appears not to. So again, one last time, if you got this down, move on to the next tutorial. Basically, we open a file, we said, okay, we want to read from it using this R character, and then we said, okay, we pretty much need a character array to store all the crap that you're going to read it line by line, print it out on the screen, and then when we're done with everything, close it out. Very simple stuff. Now we know how to write files and read files. The only other thing that I want to talk to you guys about is how to append files, how to add on to the end of this. And once we're done with that, it's actually going to be like 2 seconds. We can learn about random access files and a whole bunch of other cool stuff. But for now, thank you guys for watching. Don't forget to subscribe, and well, see you next time. Alright guys, so we can read files, we can write files, easy stuff. The only other thing I want to talk to you guys about with sequential access files is how to append, aka add crap to the end of them. Now, of course, W is for writing, R is for reading, A is for appending. This is actually going to be really easy, and what I did is I deleted all the crap in my other text file. I want to make something new here, so let me think of something. Cheese, everywhere, even in my underwear, pudding hammock. Alright, so pretty sweet. Let me go ahead and save that, and this is my beautiful poem, a beautiful piece of art. However, I'm looking at it, and right now anyone can just claim this as their own, and I don't get any credit. So obviously, as the author, creator of this, I want to say this is my file, add my name to the end. However, I don't want to do it in this notepad editor because I'm too cool for that, so I'm going to add it with C programming. So, of course, we already are in append mode, and what this basically does is it takes your file pointer and moves it to the end of your file. So basically where my cursor is blinking right now, that's where my file pointer is going to be. Now, I want to add my credits on a new line, so I'm going to have to kick this to a new line whenever I'm adding it in my program. So just take note of that. Now to print stuff out, fprintf, which pretty much means file, print to it, and it takes 2 parameters. The first one is file pointer, and the second one is what text you want to print. Well, remember, my file pointer is on line 3 at the end of it, and I want to kick it on to a new line, and then I'm just going to put this is actually called a haiku, not a haiku. Spell haiku a little bit differently, add an L to the end. It's my own, I don't know, style of poem because I'm awesome, by Bucky Roberts. And of course, we already closed it from the last tutorial, so now make sure that that original one is saved. And now write this, build and run, and check it out. Now when we open this back up, it added that line to the end of this file. So this is what we had before. This is where the pointer was. Kick it to a new line and append. So again, if you're working with something like, when would this be handy? Like stock information, and you downloaded like 3 years worth of information before, and you just want to update it with the information from today. Well, you don't want to have to download it again and write it to a new file. You just want to grab it from today, write one more line, and that's an example, one of the many of when appending would be useful. So let's actually close out of this. And the next thing I want to talk to you guys about is a random access file. Actually, I'm going to be doing that in the next video because, I don't know, I just feel like it. So thank you guys for watching, and well, I'll see you then. Alright guys, welcome to another tutorial, and in this video we're going to be talking about random access files. And let me tell you why we would ever want to use a random access file or access it in that way. Now this isn't like a new type of file, it's pretty much just a different way of working with the same file. So we can use random access tools on this file. You don't have like half of your files on your computer are sequential, half are random. It's just how you work with it and open it. So the reason that you may want to use it in this way is because of this. Say that we have a long poem right here and we only want to change one little word in the middle. Maybe we had a typo. Well, before we only had the tools to read an entire file or write an entire file, but what we want to do is we just want to go in the middle of it, jump around to the middle right there, and just edit a little bit of it. Well, the other tools are kind of powerful, so this is kind of like a surgeon. You go in and just rip out a specific part. Well, a surgeon probably wouldn't rip something out. He'd probably do it delicately. So that's what I'm going to teach you guys how to do. Just my headset. I got like the most comfortable headset. I don't know what it's called. I posted on my forum. I don't know. I'll post it below, but freaking love it. Don't even know why I said that. Don't worry about it. So before, our tools were W for write, R for read, and A for append. And the truth is, those are the only letters you can use, but there are different modes as well, or ways to enhance it, should I say. So what we can use W plus, and what this means is whenever we add a plus to the end of this, it means open the file, open it for writing first, and then after that, this plus means that we can read it afterwards. So this means open a file for writing first, then reading. And also, what I want to do is this. Let's use a new example. So delete everything out of there and save your file. Don't delete the file, just delete all the crap out of it. So now we have the tool to pretty much use this as a sequential access file, or excuse me, a random access file. So now that we just have a blank file, let's go ahead and just print something on the screen. So F puts, and by the screen I mean the file, of course. And what's the dumbest thing I can think of? I ate 3 pumpkins today, and that actually is true, ladies and gentlemen. And F pointer. So again, just like before, this prints something in your file. Don't believe me? Check it out. Our file now says I ate 3 pumpkins today. Okay, well, Bucky, you said that you're going to be teaching me about random access files, and this is pretty much just a freaking sequential file. I'm not learning anything new here. Well, let's go ahead and start learning that sequential crap that I promised you. Now, the first thing I want to do is show you guys about a new function called fseek. What this function does is it takes your file pointer, which resembles the cursor right here, and instead of just starting at the beginning or the end for reading and writing and appending, you can actually hop to a specific part anywhere in your file. So you can hop to like right there if you want to. So say that we wanted to keep this first part of the sentence, I ate 3, but I forgot it wasn't pumpkins that I ate, it was actually 3 munchkins that I ate. So I want to change that. So we'll go 1, 2, 3, 4, 5, 6, 7. So remember that we want to start at the 7th location in our file. So just keep that in mind even though you don't know how to do it yet. So the first parameter it takes is, okay, what file pointer do you want me to move around? Well, we only have one file pointer. The second parameter is what position. Actually, let me type this out and then you guys are going to understand what's going on. Seek underscore set. So again, what this function does is it takes a file pointer and it moves it to somewhere in your file. Now this seek set parameter, seek set means start at the beginning of the file. Why they named it seek set, I don't know. They should be seek to the beginning, would be a lot easier, but now you know what it does. So it says start at the beginning, and the second parameter, 7, is pretty much saying how many characters or how many spaces do you want me to move it. So again, start at the beginning, now hit right on your keyboard 7 times. 1, 2, 3, 4, 5, 6, 7. So now our file pointer is right after that 3, and now whenever we write to it, it doesn't overwrite this beginning stuff, it just overwrites right there. So now if we just do something like f puts, we can fix this, and remember, since we are butted up against the 3, right now we need to add a space in our string first, or else it'll, I don't know, appear bunched together. Munchkins on Friday. So it wasn't pumpkins I ate today, I actually ate munchkins on Friday. My apologies. So f puts, of course we need to do that, and file pointer so it knows to move it, and whenever we run this, check out our file. So it kept the I83, and then what it did is it pretty much took that string, the f puts, and put it in place beginning at wherever we told the file pointer to move. Now, just so I show you guys one other thing, let me change this. Alright, and get rid of the string. So remember, seek set means start from the beginning of your file, but there are some instances where we want to start from the end, and in this case this is a little easier to remember. Seek end. So again, set means beginning, end means end. I don't know, kind of weird, but now another thing is whenever we start from the end, this just puts your file pointer in a starting location. If we put 7 now, then it would start at the end and try to move it 7 forward. However, if you ever want to move backwards, then that middle parameter has to be a negative number. So let's I don't know, do something like this. So right now, 1, 2, 3, 4, 5, 6. Alright, so we'll put I 3 munchkins on seek at the end, move back 6 spaces, and write something else, whatever I think of, whatever pops into my stupid brain. Alright, so seek at the end, and -6, which means move back 6 spaces, and okay, so it says I ate 3 munchkins on, I don't know, on top of a mountain. This story is getting incredibly dumb, but at least we learned how to work with random access files. So run this bad boy and check it out. The first thing it printed was I ate 3 pumpkins today, and then it replaced that I ate 3 munchkins on Friday, and then it took Friday, moved back 6, and replaced it with on top of a mountain. So again, this actually makes sense. I ate 3 munchkins on top of a mountain. So all the crap that we did, we now got the world's dumbest sentence. So guys, not only do you know how to work with random access files, but you also learned what the world's dumbest sentence was, and that is I ate 3 munchkins on top of a mountain. So now that your brain is filled with this useless information and also some useful information, we can move away from files and onto functions. So that's what we're going to be covering in the next tutorial, and it's actually a really cool part of C. So I don't know, I'm going to stop talking now, go eat some munchkins, see you later. Alright guys, welcome back, and in this tutorial I'm going to be teaching you guys about functions. Going to be pretty sweet, and it's actually really important in C programming. So, well, let's go ahead and get to it. Now, before I actually start typing all the syntax and the code how to create a function, I want to explain why you would ever want one in your program. You see, the programs we made right now were kind of simple. Some were pretty long, like some of the demonstrations, but most of them were really basic. However, whenever you're making an actual program or a piece of software to sell to some company or just for a company, you're going to have a lot of code, and it's really useful to break it up into smaller bits just so it's more organized. So functions allow you to break your code up into smaller bits and organize it really well. And also, another cool thing about them is what you can do is you can write a bunch of code and write it as a function, and then you can use that function whenever you want. You don't have to rewrite the code over and over and over again. So alright, they sound pretty cool, so let's go ahead and create one. Now, I don't know if you remember from like the first or second tutorial, but we already have a function created in our program. It's this main function right here. So pretty much every single program in C is made up of one or more functions. The one function that it has to have is this main one, and it's the first function that gets called whenever your program opens. So whatever in here, between these curly brackets, is the first thing that always runs. So outside of these curly brackets, this is the area where we can create a new function. Now, there are a couple different pieces that we need to remember whenever we create a function, and we can see up here, the first part is a data type. Now, there are some functions that are just going to do something like print something out on the screen, and there are other functions that are going to do something like calculate a number, like you're making a calculator and adding two numbers together. So whatever that function does, it's going to give you something back, like the sum of a number. In this function right here, it returns 0. Pretty much means give you back a number. However, for the function I'm going to show you first, I'm just going to make a really easy one that just prints something out on the screen, so it doesn't give you any numbers back or anything. So whenever you make a really simple function that doesn't give you anything back, just put void, and it pretty much says, hey C, we're making a function, it's going to do something, we don't want anything in return. How generous of us, right? So after that, you can name your function anything you want. Of course, just like variables, don't start it with any stupid symbols. So this is just going to print something out on the screen, so I think it would be appropriate to name it print something. Easy enough. Now after the name, add two little parentheses right now, and in the next couple videos I'm going to be talking to you guys about what you're going to put inside those parentheses. But for right now, don't worry about them, but you need to have them. Again, you'll understand later. And the last thing is two curly brackets. Now, of course, we already know that anything that we want our function to do goes in between those curly brackets. And this is just going to be a real simple one, so print something out on the screen. What am I going to print? I'm a function. Now another thing I want to point out is, even though this function isn't like calculating any numbers and giving us back the answer, every single function needs to have a return statement. So what return means is pretty much, we're done with this function, return to the rest of your program. So again, whenever you get an answer back, you're going to have return the number, return something else, but since this is just printing something out on the screen, you just write return, and it pretty much just means I'm done with this function, go back to something else. Easy enough. So we have this function right here called void print something that prints I'm a function out on the screen. So let's run this bad boy right here. Alright, where is that text? It didn't seem to print out, and this is why. So check it out. You know how I told you that whenever a computer program runs in C, the first thing it does is it looks to this main function and it runs any code in here. Well, that's what it did. It looked in main and said, okay, la la la, return 0. So that's all our program is doing right now. So even though we have this function called print something created, we didn't tell our program, hey, we created this function, now we want to actually use it. So what we need to do is, in order to use a function, just copy the name of the function and the parentheses after it and paste it wherever you want to use it. So right there, it's going to say, okay, when you get to here, go to this function called print something and print text out on the screen. Now, before I run this code, there's one other thing I want to talk to you guys about, and I know that this is a lot just to use a simple function, but this is the problem that we have. Computer programs, as you already know, they run from top to bottom. So that's why this line occurs first, and then this line, and this. So it makes it simple, just like people read, it runs top to bottom. So this is what's going to happen with your computer. Whenever it runs this program, it's going to include all these built-in functions, and then it's going to say go to main. So it's going to start running main, and it's going to say, okay, print something. Wait a minute, I don't have that function in here. What the heck is this? Is it a variable? Is it something you make? What the heck is it? I don't know about this. So since C is eventually going to get to this line and not know that print something is a function that we made, we need to actually warn it above that, hey, whenever you get to print something, it's actually a function that we made, so look for it somewhere else in our program. And this is called prototyping your function, and it's really easy to do. You want to prototype all of your functions that you made yourself above main. And to prototype it, just copy the return type, the name of the function, and the parentheses, and paste it right above main with a semicolon afterwards. So what our program is going to do right now is say, okay, first thing, include all these built-in functions like printf and stuff like that. Then let me scroll down. Okay, so right now you're saying you made a function called print something. So now whenever I run across it in your program, I'm not going to get confused. I know that it's a function. So of course then you just go to main because it's the first thing it does. Scroll down here, use this function print something, which prints something out on the screen, and pretty much that's the end. So let's run this and check it out. So that's what it did. It just did it incredibly fast. Now remember that I told you guys the cool thing about functions is you can write them once, write any code you want in there and use it over and over again. Well, to use it over and over again, actually let me throw a new line on here. All you do is paste it as many times as you want. So run this and check it out. I'm a function. Pretty sweet. So right now, obviously this wasn't very useful. If you're making a simple function like this, you might as well just print this line out right up here. But I just want to show you guys the concepts of a function is basically reusable code that not only helps organize your program, but code that you can use over and over and over again really easily. So now that we got the boring crap about functions out of the way, we can begin doing something cool with them. So for now, thank you guys for watching. Don't forget to subscribe, and well, I'll see you next time. But Bucky, the only thing I've ever wanted to do was learn about global and local variables. That's what everyone always tells me, you know, since they're from, England or Australia, whatever the heck that accent was. So, to all the people who asked that, let me go ahead and teach it to you right now. So, there are two main types of variables, or scopes of variables, that we're going to learn in this tutorial. One global, two local. What's the difference between them? Well, don't let the words global and local confuse you because I'm going to explain it real quick. This is the rule for using variables in your program. Whenever you make a variable like int tuna, outside and above all of your functions, any of your functions are allowed to use that variable. So main can use tuna just like a normal variable. Print something can use tuna just like normal. So when it's above your functions, any function can use it. Now, whenever you make it inside a function, only the function that it's created inside can use it. So for example, if print something wanted to use tuna, it wouldn't be allowed to. Okay, so when it's inside a function, only that function can use it. When it's outside, any function can use it. Now, just so it sticks in your brain, let me go ahead and make like a 2-second example. So, enough of the tuna. Let's be like warts. So we'll set warts to, how many warts do I have? 23, and that's only on my forehead, believe it or not. True story. 23 big ones, size of baseballs. Alright, so remember I told you that anytime you make it outside, any function can use it, so let's do it right now. So printf I have, it's an integer, so %d warts. And might as well kick that to a new line. And for this, we're going to put warts. Looking good. And also, I got rid of the print something. So right now, if we just ran this, print something would never be called. And that's, remember that I told you that whenever you want to use the function, put the name, parentheses, and then a semicolon, and that pretty much goes down to here and calls whatever's in there. Well, whenever I say calls, it's just a technical term for using the function. So, you know, just some little programming lingo. So right now, I'm going to call print something, and we'll see if that can use warts as well. Alright, so I have 23 warts, I have 23 warts. It was able to be used from each of these functions. So, what happens if we accidentally made it right in here? Well, what would happen is it would say, okay, I am main and this warts variable belongs to me and me alone. No one else can use it. So when print something tries to use warts right here, and check this out. If we look, it said undeclarative I can't even freaking talk. Pretty much it's saying, hey dude, we don't have a warts variable and there's none out here to use, so you can't use it. And again, one last time, whenever a variable is declared out here, it's called a global variable. And whenever it's created inside a function, it's called a local variable, local to that function. So now you know about global and local variables. Congratulations, I'll see you later. Alright guys, welcome back, and in this video we're going to be done with coding these stupid little rookie functions. It's time to step our game up a notch because I'm going to be teaching you guys how to pass arguments into functions. So what the heck does that mean? Well, sometimes your function is going to need an extra piece of information in order to work. And by that I mean if it's calculating the weight of something, or in this video I'm going to be showing you guys how to take any amount of euros and convert it to US dollars. So of course the piece of information that you're going to need to give your function is how many euros do you want to convert. So again, it's not just going to print something out on the screen and do the same thing over and over again. It's going to take a number in this case and convert it. So it's going to be pretty sweet. So it's better if I just shut up and actually do this. So first of all, what it's going to do is it's going to crunch the numbers, whatever value you give it, and just print it out on the screen. We're not getting we're not returning anything back to the function. So just write void. And in the next video, I'll show you guys what happens when you actually do return something back. But for right now, let's just stick with the basics. So like I said, what we're going to do is we're going to give a euro amount, and it's going to convert it to dollars. So convert to dollars is probably an appropriate name for this function. And what piece of information does it need from the user? Well, it needs a euro amount, and I'm just going to put that as a float, since it could be like 1.5 euros or whatever you call them. I know it's a float. Give me a break, guys. So basically in here you're making a variable. What type of information are you going to be passing in? Well, it's going to be a float. And what do you want to call the variable? Well, just euro. We know how to make variables. So after this, of course, your curly brackets, we have to first, let me add that return statement so I don't forget. Now, what I want to do is, since we already have a variable for euro, I also want to add another one for float USD. This is pretty much going to be our answer. And the formula to convert euros to dollars is just take whatever amount euro and multiply it by 1.37. So pretty freaking easy. And now let's just go ahead and print something out on the screen. So printf, and this function will just say, we can format it like %f to 2 decimal places, euros, and then we'll put a little dash in. We'll say that what it was in USD or US dollars, and we'll kick it to a new line. So of course the first one is euro and the second one is US dollars. So very simple stuff. What we pretty much did is we created a function that takes any amount of euros converts it to dollars, and prints out the result on the screen. So now we just need to do the boring housekeeping stuff. Say, when do you want to use this function? Well, right around here is good for right now. And then, of course, we need to prototype it, so whenever our program comes across it, it doesn't get confused. So now, of course, we're using this function right here, and we actually don't want that in there because that's just a variable. What we want to do is we want to give it some euro amount. So make a new variable right up here. I'll just name it like euro price 1, and we'll just test it out really easy to make sure it works. So basically, say that we have €1 and we're traveling overseas, or at least I live in America, and we need to know what the US dollar amount equivalent of this is. So what I'm going to do is I'm going to take this value, which is equal to 1, and I'm going to pass it as an argument into this function. So this pretty much says run this function right here, and for your placeholder use this 1. So wherever this euro is, it pretty much treats this variable euro as 1. So it's going to say, okay, 1 times 1.37, let's run this bad boy and check it out. 1 euros equals 1.37 US dollars. Pretty sweet. Now another cool thing is this. Remember that I said that you can use this function as many times as you want without having to recode everything? Well, this is actually one of those useful examples. Say that we have, I don't know, 5.5 euros. We'll name this variable euro price 2. Well, we can just do something like this. Do this one for 1 and do this one for 5.5. And how awesome is that? No need to code this over and over and over again. You can do this as many times as you want. Piece of cake. And actually, to tell you the truth, you don't even need a variable name at all. Since this euro price 2 and euro price 1 is equal to a float, you can actually just pass in a float right here. So what if you had, I don't know, 21.3 euros? Well, what this is going to do is just going to say whatever value's in here, treat it as euro. Pretty freaking awesome. So again, that is how you pass an argument into a function. Again, an argument is just an extra piece of information that your function is going to need. So, well, plain and simple, that's how it's done. Hopefully you guys understand. If you don't, then ask me in my forum and I'll be happy to answer it for you. Also, if you want the source code for it, then look in my forum. All the source code's there. You probably already knew that. Anyways, thanks for watching. I'll see you next time. Alright, in this tutorial, we're finally going to learn about the return values. It's going to be freaking epic. So basically, a function can do one of two things. It can just go ahead and plain and simple run whatever lines of code are inside it, like print something out on the screen, tomato, or what it can do is it can calculate some equation, a bunch of numbers, and give you back the answer. So up to now, we just been putting void, which pretty much means just run whatever lines of code are inside the function. But right now, what I'm going to do is I'm going to make a function that's going to run some equation and return an integer. And we'll say that this function is for, I don't know, like a company that wants to calculate the bonus or the extra money that its employees get at the end of each year. Maybe a Christmas bonus. Who knows? Who cares? So, of course, whenever it does this, we're going to want an answer back so we can use it later on in our program. I don't know, maybe like to write on their paychecks or store in a database or something. Anyways, so I'm just going to name this calculate bonus, and this is pretty much the same as before, except instead of void right here, the first thing you write is what type of data are you looking to get back. Well, we're looking for int. We'll say that we won't worry about the cents. We're just worried about the dollar amount, so int, which would be the dollars. And of course, their bonus is going to be dependent on, we'll say years worked. So the longer you work there, the more, or the higher bonus you want, or you're going to get, however you want to say it. So now we have to make some stupid formula. So say the bonus or the extra money they get is equal to how many years they work there times, I don't know, what's a good amount? $250. I'm a generous boss. So if you work there for 2 years, you get 500 tomato tomato. And actually, let's add one more condition. So we'll say if you work there for over 10 years, then we'll give you something else. So bonus plus equal to 1,000. Alright, so sounds like a pretty sweet company to work for. So basically, you're going to take the year's work. For each year worked, you get $250, and aside from that, if you work there for over 10 years, you get an extra $1,000. Pretty freaking sweet. So up to now, what we did is we pretty much just hit return, and return meant, okay, I'm done with this function. But whenever you return anything other than void, you actually can't just write return semicolon. You need to write, what are you returning? Well, in this case, we are returning or giving them the answer, which is the bonus. So that's the main goal of this function right here, to calculate the worker's bonus. So I'm going to return that, and now this function is complete. We just need to do our housekeeping stuff. So again, the first thing we need to do is prototype the function. So copy this, paste it up here, and now whenever your computer runs across it, it won't get confused. It knows that this is a function that we created. Now inside main, let's just go ahead and call this function. So what I want to do is I want to calculate the bonus for 2 employees. So of course, whenever I calculate the bonus, I'm going to store it inside a variable. So the first one will be the bonus for me, which is Bucky's bonus. And again, I'm going to set this equal to, actually I can just calculate bonus and then the number of years that I worked there. So I'll say 14 years. So what this is going to do is it's going to say, okay, go ahead and run this function right now, which is calculate bonus, and treat years worked is 14, so 14 times 250 plus an extra 1,000, and return that entire value as this. So right now, whatever that value is, it's pretty much in place of this function right here. So that value gets stored in Bucky bonus, so now we can use it anytime we want in our function, as many times as we, or anytime we want in the rest of our program. So let me do that right now. So now Bucky bonus is equal to some dollar amount. So let me find out how much money I made. So Bucky gets, and I'll put $ and %D. And do I want to add anything else? Nah, that's probably good. So Bucky bonus. Actually, let me code one more real quick. Say that there's someone else. I'll put something less than 10. So say there was kind of a new chick that started working there called Emma, and she's only been working there for, I don't know, 3 years. Easy, right click. Alright, so print out Emma right there, and everything looks good. So now let me go ahead and run this and check it out. So, not bad. So my bonus was $4,500, and Emma only got $750. Alright, not bad. I mean, it sounds fair to me. So one more time, this is what happened. Whenever you use return values, what it does is whenever you call the function, it pretty much calculates the function, and whatever it returns, it sticks in place of right here. So right now, all this code that I highlighted was pretty much equal to 4,500. All of this code is pretty much equal to 750. So now you can just store it inside a variable, or you can even do something like this. Since this is equal to 750, check this out. And let me put this for Bucky's bonus, and we can even delete these lines altogether if we want. So now we're going to run this. Check it out. The same thing. So pretty much the conclusion of this tutorial is whenever you return a value, it pretty much return or trades that function call for that value and you can use it just like you would the variable itself. So hopefully you guys understand. Again, it's not that it's not that complex. Once you like practice with 3 functions, you're gonna get the hang of it. You're gonna be a pro. But for now, thank you guys for watching. And the next video, guys, it's the series finale. So make sure to stick around. I'll see you then. Well, guys, you finally made it to the very last tutorial in this little series of C beginner programming tutorials. Congratulations, we only have one last topic to go. Now, this is actually a topic that I wanted to make sure to cover before I finish this tutorial, and this is actually something that confuses a lot of people, and I think it's just because they don't really understand it, or it isn't taught to them in a very good way. So what I want to do is I want to show you guys a really simple example of the 2 different ways that you can pass variables into functions. They're called pass by reference, or some people call it pass by address, and also pass by value, and the difference between the 2. So since you can pass variables into functions 2 different ways, what I'm going to do is I'm going to make 2 different functions to demonstrate that. That seems like a logical thing to do. So the first one I'm just going to name pass by value. And actually, what I'm going to do is I'm just going to code these because it's going to be kind of confusing if I try to talk you guys through it before you actually see what the program does. So for right now, just follow along. So pass by value, we're going to throw a variable in there called I, and we're just going to set it equal to some number. And this is going to be like 20 originally. We're going to set it equal to 99, and then just return. So again, all this does is it changes I, and that's pretty much it. So that's pass by value. Now the other one is pass by address. Now in here, we're going to make another integer, but this is going to be a pointer to I. So what this is going to do is, of course, whenever we do that, we need to dereference it. So that's pretty much going to be the memory address of I. And we'll set this equal to, I don't know, set it equal to something random, different than this, so we can see which one of these functions did what. And then, just like before, return. So right now, we passed in a variable, and then we passed in the memory address of that variable, essentially. Alright, so the first thing that we should probably do is prototype these before we learn about, you know, the differences between them and all that good stuff. Alright, so we got the boring stuff out of the way. Now, let's get to the heart of this tutorial, and that's this. So there are basically 2 different ways to use your variables and functions. So the first thing that I actually want to do is make a regular integer variable that we have to use, and of course we have to name it tuna. If not, our computer is going to crash, and I'm just going to set this equal to 20. So we're going to take this tuna variable, which is equal to 20, and we're going to pass it through these 2 functions, and we're going to notice some kind of weird differences between them. So the first one is pass by value. So pass by value, and of course this just takes a regular integer, which is tuna, and now let me print out the value of it. So printf, so passing by value, let's show you something like tuna is now %d, and of course that is equal to tuna. So I just run this real quick just to make sure no bugs so far. Alright, 20, simple enough. Talk about that later, and probably don't want to copy that. So the next thing I'm going to do is pass by address, and of course if we look down here, what it does is it takes a pointer, which pretty much means it needs a memory address because this points to a memory address, so we actually need to toss in the memory address of tuna. Alright, that's interesting, and paste that because I'm lazy. And passing by address, tuna is now %d. We're just going to print out the value of tuna again. So pretty much right here, we set tuna equal to 20. I mean, we did this since like tutorial number 3, and then we use this function, printed it out, and then use this function and printed it out again. So check this out. The first function, it takes that I and it sets it equal to 99. In the second function, it takes the memory address and sets it equal to 64. But if we look right here, the first function, it looks like it didn't even do anything. I mean, it was 20 to start with, and then it's still 20 after we called this function. The second one was the only one that actually changed a variable. So why is that? Well, I'll explain it right now. So, like I said, we can use functions in one of two ways. The first thing we did right here is we pretty much pass by value, and that just means don't actually pass this variable itself. Just get the value that it's equal to, which is 20. So essentially what it did is this right here. It passed the value of 20 in. So whenever we ran this function, anything that happened in here, it didn't ever affect the variable. It just affected the value of 20. So he set, I don't know, I, some stupid variable equal to 99. Again, this variable was left untouched. And this is called passing by value. So if you ever want to run some calculation, and this is actually what you're going to do most of the time, but you want to leave the original variable as is, you can run a whole bunch of calculations and never mess with this. So that is why, even though we ran that function, when we printed it out, it was still equal to 20. Now this next one right here, there are going to be certain times where you actually do want to change this variable. So what we did whenever we pass by address is we pass the memory address in, and that actually takes this variable wherever it is in memory and it passes it into here. So now whenever we change it to something else, it's actually going to change that variable itself, not just like a copy of it. So what we did is we took that tuna variable, we passed it in here, and we set tuna equal to 64. That's essentially what we did. So now tuna equals 64 after this is said and done. So now whenever we print it out, again, since we hard-coded that right into the memory, that's where it says by whenever you pass a function its address, it actually changes that variable. So again, the value just passes a copy of it, and whenever you pass the address, you pass in the variable itself so you can tweak it. So hopefully you guys understand. I know that was it's kind of a hard concept to understand at first, but once you do it a few times, like anything else, it gets second nature, and all these weird symbols like ampersand, memory address, pointers, they're going to become really easy. But for now, thank you guys for watching. That is it. We finally made it. You are now capable of pretty much making any C program. The only thing between what we learned and making a large piece of software is just putting the pieces together. So hopefully you guys have the knowledge to figure that out. If you ever get stuck on anything, then go to my forum, ask me. I actually like to figure that stuff out, and I like solving problems. So again, one last time, thank you guys for watching. Don't forget to subscribe. Check out my other videos. I'm going to be filming Python next, my favorite programming language. So well, hopefully I'll see you there.